Hello. So good morning, everybody. It's a great pleasure to have all of you guys here. Today we have a very interesting section about telesurgery, the trial that we're doing with Angola, and we have all experts here to talk about connectivity, FDA approved protocols. We have some other experts in the robotic surgery field and the telesurgery. And we will start our program here talking with Alex speech here, talking a little bit about the MicroPort robot. Alex, please. And if you guys have any questions, I would like to have very interactive section so we can discuss and we can talk a lot about it.
Thanks, Michel. Marcel, yeah, so old friends. So telesurgery, we're exciting to see the moving development of telesurgery. So here we are talking about this one click, which we already planning this for a long time, but we just achieved this recently. Kind of the latest progress for our telesurgery. So yeah, title is one click promote telesurgery to the next chapter. Yeah, I'm founder and CEO of MedBot. So actually, outside of China, especially in Europe or US, lots of people still concerned about the meaning of telesurgery, but it's not a problem at all. Actually, that is what, for the first beginning, the meaning of why MedBot choose telesurgery as our most important innovation direction 5 years ago. Because this kind of uneven distribution of medical service problem of China is the most difficult headache problem of China medical service system. You can see, that's a normal picture of Chinese hospital. So patient cannot find a good treatment in a local hospital. So everyone moved to Beijing, Shanghai province capital to find a good hospital, good surgeon, because local hospital do not have the ability to perform complex surgery anymore. And meanwhile, the hospital is so heavy that surgeon perform 9-10 cases every day, like Orlando Hospital. But that is for every big hospital in China. And patient even cannot find a room for bed. So, and telesurgery is a key technology, the bottleneck technology to solve the problem of China. I mean, we just learned from recently experience that for country outside of China, emerging countries, that problem is even more severe than China, because in China, at least you can find a hospital in big city, but in country in Africa, all this continent, you cannot find a good surgeon.
You see what I mean? I mean, if you show the East Coast there to have loads of hospitals,
yeah.
Of course everybody lives there.
Yeah.
So
percentage.
A better way to show is that you normalize it by population to see where really the problems are.
Yeah. Percentage kind of thing. Yeah. So the main idea or contribution for MedBot is we build the conception of 6th generation telesurgery. which is a key. So before us, there are some attempts regarding telesurgery based on dedicated line, optic fiber. Everyone think about we should rely on dedicated line, but we come up with an idea that for large-scale clinical application, we need to establish a fundamental technology that allow us to solve several problems. One, the key is compatibility for multiple network. We need to exist working on existing hospital infrastructure telecom connection, not dedicated line. And also, we need to think about larger distance. At that time, there's some, in China, there's some several hundred, 1,000 kilometer trial on human, but no large scale distance. And also, but we are glad to say after 5 years, very difficult in-depth technology development, and also after that, very exciting, but you need to be very careful, clinical exploration. We can say that so far, right now, telesurgery have reached the critical point of breakthrough. That's for sure. So totally, we have done more than 400 cases. And for lots of regions, we are the first one in history that did telesurgery. Africa, Middle East, Europe, and also Latin America and lots of regions. And in the meanwhile, we work with, after we enter into clinical stage, we work with China authority, we draft the first standard and also clinical guideline for telesurgery. And also 2 months ago, we get FDA approval. This is the first regulatory approved telesurgery product in the world. And also actually in Chinese medical service system is the first product that we built the concept by China and get the approval by China first. So kind of, at least in this area, the innovation happens in China. And also recently, thanks for FDA, gave us approval for our IDE trial to Angola. So. It's for the clinical trial from Orlando to Angola. For the specific,
I have a lecture.
Got it. But not US.
Not the US. Yeah. It's just, yeah.
I will explain a little bit in my lecture, but basically the FDA was involved because as soon as you apply for the IRB and the machine is not an FDA approved in the US, it matters because you're doing something in humans on the other side, no matter if it's in China, Japan, or Australia. So as soon as the machine is not FDA approved, you need to apply for the FDA protocol to kind of evaluate all the standards, the security standards. I'll show some details in my slides. And then they approved one case, and then they reevaluate all the results, and then they approve all the rest according to your protocol.
Yeah. So yeah, after all this current stage, we are saying what's next. What's the innovation? What will move telesurgery forward? Actually, we already have that answer or direction back to 2 years ago. That time, Dr. Patel visited Medipod headquarters, and we discussed lots of things. So yeah, this is a picture we are discussing. So one of that is Dr. Patel mentioned that the vision that we should connect the different continents together, and we switch from candidate to candidate. So that is the original idea. So afterwards, we are thinking about trying to work on this. Yeah, here the result. So like the technology we have a map, an app you can switch on your cell phone. You can monitor. We have also a control center software. You can monitor all this kind of connection. You can monitor the delay and all data quality of the data, performance, and also even the IP, detailed IP, where the signal goes to, where it's connection. And also you can see we have 5 sites connection, so we can switch using the click on the app or even or on the console. So yeah, that is the idea. So so basically, the meaning of this is we transfer from point-to-point dedicated line or point-to-point connection to multiple content surgical network. So that's the purpose. So not dedicated line, yeah. In dedicated line, it's very difficult to do that because it's based on point-to-point technology. And you need to plug out the cable and do the connection kind of thing. So it's a network. It's based on a different connection, have different technology. In China, we are using not all we call the cloud telecom technology, and outside China they are different. So yeah, so also we did the meaning of this, like we just discussed before, the cost of this kind of normal network is kind of 100 times cheaper than dedicated line. Also not just that, also the time to set up the whole system. For dedicated line, you need to do at least half a year. And for this, we only need 2 weeks. So that's the difference. And also, yeah, because you are using the normal network, so distance would be easy. So yeah, so also, of course, we need to think about data security, especially for the dual and multiple connections. So you need to have more strict, more systematic technical solution for security. So we have done lots of things to make sure the network is safe. So it's more complicated than even our before telesurgery network. So so that's a key feature. So during the past experience with same distance, we can say the delay is reducing. For example, original connection from Shanghai to Orlando is around 260, 280, and right now we reduce that to kind of 160, 180. And also, all of our idea is based on we call the multi-network fusing. We are not rely on one connection. We can work with 5G, 4G, even 3G, and also, yeah, we have lots of technology to reduce our requirement for a network. So people are thinking about telesurgery, just use network to connect the 2 robots together. That's the right thing. We have lots of things after that. So we need to reduce the requirement of the network because the network is out of your product. So if we can use technology to reduce that part, that will make your telesurgery technology can be more useful and compatible better with the network. Yeah, so right now, yeah.
Can I ask you a question? You said the network is out of the device, which of course is true.
Yeah.
In all the regulatory exercises you do around the world,
Yeah.
have the regulators asked you to consider the network to be part of the device, or was it always treated really as a separate construct?
It's treated as a separate construct. Yeah. Why? Because it actually in China, let's just because we have lots of long discussion with China authority, it's even in charge of by different department of China. So one in industry, telecom.
That makes sense. I mean, the ownership, of course, commercial ownership,
Yeah.
different.
Yeah.
I mean, my understanding is, Norma, correct me if I'm wrong, in the US at least, the FDA would say, you need to prove that the construct, your device, network, your device, acts as one thing.
But the problem is a medical company as us, you cannot control that telecom. You can control technology. You can control your hardware, software, or your robot. You cannot control the.
We all agree with you. That's the conundrum we have a bit in telesurgery.
Yeah. So, but the solution is the China FDA gave us a requirement standard for the latency server performance. They gave us approval if the telecom connection is under that requirement. So for example, I believe right now the latency they gave to us is 110 milliseconds. So they gave us approval if the network delay is below 110 seconds.
Who came up with the number? Who came up with the metric? Was it the authority that told you, the company, that
Wait.
this latency?
That is established by us. Yeah, we use lots of testing standard and
Proposed that value?
and they gave us approval.
Go ahead and demonstrate.
Yeah. And also for our clinical trial, they ask us for lots of cases, so it should be relative to that number. So from technical testing and also from clinical results to prove 110 milliseconds is good enough. Yeah.
So what I'm concerned with, all politics is local, is your telecom equivalent to the FCC doesn't have to approve. Because the FCC, the telecom
Yeah.
authority in China,
No.
they don't have to because they don't know about that they should, or
Yeah.
they don't.
What we experience is they involve in some part. So there is a governmental research center for telecom technology. They involve in the standard, the testing technical standard of this our work. So they are working closely with NMPA, but for the final approval, they do not give any approval. They establish the standard. Yeah, so this is kind of the network we are trying to establish all over the world. A red dot is the one we are already do some collection and on robot, and the blue dot are the one we are testing virtually. Yeah, so right now we are using this network connection to promote our international telesurgery. So after that, based on this technology, our first clinical testing of the technology is one we are using in China. So the hospital in Shanghai, and we connect 5 hospitals together. The 5th one is kind of 3,000. The delay of that is kind of 50 milliseconds, and the shortest one is kind of 50 kilometer, and the delay is 10 milliseconds. So, and all of this is based on 5G in existing network. Fixed. Actually, the 5G is only the tower to the machine. The main. Yeah. The main connection is telecom infrastructure cable. Yeah.
Question to you, I think what Owen means is, are you using the public 5G, or do you have, say, fixed wireless, public mobile 5G, public fixed wireless access 5G, or an indoor private 5G? Like 3 options.
It's based on kind of public, but we work with the telecom company, have some optimization. Yeah. So you need to work closely with telecom company. They should do lots of changing. For example, originally we are using the normal one, but during lunchtime, everyone's moving around using their cell phone. The network quality reduced. That's a problem. Yeah, we have a video to present. Can you click help me?
Imagine now you can help people all over the world at the click of a button. We'll be performing a robotic prostatectomy for a man in Angola who otherwise would not have access to high-end surgical care.
the control center in Orlando. Marcel was operated there, and click on the console, so we build the connection, and we monitor the communication data, and operate to Kuwait. Then we switch to Angola to finish the operation. Then we switch to Brazil. And Strasbourg, France. And Shanghai. Shanghai is the longest one. Yeah, so that is how it works. So use that technology, we can connect different countries together. So actually, so in that case, based on that, actually that is the normal application that telesurgery will become. So experienced surgeon can focus on the important part of the surgery. For the junior surgery, surgeon just finish the simple task steps. So yeah, based on that, we can promoting our global telesurgery network. Yeah, thanks.
Thank you, Alex. Thank you. We're going to proceed for the next section. Misha, he will talk a little bit about the connectivity, the details, and the magic of telesurgery here.
All right, let's get going. Morning, everybody. So I thought I'll zoom out a little bit, give you a bit of context, why we do certain design conditions, and I'll just talk you through maybe some overview of things, how we started to look at it from a requirements point of view. So from all the procedures out there, and I'm not a medical doctor, so excuse me if I'm using terminology wrong here, but yeah, from a business point of view, we thought it would make really sense to look at least at the endovascular and neurovascular interventions, simply because of the high stroke and heart attack cases, as well as, very emergent laparoscopic interventions, as was just presented by Alex. So that was a bit the two taxonomies. We looked at what type of networking requirements would be out there. Let's say the high bar. If we had perfect networks with perfect requirements, what are the numbers we need to hit? And it turns out it is different between both procedural families. It is even different within the same family, between different procedures, and we have a lot of wiggle room. So you just heard that Alex's team had been optimizing things from a commercial point of view, but it's not as easy as it sounds. But anyway, so we have from a networking point of view, turns out that the endovascular and neurovascular are much more forgiving because it's a fairly straightforward procedure of in, out, and torque. And the round-trip latency actually could be potentially quite high until the surgeon notices there's a network in between. But from a data rate point of view, it is not forgiving at all. The reason is because we're transmitting very high resolution CT scans in real time with very, very, very fickle imaging, let's say, of the brain or of the heart. And using compression is quite a dangerous thing to do there because most compression algorithms are lossy compression algorithms. So you compress stuff. From entropy, you lose information, and then you decompress it on the other end. And what happens, as an example, if you were to use the new NVIDIA algorithm to do that, you may lose, actually it may hallucinate, the same as ChatGPT hallucinates sometimes. The decompression may hallucinate, and it may just remove a vein in the brain or just add a vein where there's none. And then the surgeon thinks he or she is somewhere in the brain, but actually it's not happening. So the lossless compression is hugely important. And in Alex's presentation, I'll show you pay attention, he emphasized as lossless, hugely important. So that's really important. And then from an outage point of view, also because the endovascular is quite slow, a few minutes per year is okay. And, I always give the example, if you're in the midst of an operation, you don't want this to fail. But you have a bit of time, and I know that Ryan Matter, who will be speaking at the Congress later, they have an out-of-band telephone just in case if the network goes down, the local team at least can intervene. But we have time. For the laparoscopic interventions, because you're chopping, you don't have so much time. We're talking about seconds per year. All of us have experienced outages from your Wi-Fi routers and from fiber at home. You know how it is to be an outage, and we're not talking about minutes. We're talking or seconds. We're talking about hours per year where your network is down. It happens. It hasn't happened yet in any of the telesurgeries. Why? Because the density of these surgeries is very low. As we scale up in numbers of cases per year in a hospital, you will hit an outage. We don't want to have our community to be in that. So we need to really pay attention that we keep that at a very, very low outage. So we started with that. And we started to look at blueprints, meaning can we have a generic blueprint from a network connectivity point of view, which works for most, if not all cases out there, right? So from a networking point of view, it's very simple, actually. You connect a surgeon with a patient, and there are 5 segments. The first one is in the hospital. You can do a lot of data acceleration in the hospital, and image compression, cybersecurity, all takes time. If you don't have the right gear there, the right infrastructure to do all that losslessly image compression, good security within milliseconds, that's all. These are all milliseconds you're losing to enable the actual distance, right? So therefore, in the hospital, a lot of stuff happens. Then there's what we call the access networks, meaning how do you get the data from the hospital to the long haul fiber infrastructure, right? So in the end, we all use fiber, whether you use 5G or not, doesn't really matter. The long haul is transport fiber. In between hospital and that long-term transport, we have access. And there you have a lot of choices, okay? You could use satellite if you wanted to. Has to be a low orbit one, so it has to be LEO. Currently, Starlink is very choppy, so I don't recommend it to be used yet. But if they can really stabilize latencies, you can have a very, very low latency access, right? So satellite's possible, 5G is possible, and fiber is also possible, and/or a combo of all 3, right? So you can handle it as you want. So therefore, we have that access. It goes then over the fiber with potentially some cloud control, and then it ends up on the access on the other side and then goes to the hospital. Yes, Lou?
Can it automatically decide which one?
Yes, yes.
That's automatic.
So we have, Alex maybe can comment if they have done this. Ericsson, my company, we do have a solution where we have an industry-grade switch-through router, which keeps all the lines you connected to hot. So if you have one 5G, 2 5Gs, you can have 2 5Gs as an example, 1 fiber, they're all hot. They could be used at any point. And if fiber goes on outage, it automatically switches over to 5G. If that goes on outage, it goes to the other 5G. So you essentially, we have a millisecond industrial grade router which can do that. So you wouldn't even notice that. And my recommendation is to use, if you really want to do it well, have at least 2 links, if not 3 links. Use them all simultaneously, actually. You know, don't keep them as a backup. Use them simultaneously so you have that redundancy in the link. Yeah. So, and in fact, it's the only way of reaching outages of a few seconds per year. There's no other way. If you just use fiber, you will never get to these numbers. So you need at least 2 systems at the same time to operate. So we have that. And then working with the hospitals, I realized that actually 5G is much cheaper than fiber, because if you want to do fiber well, you need to procure it. You can't just buy your best effort internet, because as you plug your instruments in, and it happens to be everybody wakes up in New York, your bandwidth goes down and you will experience immediately a lot of jitter. You don't want this. You want to have a dedicated reserved line. So the only way to do that with fiber is to essentially call up all the fiber companies and say, hey, give me that dedicated line. What they do is they actually connect your network, not at what we call the IP layer, the network layer. You know, sometimes you type in the IP address, but the layer below. It's as if you put 2 cables physically together. This is how good it's done, but it costs a lot of money. 5G has the same managed benefit, but is much, much cheaper. So in the US, it's about 10 times cheaper compared to fiber. And Alex commented in China, it's about 100 times cheaper compared to fiber. So it's a huge difference, and the performance is almost the same. In terms of latencies, you can do things. I personally don't see a huge business case going forward for international surgeries, to be honest, unless it's for teleproctoring, maybe in the initial years. I see a huge business case for national, even regional state type of interventions, specifically where the operation requires that you do that within 4 hours, let's say for stroke or for heart. Because if you don't have access to the hospital within that time, that's really where telesurgery shines. So, and not all countries need it. So I just talked to some Germans yesterday, or France. You have hospitals everywhere within spitting distance. So it wouldn't make sense. China makes sense. US makes sense. Large swath of Asia, large swath of Africa, and large swath of South America makes total sense, right? But not everywhere. But I see a huge business case going forward, and. We have the numbers, actually. So we did a socioeconomic analysis for Brazil. It's mind-boggling. It's mind-boggling what's going on there. So here we go. And then cybersecurity. Well, that's a blueprinting initiative we're developing as well. How do you get cyber right? And it's a hugely complicated topic. And I realize probably for this audience here, maybe except Omar, who's been briefing all that, that's a bit of an overload. But on the left side, you see what you need to do before you go into operation. And on the right side, you see what you need to do whilst you're operating, right? So one is runtime, the other one is prep time. And it's really building out a proper end-to-end security capability, use the latest encryption protocols, understand that the weakest link is really the link which will actually, potentially break your system. So, and because telesurgery is such a complicated construct between devices, which themselves are a conglomerate of different systems, right? So you have maybe an operating system computer there, which controls your mechanics. You have mechanical devices bought in from one company, put it all together. So suddenly, you have the robotics devices hugely complicated. You have networks. In fact, you don't have one network, you have a segment of networks, and then you have the robotics again. So if a hacker really wanted to go in there, I think they didn't need to try very, very hard if you didn't do that well. So therefore, the FDA, I'm at least familiar now. I helped, on the Angola case, so I know now how the FDA ticks. They were very adamant about really figuring out what's really happening from a cybersecurity point of view. So they want the right network protocols, and you'll be surprised how many people use unencrypted or badly encrypted telecom protocols. It is a nightmare. So, we have now capabilities, with my laptop, if you use TLS1, I hack into this in literally 30 seconds. So this is as quick as you can do that. And you don't want to be in an operation where this happens, right? If you might be the target, whatever, very bad. Then if you have, let's say, Windows as an operating system, it suffers from a lot of vulnerabilities. And they're being monitored and all that. So this needs to be really taken care of. And authentication, hugely important. So you may have a perfectly secure system, but you haven't really thought on how you give security credentials to what surgeon, and maybe your TA or your assistant has a grunch and maybe doesn't really pay attention on how security's been handled. So you really need to make sure that the system is end-to-end fully secure. And then runtime, you really need to monitor that and all that. So it's an uphill battle, but there's a good reason why the FDA is actually very adamant about this. So we are developing this blueprint there. And it's a very loaded slide, but you see in italic, I put below each segment on what we had done with the combo between Nicholson Center and the MedBot capabilities, right? And the telecom companies we work with. So we took everything very seriously. So my last slide, I think, and that's really on how do we make that happen? So we did a lot of trialing actually on the multi-pod router. So Lou, you see there the E300. I'll show you just that one there. That's the router which does the switch off anytime between one 5G, another 5G, or fiber, or even be tested with satellite, 5G and fiber, all feed into the same router. It's hot, all connections are hot. Any of them breaks down within milliseconds, which you don't even know. Right? Super interesting proposition with high-end security, zero. So that works really well. For that specific one, we did from Florida to Angola. It was quite a nightmare to do that. And it was really not easy to do that network right. It took us a long time. Alex is smiling, and and yeah.
How difficult, not difficult, what kind of logistics do we need to have a 5G slice for connection?
Yeah.
Not
Yeah.
in Angola, for any other
Yeah, yeah. So so if you were to go like the 5G route, and I'll come back to the Angola slide in a moment. So the question Martio's asking, that green access link you see here, how much effort would it cost us to engage with the telecom companies to do it? Right now it's a very new technology, so you still need to talk to the telco companies. But in the US, actually, we have T-Mobile and Verizon have enabled slicing for enterprise applications. In fact, if you have the latest mobile phone, let's say the latest iPhone, and you're doing video calls, you're automatically being handed over to a slice. So it is all automatic. In theory, you don't need to do anything. You just go to the shop. You don't even go to the shop. You go online, you buy an enterprise eSIM with slicing capabilities for something like $50 a month, which is very different to the fiber proposition of $2,500 a month. You buy that, it gets automatically set up. You can have multi-bonding. You can say, I'm going to put my kinesthetic control, which is hugely important to me, onto a 5G slice with T-Mobile, which has a good network in my area. And I'm going to put the OR videos, which are less important, on another slice. So you can do that bonding for different slices. Super easy. So going forward, it will be very, very trivial. Now in the transition time, we still need quite a bit of interaction to get that right. So why was that such a nightmare, the connectivity? We got it right in the end, but because we had to segment different fiber providers, that was a real problem. So the issue was we had to go from Orlando, the Nicholson Center, to the capital of Angola, across the Atlantic. Okay, so what we figured out, the best way is to go to an Equinix switching pair point in Miami. It's called MI1, the Miami One. Equinix is you've never heard about this company, is one of the biggest fiber providers. So everybody's doing Forex trading. All the big fiber requirements go through Equinix. They have loads of these server farms, but not so many that you could plug in any hospital easily. There happens to be one in Miami, which is not far from Orlando. So we got first appearing from Miami to Angola, right? So that was fiber, fairly low latency. And then the problem was then the two segments on both ends. How do you get it from the Equinix peering point to the Angola hospital? How do you get it from the Equinix peering point in Miami to Orlando, right? And we could have used then best effort internet, but imagine then, everybody wakes up in Florida and that internet just breaks down, and then it doesn't matter how good your fiber is in between because you're linearly dependent on the internet. So therefore, we made sure we got a managed internet from the Nicholson Center to the peering point in Miami, and literally it was like putting two cables together. They've done the same then in Angola, and we got it's called a virtual circuit. Pretending it's an actual cable. It's as if the robotic surgery companies used a cable to connect both control and patient, and we did the same, but just over a larger distance. But it was a pain point. Contract signed. We could do it because the Angolan government had that deep pocket to do that. But if we want to scale that, that's not the way to go. So you either work with a company like Sovado, which is kind of streamlining that, and/or other providers, who have solutions like MedBot has a solution. We do have, Ericsson doesn't sell it directly, but our partners use our solution to essentially go forward and build a very simple 5G follow-pack solution with fiber. So I think that what you see on the left here is the most flexible and cheapest solution to go forward. But it worked in the end. We got 130 millisecond round trip time. We had a bit of a kerfuffle on the speed of light because initially, we thought the fiber, we don't know how Equinix routes the traffic from point A to point B. So we didn't even know how it goes over the Atlantic. So our working assumption was going from here to here to here. Do the maths, the round trip time should have not below 170 milliseconds. Can't be speed of light. It's 130 milliseconds, right? So I went to log files, it was a long discussion. And so we figured out that Equinix actually has already switched on, new capabilities. So that's where we got the 130 millisecond round trip time. So these are the things you find out when you start deploying. So yeah, it was an interesting. Yeah, lots of discussions. Yeah. And I was very religious about this. I mean, I know you guys don't care much about it, but we can't submit to an FDA some numbers, which clearly, if they go to the depth of this, they figure out it doesn't work. So, but we got it right. It's properly submitted, and it worked all well. So we're working also on guidelines. We did a technical guideline in January was published in one of our journals there. We did one on consensus on medical robot networks in March. Then the Sovato guys published an excellent paper on technical guidelines, and we're currently working really on an expert consensus on a very technical, detailed guideline, so that we're all on the same page on how this should be done, in different regions and internationally. I'm very keen to get a single blueprint up and running, so people don't come to us and ask, how do I connect this specific hospital to this specific hospital? You should just go back to the blueprint documents, tick it off like a logbook, deploy it, and it should work, right? Alex, that would be fantastic, isn't it? Yeah. All right, Lou, yes.
Are there any differences in the difference of opinions in technical guidelines that are still not worked out?
Yeah. Several. I think the biggest one is maybe on, maybe not directly, but fiber only versus a mix of fiber and other technologies. And fiber only works today, but it's a high cost point, and we haven't hit the density of operations to see the outages you can get from fiber. So therefore, I'm preparing you guys for the future where I'm building a much more generic architecture. And I would like this to be the baseline, where you can make the choice. Let me only use fiber, or you let me use a combo of fiber and 5G. So that's maybe the biggest one. And then the latencies and bandwidths, because the community is evolving. For instance, Medbot now implemented something down to 1.5 megabits per second, which is probably a very smart encoding in the spatial domain and the temporal domain. We work with fairly high numbers. As you go lower and lower in bandwidth, you have it much easier to connect basically the endpoints. So. Mm-hmm.
Presented to the authority, and after that, the Chinese authority arranged a team involving us and them, and also the Chinese telecom research institution. And based on that, we do lots of test research, especially leading by the telecom institution. Finally, the conclusion that we should not just optic fiber, and also we improve our clinical trial and plan based on that discussing.
Yeah.
So,
So the verdict was, don't only use fiber.
That's the final solution.
That's the right way to go, yeah.
So the final approval gave us is not just fiber. Any network you can satisfy that data performance.
Yeah. Very good. Yeah, but you are able to use in principle, and we have derived that in that first paper. In principle, you can now use a cheaper fiber connectivity because you have now multiple links to choose from. And in fact, my recommendation was, if your 5G is good in the area of the hospital, use 2 different 5G systems. They give you probably a much cheaper solution. Buy 2 SIM cards for $50 each. It's $100 a month. Still 10 times cheaper than fiber, and run it like that. Makes everybody happy from a cost point of view and also from a security point of view. I didn't know that hospital IT is so religious about not plugging in stuff they haven't seen before. And so when we talked to your IT, they said there's no way we're going to plug that into our operational system. So having a separate network, which 5G in essence is a lifesaver, particularly in these times we're doing these trials and ramping up the telesurgery solutions globally. Oh, yeah. Okay.
Thank you, Misha.
All right, fantastic, very good.
We will proceed. I don't think Benita Ashar is here today to talk about the FDA ID approved. So we will proceed for the next lecture. Actually, it's mine. I'm going to talk a little bit about our experiences in these protocols and everything, Misha.
Yeah.
You can jump one and put mine, please. Back. So I'll talk a little bit what we did. That's a section for like 2 hours of discussion. It's not that simple. It's very, very complex topic. Everything that you guys see, like months and months of meetings, discussions. I was like talking to Misha almost every day and about those challenges, and also with Alex and Microport. Anyway, before any telesurgery here, I think the take-home message, as soon as we were talking about telesurgery, is to have a strong and robust robotic program. This is the most important part here. So any robotic surgery and telesurgery program, we're going to need to address all the potential deficiencies. The topic is not robotic surgery, but I want to address that this is a very important part. They need to have a good robotic program to be proficient in telesurgery. And then you're going to have to address healthcare policies, logistics of the center, anesthesia issues, surgeons, OR staff, nurses, and postoperative care. So each center is going to have a unique problem and issue to be addressed while you're doing telesurgery. So it's not going to the center and build a telesurgery program. No, besides the telesurgery, which is a unique thing, we have the robotic surgery program problems and issues also. So that's what we did in Angola first. So we established a robust training center, Global Robotics Institute, and Dr. Patel, that's our center here. And we established a robust training center over there. So we trained there first. We addressed all the deficiencies. They were proficient in robotics when we did the telesurgery, and we're still training them. That's a few pictures, nice pictures of the Angola team there training with two of our members there, Pete and Timesh, that are doing a great work there. And so it's something that it takes weeks and weeks and weeks if you're in a center without a robotic surgery program. This is the anesthesia team also. We need to train the anesthesia team as well, which is very, very important. All of you know, because telesurgery is robotic surgery, and without any exceptions here, is minimally invasive surgery. So I'm just putting these slides for you guys to see the complexity of a telesurgery program. It's not going there and doing the procedure. We have a lot of things to address. We had several meetings, Patel, Palmer, myself, Misha. We're like working a lot in meetings and studying something that it's very new to us. It was very new to us as well. So it's not something simple. Okay. So then, this is one of the papers on the anesthesia. And then what I want to address is that before everything happened, we did several trials. And this was really important while applying for the FDA. So I really recommend all of you guys that are watching us today if you want to do a robust telesurgery program, do trials, do animal trials, do dry lab trials. So those are all trials that we did. And we were learning. On each trial, we were modifying different things that improved for the next trial. The first trial we did, the first time we connected in Orlando, we got 430 milliseconds of delay. It was Orlando, Dubai, Shanghai, 430 milliseconds. And then we did the first trial here, which is this is Orlando, Dubai, Shanghai, that we reached 430 at the beginning, and then at the end was like on the 300s. This is the first animal trial we did, and then we learned that by changing, Misha can talk a little bit better, that we learned that by changing the relay, the clouds and everything, we can kind of improve a little bit the speed of our connection. So this slide is very important to show every single step we did before we're going to a clinical practice, or before we applied everything. And this data was very important because that was the first thing that FDA asked us. So all of you guys applying for protocols, you need to have data to show them that it's safe, to show them that you know how to navigate in this environment, to show that you know how to deal with delay, how to deal with cybersecurity, et cetera, et cetera, et cetera. And we're lucky to have all experts in robotic surgery and a telecom expert such as Misha, because otherwise it won't be possible if you don't have a big team to do this type of project. And when we're talking about the logistics of telesurgery, we have a testing phase. Testing phase is pretty much after the animal trials, we're connecting the centers that we want to do the telesurgery. So that was the first telesurgery we did between two buildings in Angola Center, 1 kilometer distance. But first you start small, right? And then we start to upgrade the distance and everything. So we did this case. It was really good, but this is the training phase. So that's what we do days and weeks before the telesurgery. So days and weeks before telesurgery, we connect the robot. We simply connect the robot at the same time, every single day, at the same moment that we're gonna plan the surgery. So we're gonna plan the surgery 8 o'clock. We're from 8 to 10, 8 to noon. We keep it connected, doing exercise to see how stable this connection is and how we can address all those issues there. And this is a very interesting chart here showing all the latencies between different places. So Fortaleza, São Paulo, Fortaleza, Luanda, São Paulo, Cidade do Cabo. So that's a very interesting to show how we can expect once you're doing a telesurgery trial between those centers, or if you have these centers included, or you have a third center including these centers, you can calculate a little bit your expected delay. This is the publication of our telesurgery there in Africa. It's an open, it's an access for all members here in the telesurgery at the SRS. And this is the first telesurgery we did in Angola. So it's a very interesting. You see, that's the sound, the real sound of the room, and you see that very interesting. Patel is sitting there in another building, in one kilometer distance. And the robot now, it's not moving, but you see nobody's in the console. That's the very interesting concept. Now you're gonna see the robot will start moving, but there's no one in the console. I was in a room with one of our nurses, with our nurse, Kathy, and now you're gonna see the robot moving and Patel is in another room. So all those trials and those studies, they were very, very important to collect data to show FDA how we're doing. Now, we're doing the same procedure as we were doing normally, regularly talking, communicating, and etc. And when talking about the first FDA approved trial, I think everybody has all questions what's involved. And this is what I want you guys. That was a very, very nice picture. And this kind of is a symbol of everything that we passed through and we've been passing through, because now it's been 30 days of the FDA. It's not that simple. It looks like very nice when we're putting the videos, when we're playing everything, showing all the pictures that we have, but it's not that simple. We had a lot of phases until we could reach there. So I divided basically in this four different steps. First is the application of the IRB. Once you're in a hospital, you need to apply for IRB. And when you apply to IRB, it's not only the study proposal. You need to do the study proposal and informed consent. So a telesurgery trial with another continent, how you're gonna get a informed consent? No, you need to create. So every single step here we created, we discussed, we had several meetings, and we built this protocol from scratch. So that makes more, let's say, beautiful what we did over here. And second, once you apply for IRB in your hospital and you have a platform such as MicroPort that doesn't have the FDA approval in the US, they require you to apply for their protocols because they want to know the standards of security. They want to know how the platform works and etc. So we need to send a lot of documents there. Misha and we had several several meetings to kind of address what we're having because they don't know the platform. And that's the best thing to happen because they want to address security. They want to address the best outcomes for the patient. So that's the second step there. So IRB, FDA are in parallel because the FDA questions, they come through our IRB. So we have a lot of...
On the cybersecurity side, the robot side, you needed the help of the company to answer them. They had to call Misha. Admit that Misha, I don't even understand the questions. Misha, you want to tell them some of the such?
I had a presentation before. We talked about this a bit. Yeah, it's hugely complex, but for obvious reasons. I try to defend the FDA a little bit.
Were there questions though that they just had to ask, or do you
they made sense. Yeah. They made sense. They made sense to me, definitely.
To us, to none of us.
We have a real problem. So.
Yeah, it was another language.
Yeah. Well, it's the same. I'm looking at your surgery, so you don't worry. Alex's team was great, so we did, I think, a good combo there. And so you knew a bit what the,
Yeah, and those are questions that are like, guys, you don't believe the type of questions, like what kind of animal trials you did, how many animals you used, what kind of latency you had in the animal trial. And then in some point they got the manual, they sent me like a PDF of their manual robot. I think I can build a robot now because I read the whole thing there, and then you need to address according to the manual. Page 20, item 2.11, you're talking this, but it was really nice because we learned a lot through this point. And after these two moments here, you need to start the test and connectivity phase. So we need to do a lot of tests, as I said, at the same time that we're going to do the search. So if we're planning to do in the morning, we need to connect the whole morning for consecutive days to see if we have a pattern of fails or anything like this. And then the telesurgery. Okay, the IRB application is pretty much this. More than 70 pages because it's a regular IRB, but it's all back and forth emails. You send all the proposals and then they send everything back and then you need to reply. You cannot reply in one line. Oh, this is what I meant. No, you need to put a meaning and try to explain how you thought about it. And also the detail of the study protocol, the phases, the informed consent also was a very, very challenging part because we need to address every single part of the telesurgery to explain to the patient, which makes all sense, of course. But we need to build, we built this from the scratch. Then cybersecurity and data integrity, as Misha was showing about the Windows, you have a different cybersecurity in Windows and different platforms. So they're gonna address this and they're gonna ask all of you guys if you're applying what kind of software you're using. We need to send all this information to FDA. And then you need an international collaboration and local oversight as well. You need to have someone kind of looking for your study. Second, FDA questions, also more than 20 pages there. And their questions are based on security parameters. They want to see if it's safe for the patient. And they're correct. They're 100% correct. And we agree. And they asked, that's what I told you. I showed the animal trials we did. This is very, very important. So if you're planning to do a telesurgery program built, you need to do animal trials or dry lab trials to kind of establish what you have, the distances and everything. They asked for device classification, emergency takeover protocol, which is something that nobody thinks. But once Patel and I are in the surgery, we know exactly what we have to do, what kind of connection, what kind of delay will trigger emergency protocol, which is like the local surgeon taking over the procedure. I told you.
We were kind of having fun. We connected different parts of the world, Africa. It was nice. We wrote a bunch of papers. But when it came down to the idea, the fact that we did the trials from that robot, from that hospital, that was rather than we just wrote somebody else. It's almost like
and without knowing, we had everything ready because all our trials were from Nicholson, which is the center that we were doing. So we had everything ready.
that's when we got the idea
Yeah.
So these are robot specific.
Yeah, yeah. About the robot, connectivity, everything. They ask everything. Yes.
So, since the snowplow went through once on this robot, it's still snowing a little bit, would you have to redo all the animal studies? Let's say you decide in Orlando, you're gonna do it from Orlando to Tampa.
Now is a totally different scenario because first you build the core, right? The big core of the study, the IRB and the FDA protocol, and then we did the first patient. After the first patient, yesterday, 2 days ago, I was like replying for all the FDA questions because you have a 30-day commitment that you need to send all the data from the patients. You're obligated to do to see if they have hospitalizations, problems, issues, or anything like this. After that, they're gonna reevaluate all your data, everything that happened with that patient to see if you're allowed to do further cases. Once you're allowed to do further cases, you just apply for, I'm gonna do with your center, with Misha, with Shadi. I can expand that, but I'm gonna use this core that we did, which is everything that we submitted, talking about the robot and etc. But I can add an external site, and adding the external site is much easier than anything that we did before. Exactly. Surgery.
The question is that every robot comes to you then, exact same steps, none of them can be considered prior.
Yeah, we cannot apply for different machines. For instance, this tries for microport.
Right, but you have to do everything, the animal trials, everything for every robot. Every medical device is, okay, there is nothing out there that says, okay, this entire class of devices can go and do this procedure without third. That doesn't exist. So just like every medical device goes to FDA on small wear, for its specific indication to use, the same rules apply. So if a different company other than Medtronic wants to do this, then they will have to bring their information on their specific system, how they want to use it, how they want to apply it, and make their case.
Cybersecurity that they use, what type of connectivity they use, because they're different. They vary a little bit in some details.
Variable, but isn't there otherwise nothing to get through the FDA? Because there is prior art, right? There is not big robots. Let's take video system, something a little more simpler. They say Storch makes a video tower. Stryker has a video tower. They change the chip. Yes, that's a different regulatory factor. That's called the 510K. All right. That means you're developing something that already exists. You're just doing a different. Isn't that how Da Vinci got through? I don't mean to be way back when. That was a different. There were different rules then.
Yeah.
Let's have that conversation.
Yeah.
So one question I actually already asked it. I think I know the answer. So the Da Vinci, it's an approved device. Different than NetBot.
Yes.
It looks like we still have to go through the ID process.
Yeah.
Why?
Because has it been approved for that specific indication for use? Okay.
No. Yeah, I asked the
You got your
question
answer.
already. I was hoping we wouldn't have to, but they're like, yeah, you have to go through the ID process. So you have to submit all the animal trials from before. It might actually be more complicated for Da Vinci because you have so much of the data.
Yes. And again, I think the shot caller here is the agency, is the FDA. So from my perspective, the best next step is for any company who wants to navigate this path is to talk to FDA, go and ask them, here is what we want, here is the data, here is the prior approvals that we have, what do you think is the best way to do it?
I'm not sure. I'm gonna call you.
Can give it to him to write the whole thing. You're gonna write the next one. Thanks, God. So, proceeding, guys. Again, as I said, the FDA questions were all based on security parameters. Oh, cybersecurity, if it's safe for the patient. And we have some network metrics here, latency lower than 20 milliseconds. And is this something that we discuss a lot? Because this 200 milliseconds is not a magic number. That's for our protocols because the latency, they depend on distance. So it's not a magic protocol. If you're doing a bigger distance, you're gonna have to consider a bigger latency here because as Misha said, you cannot beat the speed of light yet. Also jitter, those are our parameters in our protocol. Jitter less than 30, sorry.
Think about this whole concept that we can't go faster than the speed of light. They're like, well, maybe there's a way around that.
It's the compression,
They get
discompression.
complicated. I mean, they can do different things, and Mustafa's in the room here. So you can do what is called model predicted AI thing. So because Vip, how you operate, you're an animal of repetition. You always do it the same way. We can learn that. So you build a model on how you do operations. You take this model to the other side, and it's executing that actually a few tens of milliseconds ahead of you. And when the local model notices you're doing something else, we update these model parameters. We've used it 20 years ago very successfully in France Telecom. Actually, I built these models. So we can do that. From a physics point of view, beating speed of light, I'm not discarding it. Those who know quantum world, they know that we have something called teleportation and entanglement. We're not able to transmit any meaningful information with that, but we're getting closer.
Yeah.
I'm not discarding it. So you're absolutely right. It sounds ironic.
Yeah.
We can't do it yet. I'll tell you that. Yeah.
Told me basically I say speed of light, immediate, don't worry about it.
Thank you. Thank you, Mustafa.
Next question is for Alex. The latency was much lower than we expected. Are there modifications we can make to the robot to drop the latency? Because the version that the first
He doesn't want to tell us. He has for a while, right?
the first Medbot version we got, he said, don't use that. Let me send you a new one. We switched the robot out. You don't have to say anything authority,
But it would be good.
Exactly. I'm trying to get this information for 1 year from him.
Yeah, so we talked about this a little bit. We did actually Starlink tests on our thing. So Starlink is a low orbit construct. So it's actually quite close to the ground, and you don't do it end to end typically now. So they're working on a satellite to satellite to satellite until they go down both segments, but typically it goes up into the sky, comes back down to the ground station, then goes fiber, and maybe goes up again and goes down, right? So just so you know, it isn't the full satellite path there. So the Starlink has really good latency on that segment because these satellites are quite low. We're talking 10 milliseconds and less, so it's pretty smart. But the problem is it is very, very fragile. So, you know, if you have a satellite out of reach and the other one is congested and comes in, you suddenly have a spike of 200 milliseconds, sometimes a second. In fact, there's a website. You just go on this website, you look for ping times. It's a wildly varying number at the moment. But the engineers promised me it will get actually very stable. And then it becomes a great backup link, in my opinion. Or if you want to go very remote in Africa, very remote in Brazil, very remote somewhere in the region, where you don't have 5G, where you don't have fiber, it's a great technology. Yeah. Well, speed of light. You know, 5G is not a wireless technology end to end. So when we do these trials, it doesn't go from one hospital to the other hospital just using wireless. It is again just the access. So rather than going to the sky with a satellite, it goes onto the roof to a base station, and then it is fiber, right? So it's again the fiber connect. So it's exactly the same latency breathing. It's just a much cheaper technology. It is not as mature as fiber, so you know I recommend to use fiber these days. But as we scale up, have 5G as a primary or secondary, or even two 5Gs, much cheaper, equally reliable, a little bit less bandwidth, but you can do the operations.
I had a quick comment about 5G. I think I've been doing a lot of conversations between telecom world and the medical device manufacturers. In terms of 5G, the healthcare community needs to help the 5G providers help them. So the more business you bring to the telecom provider and the clearer the use case that you have, they will be assigning more resources and designing their networks and services around your needs. But today, those networks are basically entertainment networks because that's primary customers. People want to stream videos.
How do you eliminate the one-off people ringing the doorbell?
I don't think you can.
But I mean, should there be a consortium, like say the SRS has, this is you go to, say, like, hospital X,
Yeah.
and in California it's hospital Y, and we want to set something up.
I'm so glad you bring this up. Yesterday's session on all the regulatory topics also reached the same conclusion that there is a significant opportunity in the pre-competitive space for this community to come together.
Use that word again?
Say again?
Say that word again?
Pre-competitive.
Pre-competitive.
Okay. To put
That will become a competitive space.
Well, that's what I'm trying to articulate. What you just described is a framework that the entire community can benefit from. But for that framework to exist, the community needs to come together and do the work.
Because I wouldn't know where to go. I mean, we have Savato, but other than that, I don't know.
And you're sitting next to people that are
We're gonna give you some context, Lou.
I can help you.
So,
We're trying to do the blueprinting, right? So, and I think that's hugely important. And Savato picks up, Savato does a great job in my opinion, right? So they evangelize a lot, really make it a commercial thing. It's fantastic. There will be other players who will do it. Medbot have their own solutions. We need a competitive space for that, but the blueprinting, everybody should agree to that, in my opinion.
Well, what's interesting, if you look around the world, it's so different. As in China, they're like, we already know how to do it.
Yeah.
We can do it with fiber, we can do it with 5G.
Gotcha, yeah.
Plus 5G. I've operated actually in China
Yeah.
with 5G, advanced 5G, combined.
But you know, it's very important what Alex said, Vip. Sorry to interrupt you. He said the Chinese regulator did not allow them to do it fiber only. It needs to be a backup link. So it's only the combo of fiber with 5G where they got green light. And I think in the US we'll come to the same point. And I'm preparing you as a community that this is
Yeah.
the blueprint we should follow, full stop.
In India, pretty much only
Same,
5G.
5G,
Not even
yeah,
using fiber.
yeah.
Whereas I think US probably is gonna want to do fiber until.
No, it's gonna be a combo, in my opinion.
Yeah,
Well,
probably
the
Wi-Fi
outages will
slice,
work.
yeah.
People, I think the devil is in the details. Just using the term 5G, and I'm sure Misha appreciates this. Not all 5G networks are the same. Verizon's network is different. So just by saying, hey, I'm going 5G, doesn't convey what we think it conveys. We need to be more specific.
How are they different?
On how exactly that system, that end-to-end system, is going to be deployed. If you call the network whatever you want, call it 5G, call it fiber, call it whatever you want. But the end-to-end system is what matters, because that end-to-end system is the one contributing to patient safety, is the one contributing to the medical device efficacy. Then how exactly you're going to populate the boxes in the middle, it really depends on what's available. So if in one region, for example, if you're in northern Idaho, okay, and you have only one telecom provider, and you have a critical need for deploying a robotic system, basically your options are limited, because you have that one option.
But we, you know,
Does
it's
that one option fit for your purpose
Yeah.
or not?
as a telco ecosystem, we want to reach the state where it shouldn't matter anymore. At the moment, it's not happening. But you know, right now, slicing, so it's basically reserving a very specific bandwidth for an application in the enterprise space. We're starting to do that. You know, T-Mo does it, Verizon does it. As they ramp it up anywhere in the US, then it shouldn't really matter anymore. You just buy the SIM card, which works well for your area. You do it online, e-provision that. In 30 seconds, you have it up and running at $50 a month. So, yeah.
Interesting, yeah, when you consent the patient. You consent when you talk to them about connecting via 5G versus fiber, the reactions are very different from patients. They're like, "Hey, I can't even get my cell phone signal to work."
problem, huh?
Yeah, you're not going to do this wirelessly for me. I mean, if you say fiber, they're like, okay. Yeah, then because you know.
The technology we use is actually different. So we're using what is called fixed wireless access. So Omar knows about this. We are mounting actually a router either inside the hospital or just outside on the wall. And it has almost, it doesn't move. Mobile is a very different proposition. It's very complicated, you know. So having a fixed end device with a base station which is fixed, they're just looking at each other for perpetuity and have a very stable link. So it's almost like fiber.
And what we also found is all fiber is not the same. How do you
Neither,
know
yeah.
if you have like the best fiber versus, I mean, it seems like there's a difference between fiber networks as well, quality.
Yeah. And price.
The price, the
Oh,
more
yeah.
expensive fiber's faster.
Yeah.
Interesting. Yeah, because the other day I was doing a case, I was here. I was here in IRCAD. One patient was in Kazakhstan, the other one was in southern China,
Okay.
and the guy was monitoring was in Beijing.
Okay.
So we had 4 consoles. And I was watching the networks, they were going all in different directions and different speeds. So I started the case in Kazakhstan, handed it off to the guy in Beijing. I went down to South China, did the case there, then handed it off to the guy in Beijing, went back to Kazakhstan, all within an hour. But I could see that even though they were using fiber, it was all different. So, I mean, we all kind of think of fiber and say, it must be the same, but I don't think so.
Are you doing this for fun, Ivip? I don't know.
Yeah, he was like having a great time there.
No, he needed
Got a
help.
coffee here.
He didn't know how to do the nerve sparing, so I just showed him the nerve sparing in Kazakhstan, then went back to China.
Amazing.
We put a table with coffee for him here. Anyway, so just finalizing here, you also have some trigger points for emergency protocols. This is what I said, that nobody thinks about it, but we need to have those emergency protocols, latency, how we're going to switch the command of the console, how we're going to convert. And then this is a testing phase. This is very interesting because this is what we do for weeks before we actually connect. It's called ping. It's pretty much testing the latency, connectivity, and the pack loss. And then you see in these yellow circles, here are the, let's say, different channels and IPs here. And we kind of select the ones that are faster, with less frame loss, with best connectivity there. Over here we have, it's in Chinese, but it's like 25% of frame loss, so we're not selecting this channel. So that's what we're doing when we're connecting. And here you have all the screens with the IP, with connectivity, with latency. So we choose different channels before, and then once we get the best one, we connect with this one, and we try to do everything through this one. After that, we still are in the testing phase, and we're gonna have to connect from different places to see. And if you're doing the surgery with Orlando, for instance, here's a nice example. We connected with Orlando, and then the surgeon there in Orlando is doing some exercises in our which is Patel actually there, doing some exercises there. And then when you take a look at the lower corner here, you're gonna see the latency. This is in our screen, so it's a live monitoring. So you're gonna have here 144 milliseconds and 0% of frame loss. So that's the connectivity phase that we're talking, and we're doing this for we're doing this for weeks before we're achieving the surgery. And then go into the trial. Patel was in Orlando. I went to Angola, and that's the connectivity that we have. Misha explained very well, but you see that it's a very, very far distance over there. And then this is a very interesting video, because if you take a look at this bigger screen, here is a different timing as this one. You see that this one is faster than this one. So that's the latency sensation we have during the procedure. So that's how the surgeon, that's how I see. So I have these two screens. Of course, this one is my screen that I use in the monitor in the surgery. But once I look at this screen, I can feel the sensation of the delay here. And then Patel operating here at Nicholson Center. It's a very interesting concept. And if you take a look here, on the corner here, you're gonna have this screen in 3. I'm gonna show this a take of the surgery as well. So you're gonna see the screen is divided in 3. One camera was on me, another one in Patel, and another one in surgery. This was a requirement of FDA. So they wanted us to monitor this and to monitor all audio and video that we have for security purposes and etc. The top one, this one, the top one. This is Patel's screen, and this is mine. So that's the surgical thing. So that's a sensation of delay when we're talking about the delay. And this is, what's that? No, I don't. I know because I'm watching both, and he's only watching one. But I know that there's somehow a delay there because I can see both screens. And these are for the first time that we're presenting to the world the parameters of our trial here. So that's pretty much 137 milliseconds there, and with a very, very good and stable connectivity through the trial. So those are the surgical parameters we had. That's what we sent to FDA, and that's the final picture here. The handshake, the virtual handshake. We have the first one in China. So Patel, our team, Angola, and myself and my wife here as well. I had to call her in that time. So that's was a great moment there. Both teams, as you can see, I'm here with the whole team from Angola. I was the only one there without that was not Angola, and this what makes us very proud, because at the beginning of my lecture I said that you need to train a team very well for them to be able to do telesurgery there, and that's what we're doing in Angola. They're doing a great job in all specialties, anesthesia and etc. Here, Patel team with our team down, and the patient 3 days before surgery, Patel went there, saw the patient, then he flew to US, and this is 5 hours after surgery. The patient was walking. It's the same protocol that we use in our hospital and at Advent Health Celebration. That's the same protocol that we've been using for years. So minimally invasive surgery, best approach for the patient, and then he was walking in 5 hours and was discharged in 2 days. So In summary, as you said, as I showed, a lot of different things to do, a lot of trials before you try to do telesurgery. We recommend all of you guys, if you start doing any protocol, to do under IRB, doing with experts in the field, in the connectivity, to have a great relationship with your hospital, because you're gonna need a lot of their structure over there to support all these projects, and it's a teamwork. As I think you guys noticed, I spoke about 10, 15 people here that I was working with during the FDA submission, during the surgery, during the connectivity, a big team in Angola as well. So it's a teamwork. It's not something that a surgeon with a company will make history and be shown. No, it's a very, very robust teamwork. Everybody talking the same language. Thank you. We will proceed for telesurgery collaborative community. Shadi, please. Thank you.
All right. Good morning, everyone. Thanks, Marcio, for the detailed introduction into telesurgery. So I'm going to be discussing collaborative community and the framework, which are two things that we've built in our institution. We started off, it's a very common theme that's been talked about, collaboration. Everyone talks about collaboration. It's almost like a magic word that you can plug in anywhere to try and get you through conversation. But the actual meaning is what type of collaboration are you? You need the details of what this collaboration is like to understand how to go forward. So, all right, great. This is going to take a while. All right. So why telesurgery? Why now? I think you've probably seen 1,000 slides over the last 3 days about this. But the reason is there's these advances in robotic platforms that are happening, and there are advances in telesurgery or telecommunications that are happening. And the question is, since the conception of robotic surgery was to perform remote surgery, or it was one of the initial ideas, can this be realized? And finally, I think the answer is, as you can see from today and yesterday, that yes, it can. And the one key thing is that we're trying to find a way to close the gap globally in surgical disparity, and as well as we also need a structured way of doing it and trying to dissipate surgical knowledge and allow surgical education globally without the need for travel. These are the three main themes that you've probably seen repetitively over the last few days. So the telesurgery collaborative community, it's a working group. It's started probably, I would say, in February 2024. We had a special meeting in Orlando. There was people from all over, all walks of life, all industries. You had telecom guys, you had the robotic companies, surgeons, you had cybersecurity guys, regulators, FDA was there, everyone was there. So probably half the people in this room were there. And the reason was they wanted to come up and understand the topics behind stopping or that could prevent the application of telesurgery, and understand what are the different parts of telesurgery that need to be looked at to understand how we can implement it. And it was around 2 days. Different working groups. There were breakout groups. People were talking. People were arguing. No one was crying, which was great. And so, but in the end, we were able to come up with a lot of things and a lot of topics that basically sparked a Delphi consensus. And the Delphi consensus covered most of these topics. It was sent out to all of the Delphi process was sent out to all of the people that took part, and they were able to fill it out. But what you need to know is that all these different people have different perspectives as to how telesurgery should be applied. None of them have their own unique way, and not one of them can do it alone. So being able to apply questions or ask questions that could apply to every single industry was very important. Marcia worked tirelessly on it to try and be able to get as many rounds as possible. I know people hated us by the third or fourth round, but at least we were able to come up with something useful. So that Delphi process led us to something that we just recently published about a framework. It's a telesurgery framework. It's denote the language. It's not a guideline, because we don't have the data yet to provide an actual structured or strict guideline as to how to perform telesurgery, but a framework on how to think about it and how to provide it is what we actually looked at. Those are the different 8 pillars that we found that need to be focused on when trying to apply start a telesurgery program, or at least embark on starting telesurgery. Those are the 8 different parts we will talk about in detail in a second. So how it was created, just to overview, we did a literature review, systematic literature review, which was published. Then we had the February meeting, and then the Delphi consensus that had all these global experts involved. for us to then take all of that and then summarize it into what we call the framework. So the framework starts off by talking about the challenges in the telesurgery scenario today. Different regions across the world have different ways of doing it. If you looked at how they started it in China, how they did it in Japan, in India, each one has their own way. And that's something that we acknowledge, we appreciate, but there has to be something in common. You can't just decide to do telesurgery the way you want, anytime you want. There also were a lot of unclear definitions. There were a lot of words that were just used randomly and plugged in and synonymously with others without actual clear definitions. So that's sort of one of the few challenges that we found that we needed to address. The first one we looked at were technological requirements. I'm not going to go into details with experts like Misha here, so I embarrass myself, but in general, you had fiber and 5G. Those were the two main ones that were looked at in terms of telesurgery. Latency mitigation, which we talked about relentlessly, how to try and overcome this latency issue, as well as redundancy and liability. We had to make sure that we had redundant and liable connections before we can actually start doing telesurgery. Cybersecurity, there are cybersecurity threats. The most common types of attacks you could have are some like man in the middle, someone takes over the robot all of a sudden while you're working from the remote location. That sounds pretty scary. Or someone can just block your connection into the other side, onto the patient's side. Obviously, there's malware and ransomware and all of those as well. Network security, having authentication, having secure authentication, passwords, facial recognition, whatever it is, biometrics, all of those that could probably make the network more secure. Safety and efficacy standards, so from not just a technical side, but from a clinical side, we need to know that this patient isn't high risk for telesurgery. Is there anything in this patient's case that precludes you from being remote? Do you have to be right next to this patient for some reason, some specific clinical reason, not just technical? So there's a lot of those that go into that, as well as obviously the technical part. And like Marcio mentioned, there's also the emergency takeover. Is there an emergency takeover plan in place or not? You can't just decide to wing it when it happens. This is not a procedure where you can do that. Training and credentialing. So a lot of people say, well, telesurgery is the same process. It's just you're not next to the patient. So why should I go through extra training? That's not true. So when you have to look at it, you have to try and get your mind adept to different situations. We can't just decide, for example, that if you do a robotic case, you can do this 3,000 kilometers away, because the little details, for example, the extra 200 milliseconds delay, you're performing a surgery and all of a sudden the latency shoots up. What are you going to do? Are you going to panic and disconnect and start locally, or are you just trying to overcome it mentally? This needs training. This is not something that you can just sit on a robot and decide works just fine. The credentialing requirements, is your system set up to accommodate telesurgery? Not just because you can connect to the internet doesn't mean you can do telesurgery, as Misha and Omar clearly explained. You need to be able to accommodate it and accommodate the latencies. Simulation should be involved. You need to try and simulate different environments, high latency environments, low latency environments, what happens when the connection cuts off. You need to be able to be prepared for every scenario. And the implementation model. So we actually found that when we talked to all these experts, they decided to split it up into two major groups, the implementation phase and the maintenance phase. Implementation has to start small and grow. And then the maintenance has to be constantly audited, just like any other process. You can't just sit there and expect to start it, and it should go on autopilot forever. You need to be able to audit your process, see what's going wrong, because this is a growing field. So things are going to change as we progress. So between both of them, you're able to having those two models or those two phases distinctly available allows you to maximize the efficiency of the program itself. Then obviously there's the great big question of legal and ethical issues, patient autonomy and informed consent. Being able to do remote surgery shouldn't take away from patient autonomy or patient priority in this. Patient always comes first. There is obviously a potential to dehumanize the patient since the surgeon is not right there next to them, but you also must inform the patient that this is not the only way we can do surgery for you in the beginning, unless it really is, as well as provide them the chance all the way up to the last minute to refuse surgery if they want to. And informed consent should detail that, as well as try and detail the legal responsibility of the surgeon, as well as the possible risks. And they should be obviously in the patient's language, local language, and be clearly stated to the patient so there's no confusion. The clinical indications should be clear. The eligibility criteria, which was something of a concern and was discussed at great lengths during the meetings, is because who's going to decide that this procedure is eligible for telesurgery? Is every procedure eligible for telesurgery or not? So this has to be strict criteria coming from professional societies, we believe. Not necessarily, but that seems to be the first place to start, is trying to come up with a group of procedures we can start with, validate this with real-world data, and decide then we can progress from that to other procedures. And you need a multidisciplinary review board. For example, if you have the clinicians just looking at it, if there's no delay time and they're able to get through the surgery, they're going to say that was great. It was a beautiful success. It was amazing. We should keep doing this forever. Then you have the telecom guys that are going to like, look guys, there's a latency there that went up to 250 multiple times. That's dangerous. You're a great surgeon, you're able to do it, but what if someone who's less experienced decides to go ahead and operate at 250 milliseconds? Then we could run into problems. And an expert surgeon probably might not relate to that because to them it was fine. So those are the other questions that need to be looked at by multiple people from multiple specialties. Then there's the regulatory process. You have to respect the rules and the regulations of every process. Marcio went into details how long it took to get the FDA approval. I'm pretty sure trying to do it in Europe is not going to be much easier. The rest of the world also can adopt, if they don't have their own regulatory process, they can adopt the ones that are already established by the FDA or the GDPR. And then we have to also have a way of reporting these adverse events to these regulatory bodies so that there's a standardized method for doing it and it can be recorded and kept in records for other people to learn from as well, not just to reprimand people or to audit the program itself. So in summary, what's the call to action here is that there's an opportunity for stakeholders to come together and build something that could last for ages, that could take robotic surgery into the next realm. No one says that this is going to be how surgery is in the future forever. No one says telesurgery has to replace regular in-person surgery, but the option to have it when you need it should be available because we have the technology to do it, and we also have a huge disparity and need to do it when we should do it. So the next steps are to try and make sure that this is a safe and efficient procedure. Invest in telesurgery is going to drive it. So what Omar was saying earlier is actually very true. If you bring the use cases to these companies, they're going to start investing in it. If we're going to say that it's going to happen once or twice every 6 years, they're not going to find the use in it, and they're not going to help you develop it. Policymakers and investors should all work hand in hand as well as clinicians, but we should always remember that clinical indication has to be there as well as the patient should always be put first. Thank you.
So in sequence, we will play the video that we recorded for FDA, so you guys gonna have an idea about the documentation and what we sent. It's basically a video showing me, Patel, and what we were discussing during the procedure. So they required us to record this video to show everything that was happening. So, Luke?
I just want to make two statements. First of all, thank you so much for putting this together and including me on the guidelines, because I didn't quite agree with everything in there. Two things I want to point out. First is the ethics, and
I will just keep playing and then we discuss.
yeah, that's fine.
Yeah, but we only do 20 minutes because we need to go until 10.
So if we don't have time ourselves, I don't have to say anything. But my concern is that it is unethical. If it is unethical to have somebody locally do a surgery that is not as good as, say, VIP is, that's unethical. And if the technology exists to do that, the ethical thing is to offer that to the patient. So that's number one. Number two, I'm very concerned about the oversight piece. And that was the other part that I was really, that organizations say you can and cannot do this operation. And there are nuances, just like there are nuances in the telecommunication connection. There are nuances with the cases that are only known by the local teams and what's available in the local hospitals, what can be approved and not be approved. So you don't have the American College of Surgeons, Royal College of Surgeons say you can only do these hernias with mesh. You don't have that. And I think it's dangerous to suggest an organization, then you're going to get the dogfight. Which organizations are going to do it? Is the SRS going to do it? Is the Clinical Society of Surgeons? Is the Royal College going to do it? I would stay away from that. And I also think it stifles creativity. It needs to be done safely, but I wouldn't put an extra layer of some other outside body telling people what to do. And this is very antithetical. As an American, it's so antithetical to the American way. So there's no way on earth that, that's why I'm glad it's not a guideline. Otherwise, I would say take my name off it.
Who are the people there to regulate this? That's the main issue.
Right, you have to just say that there should be, and I agree with that.
Yeah, but just to answer the last point about getting an authority or someone at authority to you what to do or what not to do. Remember I think the first draft we sent you, we looked at your comments where you were saying that, you said that exact point where I don't think you should put strict guidelines. And even I think the first word we used was guidelines when we first started thinking about this. But when we rethought it and got more feedback and looked at it, we understood your point, which is completely valid. That you can't put strict guidelines when it's not, first of all, not based on data. There's no real world data available. Second, it becomes too restrictive, no one's going to use it. It's that simple. So that would be a pointless piece of work or document. So you notice we moved it more into a framework with suggestions of how to go about it if you don't know what you're going to do. It's for people that want to start it, but not to tell them you should do this. But if you don't know what to do, this is where you should go.
As soon as it starts, it's going to take off like a match.
Yeah, exactly.
There's no question. As soon as the road, that's why you're doing the hard work. And I have sympathy for all the paperwork that you did to get the initial FDA, and my fellow's in the back of the room because we're getting ready to put an FDA trial in. And at least he has a friend, Marcel. I'm going to connect you guys. So he has somebody to talk to about this.
A lot of time. But anyway, when we first started the frameworks, our main title would be recommendation. Remember we spoke in Belgium?
Right, recommendation.
Our initial idea was recommendations, because we think, all of us in the paper there, that it's too strong for you to tell guidelines. Guidelines pretty much something that is based on data, based on high-level evidence or expert opinion. We have some experts there, but in telesurgery, we still don't have experts enough to tell us, no, that's exactly what you have to do, because nobody tried what we're doing now, right? So I think we should be very careful. And there are some recent papers addressing guidelines for telesurgery and etc. This is something that we're gonna have to be very, very careful about it. So here's the main surgery that we're doing. FDA required, this is not the screen, this is only the surgical screen. Here is a radical prostatectomy. And FDA required us to record everything, audio, video, everything that was happening in the room, all the parameters, the surgical parameters that I showed in the tables there. So all of you guys gonna have to do this, especially in the US. When you guys apply, you're gonna have to you need to have system. But one question here for Misha, for instance, we were recording all that, and we did a kind of a Zoom recording there. Is there any difference in terms of connectivity, delays about this, between the surgery and the Zoom? Or are they using the same type of connections? How do you see this part? What do you recommend people to do?
So the networking latency you measure with a ping, which you had shown, is the same for all data streams. So for those who don't know, there are a lot of different data streams going on here. So we see that camera here, but there are also other cameras of the OR. There are there's telemetry, there's the kinesthetic control, and quite a bit more. So, you know, Alex, of course, as a medbot guy, he knows what's going on there. But so whilst the point-to-point networking latency is the same, the perceived truly, you know, photon to photon in this case, or the feeling VIP has or you have when you operate to the patient or the haptic feedback back is actually different, because there is processing still going on after the network in the actual robotic device. So you need to do image compression here, decompression. There's security there. There is a robotic inertia, which also has a different latency. So everything, you know, the truly perceived latency is slightly different on all, but the large components, which is the networking one, is the same for all. That's why I think it's a good measure to measure, actually, as long as we know that NVIDIA does a great job in compressing the data very quickly. Medbot does a great job in implementing that on their fabric to make everything low latency on the endpoints. Yeah. Does it make
Marcio,
sense?
it looks to me, I've seen VIP operate, and it seems pretty slow. Him moving slowly.
Yeah, I think at the beginning of the
And
procedure.
now, is he doing it because he's being
No, he's being.
extra
Yeah,
cautious?
actually,
or-
the time of the surgery, the operative time was pretty much similar. It was 1 hour and something, 1 hour and 10 or something like this. But at the beginning, the first 5 to 10 minutes, you have to, because it's a defense mechanism that I tell everybody. When I did the trials with the pigs in Shanghai and etc., I operated I don't know how many pigs when I did all my fellowships, especially in Belgium. But in when I enter there and you see the thing pumping over there and you're gonna dissect with a delay, you go very cautious. So the first 5 to 10 minutes, you're adapting your brain for the movements, for the delays, for the energy, for everything, how it behaves inside. And then suddenly you're gonna see that he's gonna start jumping. Yeah. Yes, exactly, correct. And here, I had all the team there in Angola supporting me, and then we were talking. Can you put the volume up a little bit? I think, because it's interesting, I think the discussion inside, because I'm asking all the time, how you feeling? How's the latency? How's the movements? Because he just kept operating, and that's it, without any issues there. Any questions from? Yes.
Not usually a talker.
Yeah, but this time we wanted to talk, to document, and to explain what's happening. Because imagine the guy from FDA, he doesn't know anything about prostate cancer, radical prostatectomy. So you're gonna see, I don't know, I'm in the background narrating. So guys, now we're doing the bladder neck, now we're lifting the seminal vesicles, now we're doing the anastomosis, because this video was going to be used by FDA, so they were realizing what's happening and what kind of a step of the procedure we were in. So that's pretty much the main idea of talking. He hates talking while he's in the surgery. And this is in Portuguese. I'm talking to the local team. What's that? No, I don't know. Probably, yeah. Probably they want to put like a caption down there. And this is, I think, the most important part that you realize about the delay and how you can do the procedure is when you're going to put the clip, when you're going to apply the clips. Because once you're going to apply the clips on the pedicles, you need to be very, very synchronized with the surgeon. And I can tell you that because when we did the trials with the pigs, it was like 300 milliseconds. And we were like applying the clips and it was like a mismatching. But all the other ones, you're going to see when I apply the clip, I was very synchronized with him. He just presented and just boom, clip. So we were almost not feeling it. Dr. Patel, talk a little bit about your sensation on the delay. And Lou said that you're going too slow there. What happened?
Having watched you out there before.
Yeah, this was like 5 a.m. in the morning. So I got a call from Marcio at 4 a.m. He's like, the Minister of Health's here. We have to start. Minister's in control, right, Benedito? So okay, so we go in 5 a.m. in the morning. I drive to the hospital. I think for this we gotta pick the right patients. I was fortunate that the week before I met this patient because I was in Angola. We did 10 cases, so I was very comfortable already with the system. But I kind of went slower on this one because, first case, I was like, I'm going to go really slow just in case I set something off I'm not supposed to. I think by the time I get to the 10th case of the trial, I'll just kind of just do my normal speed. But here I'm like making sure nothing bleeds. Marcio knows the speed I operate at. This is probably like, 30%, 40% less. Yeah.
How you adjust yourself? You were discussing.
Yeah. I don't think I had to adjust at all. I think I went slower because it was a part of a clinical trial, and I wanted to make sure everything was clear, nothing bled, because I wanted to make sure that, say something happened. I didn't want my clinical team that was in Angola to have a difficult case. So it's more protecting them in case something happened. I wanted to have it all, so I overexpose, I do more exposure than I normally do, just in case those guys, at least I leave them a nice, easy case to do. And we picked a nice patient, wide anatomy, but, it looks pretty good. Hardest part about the whole thing was having listened to Marcio the entire time. Because usually, it's the hardest time.
But he doesn't like to talk to what he said. No, he hates talking.
Oh, I turn off all the audio on mine. Because my assistant, who normally is like, Marcelo doesn't assist me. My assistant's done maybe 7,000 cases. He knows everything. So I never have to talk to my assistant. And so I just turn off all the audio. And it's weird for me to actually have someone talking on the other side. And especially Marcio, like, you know Giovanna. It must be. I don't know.
For this one also, we needed to describe for FDA like the steps.
Yeah.
You guys see here the latency in the frame loss. That's
Yeah.
what is this parameter we're watching all the time.
Yeah. So,
See, that's
At what latency do you not notice a difference? Do you notice a difference?
I think it's about 180.
So you didn't notice any difference?
No, nothing on this one. I think around 180, you start to feel it.
Actually, so original we say that, but that depends on the development robot. You cannot say that based on this communication delay, because originally maybe after 150 grams, but right now,
and I keep this 22, and I'm gonna use it later.
Because the guys in Kuwait, when they were doing Shanghai, Kuwait, they were at like 180. And Saad said he was fine, and he was good. Omar, question for you. So FDA we had to send them this entire video, outside, inside, external view, so they see, it's like they're watching. What are they looking for? No, I mean, they want everything, external view, internal view. I mean, we sent them the entire files, unedited. But what are they gonna, but what are they gonna do with it? And who's gonna watch it? And are they gonna critique my technique?
146.
It's gonna be Lou talking about.
It's a loop.
146 is stable since the beginning of the case. No frame loss here. The imaging is good.
And
as
then
well, so-
you're going to have somebody who is a cybersecurity expert, somebody who is a connectivity expert, and somebody who is an expert in surgical robotics, all of them together working and evaluating the information that you're providing. And at the end of the day, all of those conversations contribute to the benefit versus risk analysis. So is what you're doing tilts more toward benefit?
It's a battery, it's a battery.
Just color it.
That probably means it could be a bit better.
No, maybe
I'll let you
that's
know.
the first thing I looked at. I'm like, why is that one not yellow?
It's a question of calibration. I didn't know the robot. Why is it this?
I need that one to be yellow.
And then, Vip, another point about reviewing this data by the FDA team is that they're going to reference the information that you provided in your clinical procedure, okay? And they're going to see, did you adhere to the steps that you said you're going to? Did you meet the criteria that you set for yourself? So for example, if in the submission, Misha said, we need 150 milliseconds and we need to be less than that, they're going to look at this number and see, okay, yes, you met that criteria. But if you said, I absolutely need 150 milliseconds, but then your numbers demonstrate 250 milliseconds, I think it's safe to assume that they're going to ask you, why didn't you get what you set out to get? And how did you accommodate for that deviation?
What's that?
I respect John and I, we
That's the
did
most
this whole thing
important
from
part,
day one
which
in
shows that they
robotics.
have
You know,
synchronization.
John's one of the originals. Think about all this from MD Anderson perspective, you guys got multiple hospitals. Everything your admin, everything, they're gonna come to you, right, John, in a second. Also has some surgery. Now, where does it stand? I mean, all the big hospital systems are asking, they're gonna ask you, what do you say? It's out there.
We used to have a division head that actually moved to Ohio State. He was a big-time telemedicine or telesurgery advocate, but, you ran into the regular obstacles of what's going to drive, continual interest as opposed to, a demonstration or feasibility. But for example, like we're building a brand new from the ground up cancer center in Austin. So then you don't have licensure issues. So you could easily start there. And some of the other UT sites are trying to increasingly collaborate with us. So even within a large single licensure state, you could start it. The one I haven't pushed on either is since COVID, the hospital is actually paying for us to maintain telemedicine licensure in I have 9 states now. I don't know if that means I could operate in those states, but I can do a follow-up visit. But that shouldn't be hard to transform to. So I still think it's a fascinating discussion of, are you going to use this to help train fellow graduates in their early independent years? Or is it the Angola model, which is completely different, obviously?
At some point, the payers may let, look, you're a resident graduate, right?
Yeah.
You sign up, you train robotic. They're not, they're not.
Yeah.
You were trying to find a plane that is like a vascular plane.
Once you kind of be around for the first 10, I think all of my fellows.
That model can work. I really think so. I think especially if it's just something you could turn on the console, not buying a brand new platform or something like that, but yeah.
Bernardo, you said you got approval from the Vatican to do telesurgery?
Well, we have the endorsement of Pope Francis, actually. Yeah, we share our intention to proceed with a humanitarian purpose. And through a very good friend of the Cardinal, I sent him a letter regarding our interest, and he kindly replied with a letter that of course, I'm preserving on my table. That was endorsing this project. So this is very good, of course, with the clear intent of providing such high-quality surgery, minimal invasive approach to people who has difficulties. And my personal view is that this can contribute much more than what can seem, because many other stakeholders might be interested in being part of something like that. So if you go there with telesurgery, we might have other companies interested in providing a CT scan where there is no availability, just because the project is very attractive. So I think this might be the cherry over a cake, and they can also provide a big cake. So I think this is important.
I think Brazil likes the concept of from a humanitarian perspective, size of the country.
I agree with the discussion, especially with Dr. Rocco said. In Brazil, we travel around Brazil. My wife is pissed with me because I'm not at home ever, because there are more than 160 systems in Brazil in more than 50 cities, different, as a proctor. Yeah.
How many hospitals in Northwell, and you have big aspirations? Aspirations for your system?
Yes, we do. We've got, we just took on 8 more hospitals. So my view is that there are too many surgeons. And I have a very radical view that most surgeons probably shouldn't go to medical school, that we're missing a lot of very good, because it's a technical. What you're doing is absolutely technical. Now, it's nice you know how many ATPs came out of the Krebs cycle. It's very nice. But I'd venture to say you don't.
36.
Yeah, but I'd venture to say that's a fact you don't use taking care of your patients. I think it presents an opportunity to really change the way surgeons are trained and put out, and you can get more of the Patels, the LeBron Jameses, the Messis are out there, and just have fewer of them, and then the whole thing, well, what happens to the patient-doctor relationship, that's going to be different. They're going to have relationships with their local people. In our system, there just aren't enough, and this is nationally with urology, and I think it's worldwide, but in the US, it's a urology shortage. And even in New York City, we do not have enough urologists. So this is a mechanism that administration loves, because it's much cheaper to pay one of the prostate guys a couple of bucks than hire 2 or 3, 4 guys who may do less cases. You get worse outcomes for patients. This makes 150% sense. And again, it's a matter of getting it to the point that it's pedestrian. It's not yet. It's a lot of work. But you guys know this demonstration, what you've done in your previous time, it is going to be pedestrian, all right? You've had the courage and the fortitude to do all the paperwork, the hard part of getting to this point. This is almost the easy part. I'll say it's not easy, but for you, this is not the hard, this is the sexy part, this is the wonderful part. But to get to this point, you guys, and I'm looking at Marcelo because I know you're both busy, but he didn't a lot. But
Red and IRB, 70 pages.
this is going to be the new paradigm. There's no question in my mind that this is what's going to happen.
Get it through all the legals of New York, and I think that's. I mean,
I don't think that's not going to be. It's a matter of setting expectations, and here you need the personal touch when you're getting it through people. And I can't tell you how many people you go to, you talk to, you say it's a great idea. Then you got to talk to them again because they forgot they told you it was a great idea. Going to the local politicians, going to the local newspapers, just setting expectations beforehand. In parallel, meeting with a bunch, and in the hospital, a lot of the committees are not surgeons. You got some pediatricians who say, I don't know about this, and there needs to be a credentialed surgeon on both sides, long term, and I'm saying, well, that takes away the beauty of this.
One thing that we need to think about is, as urologists, we're talking about radical prostatectomies, kidney, bladders, but what about the cardiac and neuro? You see the benefits, like almost 70% of the guys that have stroke, they cannot get to an hemodynamic place. Almost 65% of the guys having an infarction, they cannot go to appropriate procedure on time. So if we can build something around it, because imagine if we can decrease the consequence, first death, and then all the consequences these patients are going to have for the rest of their lives, we're saving a lot of money there, because people like to talk about money. Hey, how much does that cost? I say, you know how much it costs one guy with stroke and sequels, like physical things that he needs physical therapy for 20 years. So I think we should be very broad when we talk about telesurgery, talking about the other applications, well, biopsies, or other minor remote procedures that are going to benefit a lot of patients.
That's why I prefer to use the term teleintervention.
Yeah, that's
the term
smart.
that we use in New York, teleintervention.
Yeah, what's interesting on this is, if you didn't tell somebody this was a telesurgery, I don't think they know, because Marcio missed a couple of clips here, but I think that was
zero clips.
That was
you
him,
owe me a wine. He said, if you don't miss a clip, you're gonna get a good wine.
Yeah, it is. The Angola cases are not easy. The anatomy is different. There's more prostatitis. I haven't had an easy case in Angola. Let's put it that way, right? We've done a lot. Now the biopsy, there's something inherent where there's more prostatitis. They're difficult cases. So.
Were there any particular guidelines or recommendation with regard to telesurgery techniques? You said, as you said at first, maybe better exposure, to go cautiously or something like that. First.
There wasn't anything in the protocol, but I was maximizing exposure. I was going slower. I was definitely making sure I didn't lose any blood. Like I said, in case something happened, I wanted to make it easy for the team over there. They would just take over and finish it. I think, for this trial, we definitely have to have surgeons on both sides. I can see in the future when the Angolan surgeons are trained well enough that it'll be fine. You have to go back. When we did robotic surgery, remember, for the first 2 years, we used to have an open tray in the room, right? We used to make sure, does he have blood on board? Oh, I've never seen an open tray in the last 15 years. I've never asked, where's the blood? It takes time. It's going to take 5-10 years before we're comfortable. But eventually, it's going to be so much that the Wi-Fi, the fiber, it just always works, right? So it's fine. So we don't need that backup. Because we also used to say, what happens? 20,000 prostates? I haven't converted. 0. There's 0 conversion. So, if that happens one day, fine. Luckily, now we even have backup robots. So if something happens to a robot, there's another one there. And I think it's going to take time, but we just accept that it's okay. That the team on the other side eventually won't need a physician. It's going to be a technician who puts the ports in and says, hey, good to see you again. We did this yesterday. Go for it. We always talk about open conversion, all this. For the residents, they've probably never seen an open surgery, right? And the chance of an open conversion, if you convert a robotic prostate, it's only going to be worse. Or if it is, fix it robotically. It's much easier to fix. So, I don't know. Benedito, you were the guy who helped us enable this. You signed the deal for the robot. You took that leap of faith in us. What does Angola think about this?
Thank you. I'm trying talking English, but I don't have a very good English. But I think that it's a new process. We are trying to do the best way with your help, and we have a very expectation about the whole thing that we are happen at this moment, and I think that we are in good way, step by step. And we are
learning.
We are learning every day with the process. Yeah. Thank you. So we think that our doctors are very young first, and they have many
wishes.
They wish to learn everything that you give us. So I think that the nurses and the other person who involved in this process are very estão muito disponíveis.
Available.
Are very available to do the best.
You bring up an excellent point, because the young residents will think this is normal, which it should be, because they grew up with this.
Okay, thank you.
When you look at countries like in Africa and stuff, I've been going back to Angola for years, right? I kind of, what I see when we introduce robotics and telesurgery, you can see the light bulb go off on all the young guys, the nurses, creating a whole new industry for them. There can be an industry of whole physicians, med tech, nurses, even pharma. Have all this, it's all going to come there. And so the investment that they made was significant. I think it comes back in 1 or 2 years. And then it's like 10x, 30x, 50x. If you look 10 years from now, the whole country, the healthcare system is different from that one decision they made. I think from what I'm seeing, it's already there. So everyone talking about Angola these days.
The decision to invest in robotics in Angola is a government decision. I think in other places the robotic is more private. the hospitals private. In Angola, it's a government, the investment is from government. We have I represent government Angola at this moment. So I think there is a place of opportunities for investors in Angola. We are hoping.
All right. Well, I think we're out. What's the next live surgery, Marcio? You know, 10:30. I think it's actually I know it's the live Kangdo dual console to China. It is. So the next one's interesting. It's a double console where there's two surgeons operating and using Kangdo, but it's live from IRCAD here to China. So it'll be interesting to see how they manage that. So, all right. Thank you, guys.
Hello.
Testing, yep.
Okay. Okay. I'm Dr. Li. I'm now do a remote surgery from IRCAD to South China, Fujian province.
Hi, Dr. Lee. We're moderating from the Palais. Dr. Davis is here, myself, Dr. Shaddy, and Dr. Rogers. Can you give us a brief overview of the case, if you don't mind?
Doctor from LA. I'm not here clearly.
Yeah, it's Dr. Lee. I'm Dr. Shaddy. There's Dr. Davis with me here and Dr. Rogers. Good morning. We just wanted to have a brief overview of the case, if you don't mind.
Yeah. Do you see the patient's history about the case?
Yes.
That at the beginning, we have preview. 2 days ago, we have do a remote surgery from IRCAD to China. To radical prostatectomy. For today, we'll do a left UU anastomosis for the left side. And I and Dr. Yang from Beijing and Dr. Ye from Fujian province. Fujian is South China, 9,000 kilometers far away from here. And Dr. Yang, can you say something to the audience and the moderator?
Okay, it's a very honor to operate this remote surgery. Nowadays, we know the Kando robot do a lot of nice work in telesurgery. In China, our mainland is very large. So if we have the telesurgery, we can provide them the more and better medical or surgical service for the remote surgeon patient. I think it's very useful tool in the future. So today, I feel very exciting, like Dr. Li will do this remote surgery. For me, I think this is an easy case, ureterostomy case. But I think for this patient, he can she can receive this remote telesurgery. I think it's very good for the patient.
Thank you, Dr. Yang. Dr. Ye, it's your turn, Dr. Yang. Dr. Ye. 叶教授，您跟几位主持的教授还有会场的观众打个招呼。
Hello, this is Dr. Ye from Fujian Provincial Hospital. It's a very exciting time, so I'm glad to work to cooperate this patient with Dr. Yang and Dr. Li.
Thank you, Dr. Ye.
Thank you.
Dr. Li, could you describe your sensation as far as latency is concerned about what you're doing right now?
Yeah, absolutely. The linear distance from IRCAD to Fujian is 9,400 kilometers, and the data network distance is 14,000 kilometers. If the speed of the light, you can imagine the speed of the light from IRCAD to province and come back from Fujian to IRCAD is latency maybe
over 1 to 100 millisecond light speed. So the latency absolutely have the latency. We can feel it.
Maybe as a follow-up, once you're in the network, does it really matter if you're, whatever he said, 14,000 kilometers away versus if they were 2 hours away across the German border?
Well, I was going to bring this up earlier, and I was actually going to ask you, Shadi, is there a technical definition of what telesurgery is? Because don't we all do telesurgery if,
But
from 9 feet away?
Dr. Yang,
no, I mean, right? Like,
Dr. Yang, can you try the latency time? Okay, I give you the control. I give you. You take it. Okay.
I will take it.
Okay, let's show the latency between Beijing and Fuzhou Province Hospital. This is 3,000 kilometers. You can see the time difference. The latency is okay. How about you feeling, Dr. Yang?
I feel no delay. I feel it's very, very fluent.
Doctors at conference, can you say the latency, the feeling, Dr. Yang?
No delay feeling for me.
Are they reporting a number as far as the latency is concerned?
You can see, Dr. Yang can do the procedure very smoothly.
I can do some a quick action like the blunt dissection very smoothly for me.
The engineer tell me what the latency time between Beijing to Fujian and France to Beijing. 工程师能告诉我一下这个延时的时间吗？从北京到福建和北京到法国。Okay. The engineer will tell me the exactly delay time. The distance between Beijing to Fuzhou is 3,000 kilometers. So the delay time have so many factors: the distance and the speed. You know, in China, the 5G, even 6G network is available. So the network in China is very good. So from east to west, from south to north, 3,000 kilometer distance is not a problem anymore.
看一下左手可能卡了一下，帮忙动一下左手龙城。OK， 好。
46. Okay, the engineer tell me the latency between Beijing to Fujian province is 46 milliseconds. From IRCAD to Fujian province, 216 milliseconds. So the latency is relatively longer. 200 milliseconds is the limit to do the remote surgery. So I think it's a little bit far. The lander distance is a little bit far from France to Beijing. But we can do it slowly. The remote surgery, I think, have some meaning. The first is not really remote, it's teaching. I'm the senior doctor. I will tell Dr. Yang or Dr. Ye how to do it. We have an annotation function of the screen. 工程师帮我秀一下这个视教的功能。
I guess the other way to ask the question would be, at what point does a surgeon with a longer latency time have to sort of slow down to wait on a response versus sort of
Dr.
continue?
Yang, slow down. Dr. Yang, slow down for the. I'm concerned about the spin. The lesion as a lower pole of the kidney, so dissection the lower pole. Okay.
Yeah, Dr. Lee, what we're saying, what Dr. David is trying to say is, at what point do you think that the doctor has to compensate for the latency in terms of milliseconds? So 100 or 150. So below 100, usually that's what the literature says, is that you don't really detect the difference in latency. Do you notice that in your real life examples?
For this case, the latency less than 50 milliseconds from Beijing to Promise is pretty good. So Dr. Yang can do the remote surgery very safe. But from Beijing to France, I think it's a little bit longer for the data time. So maybe the teaching remote surgery is most important meeting at this till now. So I will tell Dr. Yang how to do the surgery and tell him if I'm the junior doctor and senior doctor between the two hospitals. 挪一下镜子，慧玲。
So do you see, Dr. David, do you see a value in teleproctoring in terms of whether there's latency or no latency? Do you see the value in teleproctoring and mentoring someone with the possibility, knowing that at one point you might need to intervene from a remote location?
Okay.
Yeah,
Dr.
those are the conversations we've often had. Like
give the control
in the
to
earlier
Dr.
session, you know, we talked a little bit with Dr. Patel about that. So,
Dr.
you know, 4 to 5
take
fellows
it.
a year, they go out. Could you
Let's
mentor them in
start.
their first cases? Yes, in
Okay.
theory. Then, but you know, you can poke holes in any of these arguments, such
I'm
as.
talking the
So one of my fellow from the end of this past year took a faculty job at University of Iowa. So certainly I could proctor with her, and she, you know, she's ready for all.
Yeah, so
that. She's got
slow
local
down,
help too,
slow
so it's
down,
not
slow.
like- So
Don't
that
so
model
quick.
theoretically works, but
Dr.
the
Ye,
Angola project's
叶
totally
教授不要说太快，
different,
慢一点，慢一点
much。farther away, probably a different experience level.
老外他喜欢
robotic
慢而
systems.
可控
So
，everything under
sustained
control。
interest is always
快并不一定是
interesting
好，
challenge.
快不一定是好啊。
I've even wondered, we have like
Yeah.
a good number of small.
尤其是在我们修复
fellow
我们修复的
to
领
1
域
to
是
4
要
person
everything under
groups
control。
around Texas that just
对
refer
，slow
patients
down。
in, and then they do general urology and stones and everything. Would they want to have us remote into their hospital? I don't, that's untested. I mean, because some of those folks, I mean, yeah, it's a 2-hour drive. So why wouldn't they just come on in? Although, in theory, rather than MD Anderson continually building more and more and more ORs, you could be theoretically utilizing existing ORs in the community with existing help. So, you know, we have 40 now, I think, you know, but if there's 8 more in Beaumont, 2
Oh,
hours away.
slow down. Okay.
And during a turnover or a non-clinical day, you could remote, yeah, so I think so, but these are, none of these are like straightforward slam dunks. Oh yeah, that's easy.
Yeah.
For continued use, not beyond presentation, feasibility,
So
interest.
you're saying kind of a hospital system using like a spoken hub model where you have one expert senior surgeon and
Okay.
he's transmitting to
Dr. Ye, can you
referring to
say
him, but he's not going. and he's just
anecdote?
transmitting.
能看到这个我的这
It
个，我
reminds me
画一
of
下哈。
the stories they would tell about DeBakey would have rooms and just walk in and do the distals for all the coronaries. Kind of the same. You have one guy just come in and do the nerve spares for all the prostates around town.
I mean, we say we're busy, and we are, but I'm sure that by the time you know,
Dr. Ye,
outside of Patel's fantasy
Are
camp,
you-
y'all have there in
Here's the
Orlando,
screen. 你看一下屏幕，
take
能
my
看
hands
到
off the console
我的
on
画
case
线吗
1 until I put him back on case 2 with a normal turnover.
？Dr. Ye，叶教授，
It'd almost be 2 hours. By the time you extract and close and turn over and then report, you know, maybe it's an hour and a half at best.
Yeah.
Remote in a bunch of another case if it's teed up and ready. So I mean, it's
Do you think that works from an administration point of view, paying one surgeon to basically farm out his services to the
Yeah,
rest
that's
of
what
the
I don't know
happened.
how you deal with the fee issue. That's, again, that's why the presentation's interesting because nobody's worried about that. But for ongoing use, you
看
would
看
have to
福建
sort
那边的
out,
声音能听见吗？
everyone's time and effort and, malpractice risk, all the above.
看看福建那边的声音能听见吗？
I did some telesurgery like this at the beginning of my career with the old computer motion platform, and we did it between Virginia and Berlin. And we could move the camera and you could draw on the screen, but the latency, you could theoretically play with an arm for a minute, but it was like a big latency. So you wouldn't dare actually do a case. But you could certainly talk your way through it.
叶教授能听见吗？叶教授
Dr. Lee,
叶教授能
Dr.
听
Lee?
见吗 I'm here.
Yes, we have a question here. We'd like to know, in terms of when it comes to explaining to your patient the process of telesurgery, how are your patients understanding or so yeah, how are your patients actually accepting the concept of telesurgery in China when you talk to them about it?
Okay, in China, the telesurgery it depends on the demand. For example, we have a hospital group. For example, in our Peking University First Hospital, our hospital group have a total of 5 hospitals, and the distance from the central hospital is 80 kilometers far away. I myself go to another hospital every 2 days per week. So in the telesurgery area, we save times. We can do the surgery from the central hospital. So it's meaningful, especially for the complex cases, for the new bladder, for the upper tract repair surgery. Only the top doctor, top hospital can do the surgery till now. So Dr. Yang and me do 600 upper tract repair surgery annually. So if we have the telesurgery, we don't need to go to another hospital anymore. It saves time. So there's really demand in our hospital group. And China is very big. Many hospitals, some doctors need our teaching, and some patients need collaborate. For example, I do a lot of cases, hydronephrosis, post-radiotherapy, post-endometriosis from the pelvis. So I must collaborate with gynecologists. So the collaborate between different doctors is the remote surgery demand in the future. And for the army, for the injured. So I think the remote surgery is really demand in China now. I don't think it's any need in America because I visit America many times. American doctors don't have difference as much as China. So it's the reason why you don't understand Chinese doctor. So I really want you come our hospital to China, to Beijing, have a visiting and know us. Okay, I invite you have some time to visit us in the future for Beijing. And you will know why we need the telesurgery.
Yeah, as an example, I proctored some of the Chinese, especially in Shanghai, over 10 years ago. And when robotics first was approved over there, only the chair or the vice chair were allowed on the console.
Okay.
So that's kind of what he's saying. I don't know, maybe they've relaxed some of that by now, who knows? But the concept of consolidating up to one expert, like, what do you do, 600 upper tract repairs, that's phenomenal. So yeah, every health system may have different
Okay,
baseline needs.
Dr. Ye, can you give the control to Dr. Yang? 叶教授，您把这控制权交给Dr. Yang。
Do they have always a qualified surgeon at the bedside, or just general surgeon that give helping hand?
Are you talking about in general or for telesurgery?
Okay.
Oh, yeah.
Let's see, Dr. Yang do the surgery now?
I don't know. Typically, so like I said, when I first started proctoring over there, only the chair could be on the console. But the assistants were usually young guys who had trained abroad and come back and actually were very good laparoscopic surgeons. So there's probably a similar model.
Yes,
But yeah,
I really agree with you.
They have to have the ability to take over. So the question from the audience, you have an assistant who could take over the console if needed?
Yeah, we take over the console to Dr. Yang at Beijing. And now Dr. Yang do the surgery now. Dr. Yang, can you use the forearm?
So when you switched consoles, that was between Strasbourg and Fujian, right?
Yeah.
Yeah. So still they have not actually activated. I think the bottom, well, it's off screen now. I think the local surgeon has not been on console just yet.
I tell the gun artery, and can you see the screen? I use an annotation function.
Yeah, we can see that now.
I will tell Dr. Yang, please isolate about the gonna win. Dr. Yang, can you hear me? You decide, yes, from up, about when gonna win, down it. And ureter is behind the gonna win. So just stop to dissect down. It's okay. 我就是说从性腺静脉的上方进行游离，把性腺静脉给它分到下边去。桂林 ，OK。So I tell Dr. Yang to dissect about the gonna win. No need to dissect, and you can see, doctor, you can see the ureter just behind gonna win. Okay.
But that's part of what I found interesting.
Yeah, yeah. It's my routine.
Here when Dr. Patel was talking during the last presentations, when he said that you don't ask about, for robotic cases, you don't ask if there's blood anymore, you don't ask if there's open tray. So it'll get to the point where you need the surgeon on the other side. And I've said this to him before, you don't ask if the blood's there, but it is. You may not see the open tray, but it's there, you know.
更多。橡皮擦。I use the rubber.
The intra-op consult's an interesting idea. Like, I mean, this is a clearly planned, clear your schedule, everybody's ready. You wonder what's the concept if you had a network of hospitals where there was a ureteral injury unannounced at another hospital, could they scramble a connection and have a urologist fix it remotely?
I think that's, you know, one of the things that talk about the ultimate goal here is, you know, intra-op consult. Okay, yeah, I'll go sit in my office and log in and fix what you need me to fix and then log out.
Or in some cases, like they've little bladder rent, you know, and they consult you because they've already fixed it. They just want you to bless it.
Yes.
Or take responsibility if it leaks.
I asked.
Dr. Yang, how about the latency? Kunlin, 能听见吗?
We're getting to know your fellows, like you said, proctoring would be nice, but they also have local help.
Yeah, like what's the rate of fellows taking a job where they're going to be like by themselves? It does come up, but it's usually Canadian fellows. If they're going to go to Ontario or something like that. We had one fellow that, believe it or not, did an extra year with Gil at USC because he was going to go to, I think it was Ontario.
Yeah.
I think he changed plans later, but that was the concept of it. He was really worried about all that. Or the guy they mentioned, Aldasari, he was one of our fellows. He literally did come back to kind of a vacuum in Kuwait.
Yeah.
And he was thinking about doing
Dr. Yang, tune the scope.
Doing it, and it worked out well. But But most fellows join a
昆凌
department
听不见是
or a
吧？
big private practice where there's going to be some expertise. But on the flip side, like I learned Retsia sparing many years ago from Kun Ra in Korea. And one of the challenges is Ra is ridiculously fast at that operation.
昆凌让叶教授
Usually it's
他
the
们把
fellow
声道漏
who
加
flies
闭
the。seminal vocals in the posterior plane and get the bowel out of the way.
Dr.
And
Yang,
then Ra takes over, and the rest of the resections, 20 minutes give or take, and then dry it up, sew it up, and you're done. So I learned it, but it took me like 3 years of stop and go to really go through the step. It would have been great to have connected to Seoul and say, can you walk me through the first case? Because we call it the shoulder turn when you go from the part you're used to, down low, dropping the denanviers to turning up and around the nerve bundle without that lateral and anterior orientation. It can be done, but if you've never done it before, and there may be other variants of that if someone's doing their first neobladder and they haven't really done all that sewing all at the same time.
Dr. Yang,
To the extent these connections are just sort of an included part of any system would certainly help. Some of this is a surprise. So, for example, at another robotic meeting I do is called NARIS, that we're always in Las Vegas in February. And we started a collaboration with a local private urologist who's very busy, who would have us come to his hospital and do cases with him with a live transmission. Mike in the back is our go-to AV for that. But that meant we would all have to get a licensure with Nevada for the day and sometimes an insurance malpractice rider for the day and all that. So that we could, it was great. You could go do a case, come back to the conference, 2 days.
是吧？待会他们听不见。
Some people were
那个
required to
昆凌
operate
他们
at
听
their
不见我的
local
声音，没有反
hospital
馈。
for their own guidelines.
昆凌能听见我的
Just
声
the
音吗
meeting,
？Dr. Yang, can you
other
hear
than the
me?
case, and sometimes those cases, they would have to hire an external audiovisual person to do it. It'd be like 5,000 or more of AV costs to do that transmission to Mike's end.
Dr.
The
Yang,
collaborator, I think it's from
me?
Storts. I did one back in February,
Please
and it
don't
was
think about-
literally with the software built in, it was just a Zoom call to Mike. There was no cost on our end. And so I could do the case on a Saturday with my team, no change in licensure. So you kind of need little incremental gains like that. Where now we could really open up
他们得不说才
put
能
our
听见。
surgeons very
OK
carefully for a live case. We've had VIP do several, which we usually don't do 2 at a time when VIP's there. Otherwise, they'll miss most of the case if you're trying to do 2 at a time. So I think the ability to just have it as part of a built-in connection that you just turn on as needed, not some massive platform that you're going to have to use daily to justify. So that'll be a game changer.
You think this leads to things like universal licensing, or regional licensing, and things like that?
Talk to me about it. My younger daughter's about to take the bar for Texas, but Texas is part of a collaborative where it's good for like 9 states.
Okay.
And part of you're like, well, why isn't the whole country? Why do you have
Yeah.
50 states with different legal and medical licensing?
OK, thank you for your comment. Because
Granted, in law, the law is
voice, you
different
have
by
the
state,
priority
but
for the
bodies are
voice.
not, you know,
If you
for the most
talk, my assist doctor cannot hear my voice.
Yes.
You have the priority first, priority for the voice control. So if you talk, I cannot communicate with my assist doctor, professor. Dr. Yang, can you hear me? 昆凌能听见吗？
I mean, I guess that means you'd have to get the federal government involved somehow. Is that about the only solution to
这个
this?
设计的是
Otherwise,
会
it's
场
gonna
声音
be-
优先吗？
Again, as I said in the other system, the other way around it is compact licensing. So during COVID, a lot of states relaxed state rules. So like, 'cause in Texas, like half of Louisiana is closer to Houston than to New Orleans. Don't tell Raju Thomas that. But, so they relaxed all that so we could take care of people at home as needed. Then they started putting the rules back in place, but the hospital really liked the ability to do more of that. So like I personally, they have a staff now that does this. I have licensing in 9 states. And Now, I did just get a bunch of CME rules, so if they really make me do different CME criteria for United States,
把
I
这
could
个
fall
给我
apart
退
fast.
出来。
But in theory, the idea of having that, I don't think that lets me operate out of state because it's for virtual medicine, but I'm sure
我
that
要
could be
退出这
tweaked.
个，
You just have
把这
to
个
add the procedural
不能退出来了。
credential to the mix.
退
Or
出
it
来，我
becomes
不要
part
这
of
个标注
massive
了，我要
states
看看
like
那个多录
Texas
屏
that。have, I don't know, 30 million people or whatever we have.
接触共享。
11 hours from one side to the other.
退出批注。我的扬声器为什么关了？
Seems like there's more shared licensing in Europe. Depends on the location. But like I know, like Norway and Sweden is one credential. UK credential definitely goes to Australia, for example.
Ah. 怎么个退出法呢？哪边关了呀？哦。
Right. For sure. Yeah. Well, I mean, getting off topic, but if there was more federal oversight, that might solve the problem of people with malpractice just, escaping to another state, if there's oversight, because otherwise, that's why every time we re-credential, they ask us 30 different, are you a criminal, questions.
昆凌能听见我声吗？
If yes, please explain.
昆凌能听见我的声音吗？怎么还听不见我声儿？昆凌。
They went very quickly on this, but I think we can see the stricture, right? That's kind of the transition point. They went through the X-ray for about 2 seconds, but it looks about right. So hopefully this is just a straight up plumbing repair.
Do you think there's an argument, if somebody could make the argument against the intraoperative consult or the spoken hub method, as it could water down surgical skill for the mass of surgeons if the same people are doing things over and over?
Possibly. A related concept, a long time ago, our sort of like public health team did a paper on the volume relationship between radical cystectomy and very morbid operation. Because if you looked at American Board of Urology stats, like at the time, the average urologist was logging in like 2 cystectomies a year or something like that. Now it's probably you do 30, 40 or 0.
我还是想跟他们对立，我切回一个来，我在
What
动。
that did then, if you're then saying that if 80% of Texas
hear me,
doesn't have
Colleen?
enough volume to do radical cystectomy, not everybody can afford
Give me the
Houston
control.
and sit in a hotel.
Give me the control. Okay.
For their families,
I
like
take
for
it control.
prostate, we can get prostates in and out of town in
Okay.
4 to 6
It's my
days,
turn.
depending. A cystectomy is going to be much longer. So you
I
do
want to
you get
identify
that
the
problem where someone
obstruction.
doesn't have resources and they're 8 hours away. There might be a need for it that is being unmet right now, and not watering it down.
But does that lead back to kind of, high volume centers get better outcomes, right? So doing the cystectomy is great, but if the people in the remote area can't take care of the cystectomy post-operatively, what are you really doing for the patient?
Yeah, that's a good point. I think if on the flip side would be if the surgery's done well in the first place, then the rest of it's probably medical care that they probably should be able to handle.
Yeah.
Because they should have a functioning ICU and pulmonary doctors. So I know there's a mixture of complications after cystectomy, but surgical in the downstream probably still leads the way. Or it's something, and that's where, in theory, you could apply this technology to other areas. I mean, what are probably the most common interventions after a radical cystectomy is not a return to the OR, it's a return to interventional radiology to drain an abscess or, restent a ureter that was leaking. That's actually far more common than actually having to literally go to the OR. And then past that, everything's medical complication treatment. So you'd have to have an IR. That's actually our bigger issue with like lymphoceles in the community is they want to transfer them in because they claim there's no IR doctors. Like, really? The whole hospital, you don't have an IR doctor? Let me look that up. Sorry, we've been bantering on our own here. Back to the surgical team. Do you want to talk us through your plan for excision and repair here? It looks like you're pretty close.
Yeah, thank you. This is the side. From the antegrade and retrograde urography, we can see a complete obstruction of this side. So, resect it and do a ureter and ureter anastomosis. In our team, we have a S-shaped incision. From here, cut it, and this direction, and like an S shape. If it's the side of the obstruction, we can identify where to anastomosis. For here, or here, or here, it's okay. And we'll do a tension-free anastomosis. This side to this. From the S-shaped incision, we can control everything. So it's our standard technique. So Dr. Yang, can you do it for us? Can you do it for the audience? Thank you. I give you.
And remind me, this was thought to be a kidney stone related stricture, right?
Yeah. For this patient, post lithotripsy 3 months ago, used the laser, and the ureter was injured. For this patient, if the obstruction can pass the get well, maybe the balloon dilation is the first choice. But from the urography, we can say it's completely obstruction. So we use the robot to do a ureter and ureter anastomosis. Dr. Yang and me have upper urinary tract repair group. We treat over 3,000 hydronephrosis all over China, even from New Zealand, from Japan, from Germany, from France, from all over the world, refer to our team. So very, very high volume. We have multi-center database, we call it IRCAD. Till now, we have 40,500 cases.
Yeah.
This is a question from the audience. Do you have any experience with buccal mucosa graft in a upper urinary tract reconstruction?
I'm sorry, can you?
The question about buccal mucosa grafting.
Oh, it's my favorite. Dr. Yang do a lot of buccal and lingual mucosa graft for repaired ureter. Nearly 200 cases in the recent 5 years. Among them, Dr. Yang, as a top doctor, used the appendix. Dr. Yang is the top doctor in my country to use appendix to repair the ureter for the right side, only for the right side. Dr. Yang had done over 60 cases, right ureter defect. Use only graft or interposition. Dr. Yang, can you tell the audience question, you experience to use appendix to repair ureter? 克林，说说你在用阑尾修右侧输尿管的经验。 No voice，昆凌的声音没有。我怎么听不见昆凌的声啊？福建那边没有 POS 检是吗？In Beijing, we have a POS scissor available in our hospital, but in Fujian province, maybe it's not available right now. So Dr. Yang use a suture to suspend it, to help to cut it.
At the semi-live sessions, we get so spoiled at seeing mostly 2x video, then we're like, oh yeah, this is normal speed. Hit the button.
There's some problem between me and Dr. Yang's communication maybe. So I will talk about my experience about buccal mucosa. In China, most of doctors select lingual mucosa to repair the urethral structure. So we learn from the doctor first. We harvest the lingual mucosa first. After 50 cases, I transferred to buccal mucosa. And now I have two cohorts, one lingual mucosa, one buccal mucosa, nearly 70 cases versus 70 cases. No difference. All is very safe for repair the lung defect ureter with a success rate over 90%. And
At
for
what
the
length of stricture do you start using buccal?
I'm sorry?
At what length of stricture do you start using buccal versus a primary repair?
Relatively shorter than 6 centimeters. Because the buccal mucosa, it cannot harvest too long as the lingual. The lingual mucosa, it can harvest over 6, 7, even 10 centimeters is okay. But the buccal mucosa, only 6. So most patients, not shorter than 6 centimeters, we prefer buccal mucosa first.
Dr. Lee, do you have any experience with like biosynthetic grafts for repair?
I'm sorry. There's a lot of noise.
Oh, no, I was asking if you have any experience with biosynthetic grafts for repair.
I'm really sorry.
That's okay.
Slowly. Say slowly.
Like biologic grafts.
Biologic, never. I never use biological material to repair ureter because I concerned about success. Till now, no biotic material better than the lingual mucosa or buccal mucosa. So, in my idea, in my opinion, the success rate must over 90%, at least 90%. It's the key problem. So I don't trust the biomaterial. Only self buccal mucosa or lingual mucosa. And what's your opinion? What's your opinion about that?
No, I agree. I was just wondering if you had any experience doing that.
Yeah, I totally agree with you. But I do the basic research. I have a group of research team. I do a lot of basic research to use the biomaterial and 3D, all of them. I try all of them. But till now, only in animal model. Only in animal model.
Do you stitch the buccal mucosa graft to the psoas plane?
多来一个导管。
I'm sorry.
Do you stitch the buccal mucosa graft to the psoas plane?
Spleen?
Or just let it free?
Not keep it free. I use the buccal mucosa to do the only graft and wrap it with
Omentum.
omentin. Usually, all the cases I use omentin to wrap it. Some cases use the fat to wrap it. So I do this repair cases every day, 6 days per week, 6 days per day, 3 days per week. I and Dr. Yang focus on the upper tract repair. 刚才说换一个全新的剪刀哈，那边有吗？
没有剪刀。
没有哈。OK。
没有新。
OK。
但是比
Next time we will prepare a new scissor because it's so delicate. In my team, for this case, new scissor for ureter, 5 times scissor for partial nephrectomy and prostatectomy. All the nurses know me. 在北大，我们好剪刀、新剪刀都给修复团队。用3、5次以上的是给肾部分和前列腺癌。
应该的。
是 OK. I got priority to use the new scissor.
You can see how this would be a good, if this telesurgery weren't part of it, this would be a good single port case. Then you get a new disposable scissor tip for each case.
Are you doing a lot of
今天助手是谁呀？叶教授，今天助手是谁呀？
Hostile abdomen extracardiac type things. The niche robot.
林荣成是吧？
Head and neck uses.
还有一个蔡医生，蔡华来。
哎 ，OK。
It'll be interesting in this next year because now there's indications in lung and colorectal. So we'll see if the lung surgeons have already started posting. So it was kind of underutilized. Now it might get busy. We'll see. If you're wearing those stream glasses for the console, is the rest of the room distorted somehow, or just shaded?
When I've sat down on the King Duo, you only really see the screen unless you start moving around. So it is a little kind of faded out, everything around you.
Are there any single port telesurgery platforms yet, or is that coming?
I think the Shruri from China,
Yeah.
I think they're telesurgery capable.
I know Singapore, the Shruri robot can do telesurgery.
Okay.
Definitely. Shruri, Microport, Edge Medical, and at least 9 Chinese robots got a license right now. So I try all of them. I try all of them in our hospital for clinical trial, for the RCT.
When is the King Duo single port coming out?
Condo is focused on the multi-port robot. Single port robot is not available right now, but maybe in the future.
You may know the answer to this, Travis. What did it take to get this case approved in terms of from French government and China?
That I just know that was a lot of paperwork. Do you know, Dr. Lee, what the approval process was for y'all to have a patient in China and operate from France?
The police, we got the proof of ethical approval and got the permission by our government. 崔主任，这个咱们经过了伦理审查是吧 ？I got the proof, and it's in our clinical trial. We have a prospectively clinical trial. Use the condor do the remote surgery. I got all the paperwork, so.
But including from the French side as well, right?
Okay.
Hate to think about it, but I guess logically, if there were a malpractice issue between two countries, which side resolves it? Or do they both have to resolve it?
I think so. The way I think about it is it's more than likely where the patient is. I think it seems like the most logical, but it'll probably, whatever's the most litigious will probably win out.
Yes. I don't know, that's good. The question from the audience about, is there a Firefly or ICG type of capability in Kangduo?
Yeah, the Firefly function depends on the scope. For this time, we use a Chinese 3-in-1 scope as a Tuge brand, Tuge company. 3-in-1, 4K, high density, have the ICG Firefly function and the 3D. You can see the image is very good. The quality of the image is very good. We can show the ICG function. Maybe I will communicate with Dr. Ye. 叶教授，您那边有ICG 那边
没有。
OK， 今天是华左康是吧？
对对。
OK。
好，观众等会儿我再剪一下这个。
The audience can go to the exhibition hall to test the Tuge in the booth of Condor 3-in-1 scope. This time in Fujian province is another Chinese brand, Wilson Healthcare. It's 3D. So in our hospital, the Firefly function is a routine in our team. We test the blood supply and maybe endow the ICG from the STEMI stop to identify where is the lesion to obstruction, where is the scar.
So does that mean the camera on Kangduo is a third party, basically?
Yeah.
15厘米的单条线有吗？如果没有的话，就要微调吧。
昆林他们有 PDX 线 ，PDX 线非常好。昆林不，它的 PDX 线非常好。
Dr. Lee, is the scope for Kangduo third party, or is it you accept like universal scopes?
No, every scope you can select compatible nearly all the scope in the market. Stores, car stores, Olympus, Healthneck, Psych. All the 3D scope is compatible to Condor. It depends you.
15厘米的 PDX 线也可以。PDX 对 PDX 15厘米。5个0是吧？5个0的。OK， 有的。
那我们荧光上面显示的那个镜头，那你中文那里基本上镜头，我们这里有，这里有，
那接不了。哎，学生教授，我们有那个华洛康的无光的回传镜，但是接不到机器的。
I know。下次我们把这个荧光的镜子我们接上。我听说了，这个图格呀、华德康都有3合1的镜子哈。
有的，我们都试用过。
好的 ，Next time we'll try the firefly function of the Chinese 3D scope. OK。OK。再说一遍。OK。Okay, Dr. Yang, the site of Kazakhstan is ready. So 1 minute later, we'll transfer from Fujian to Kazakhstan AMP2. OK? OK. 你把控制权交给这个叶教授吗？您把这控制权暂时交给叶教授，叶教授可以稍微的、慢慢的跟昆林教授啊交流啊，慢慢缝一下。哈萨克斯坦那边的远程的那边已经开始准备好了，我们要切换一下。好的。您跟昆林来交流一下，慢慢缝不着急，或者您歇一会儿都好，歇一会儿能。对，昆林得放下这个控制权，要不我们过不去，是吧？
我放下控制权。
对 ，OK。叶教授，您接手之后呢，您可以歇一会儿，或者是跟昆林呢在语言呀、视觉上交通交流一会儿哈。好的。OK， 我们切换到哈萨克斯坦了哈。OK, doctors from the SRS, the side.
So as I understood, I think we're going to the partial nephrectomy case, Mike, or not? And but the IRCAD team's still going to direct that.
Okay.
All right, we're back with you.
Hello, doctor. This video from Kazakhstan.
All right, good to see you. Maybe catch us up to what y'all have done, and we see the patient case details already.
Okay, please play the video of the case. 那个患者的资料放了吗 ？Okay. Doctor, can you see the patient detail?
We're on 4 screens now, so we've got inside, a couple of exterior shot. Now we're on exterior shot. And now we're on interior.
It's a right side kidney tumor, anterior lower pole.
And are they planning a full clamp of the arteries or partial or?
Usually, Dr. Hussein don't clamp the artery, but for the left surgery, maybe Dr. Hussein will select clamped artery to make it safe and everything under control. Maybe. I prefer clamped artery. The distance from France to Kazakhstan is better than before because the laminar distance is shorter. So I can feel the distance is so. I can control it.
Are you noticing less latency? Because it looks like your speed is picked up.
Yeah, the latency is 120 milliseconds.
And it's the same type of connection as it was with China, or is it different?
The same. Only the laminar distance is shorter. 哈萨克斯坦到法国多远呀
？1800左右吧。
6,000 kilometers far away from here. So the distance is really important. Dr. Yang, can you try it? I give you the control. Dr. Yang, Dr. Yang, you try it. Take it.
Then where's the other console? Local or?
Yeah, I transfer the control from France to China.
Oh, so China is now linked in to Kazakhstan. Okay.
From Beijing, France and Beijing to Kazakhstan. Three separate console, 3 doctor, 1 surgery.
Это сейчас операция продлится. Вот теперь продолжить операцию.
昆凌这个延时会比较长一点哈，你稍微慢一点。昆凌，你一般的操作比例是多少
？Open console platforms.
I've only done them in demonstration halls. So, guess we didn't get to see the ICG, but I guess with all those multiple screens, it opens the possibility that you could just have both up.
Yeah.
Whereas intuitive, you're either toggling or you've got to go side by side.
Yeah, no, I've seen them and they've had it like that, and they've also had, 3D reconstructions on the top, CT images on the smaller screens. Dr. Lee, do you have a 3D reconstruction that you're viewing during this operation, or no?
Yeah, if in China, in Beijing, nearly every case I use the 3D reconstruction before to design and use the navigation, use the upper screen to navigation. I have a total nearly 6,000 cases for the kidney cancer, for the hydronephrosis. We have a database of Recator database, multi-center. We have the data, and we have the image, nearly all the CT scan, but in the multi-center database. But for this case, only no contrast CT scan, no contrast CT scan available. You can see this patient only no contrast CT scan.慧林能听见吗 ？Dr. 杨？
我能听见。
能听见。
Yeah。
你那边这个延时怎么样？
还可以。
还可以，应该是150。The latency between you and the customer is 120 millisecond. 你在哈萨克斯坦之间的延时是120毫秒。我这边也是120，是吧？
What was the threshold?
对。
Literature says 150. Notice the. I've seen different. I've seen over 100. I've seen over 150.
一会儿让 Dr. Husan 说一会儿，是这意思哈？
现在吗？
啊？
现在切过去吗？还是
？OK， 哈萨克斯坦那个康德工程师在吗？
在呢。
哎，你跟那个 Dr. Husan 说一下，准备让他操作啊。
好嘞。
OK， Husan, it's your turn. Professor Husan, it's your turn. OK。
Husan 马上到你们。
Okay.
It's an interesting discussion I had with Jim Porter, who's working part-time with Medtronic on this topic of different constructs. Hugo and others that are open and very different in design, they have to budget in a certain amount of effort to train new surgeons. Whereas some of these companies are making very, very Da Vinci-like platforms, and they essentially don't have to train anybody because it's just if you're a Da Vinci surgeon, you can just cross over.
Yeah.
Right. Maybe a quick check-off. So it's.
You think it'll come to the point where you'll have a platform that'll give you
我有点冷，
console
能不能
options
稍微温度高一点
that you can either have open
Plug and
or-
play.
Yeah.
Immersive is there now? I haven't heard that term till now. Well, we're breaking in Da Vinci 5, and we collaborated with Intuitive, kind of made a big deal of having like early users and web trial and stuff. And now that I've done it, it's like, that's kind of overdone.
Yeah.
I mean, Da Vinci 5, you need about, 10 minutes of updates.
Yeah.
The rest of it, you can figure it out later.
Dr. Husan, can you hear me?
even sitting down on the King Duo, once you get used to the fact that you're on an open
问问那边他
the
准备什么
usability
线了，
is
缝线。
pretty much the same. The hand controls are
他
the
们这
same.
边没有倒刺线。
什么？
Yeah, there are DaVinci-like grips, not the.
有倒刺线吗？
没有。
It's just the
用
only
什么
difference
线呀？
really is the open versus the.
他们这边这种丝线，你需要那个风不漏的夹子一点一点。
You don't have to hit the
Okay.
pedal twice to cauterize,
okay.
do you? End up being some weird
是2个0的 V 小
Hugo,
2个0的那个
tap once to turn on, then another to fire.
V 桥线是吧？你问不是丝线，可吸收的哈。不是
可吸收的 V 桥。
不是
And
对，
the
是2个
instrument
0的吗？
libraries similar? Is there advanced energy
要
stapler?
20到30公分长的哈。
Basics.
When I was there, they did not have those. They had all the basic instruments.
Yeah.
I don't know if they've. Dr. Lee, for
Yes?
the King Duo platform, do you have any advanced energy instruments or staplers, or is it just the basic instrument library?
Till now, only basic instrument is available, and harmonic scalpel is available.
Harmonic. Okay.
Maybe in the future, the ligature or stapler in the future. Okay, the duodenum. Dr. Husen. 把那个标注给我拿来，标注，工程师标注给我打。
So the top right feed is Kazakhstan, right?
Yes.
Okay, so they're on the local surgeon right now.
Yes.
Okay.
Be careful for the duodenum.
Yeah, so it's basically the bottom two plugging into South China and Kazakhstan.
OK，工程师康多的工作人员把那个控制权交给我来。他要 Dr. Husen， 把控制权交给我。Give me the control. OK。
多少现在可以把控制台交给房东。OK. Thank you. It's okay. OK， 你好。多了，我给你了。
OK。
接话。因为Thank you.
Doctor, help me to press it. Okay.
Okay, now we're back on Strasbourg running.
Another. Only one assist port. 问他只有一个注入孔吗？再打一个。
Question on the multiple consoles. Can, like on a DaVinci dual console, you could reassign all 3 arms or just 1 or 2. Is it the same on Kang Duo, or do you have to reassign all of the instruments, or could one surgeon just be running, like an assisting pro grasp all at the same time?
Yes, in Kangdo we have a separate console, separate arm, 2 console. But now only for the clinical trial. Maybe we can do the international clinical trial to test the 5 arm 2 console in the future. We can say the duodenum.
When we were over there, Dr. Patel and I did 2 console 5 arm to where we were both operating at the same time.
5 arms running? Okay.
Yeah. So they have a 4-arm platform with a single modular arm they can roll up and plug in, and then you can use 5. So it's one surgeon would have 2 arms and could retract and do things.
With articulation. Yeah, always wondered about that. That's very nice.
So this is a duodenum.
Was there a particular reason that you decided to take over, Dr. Lee?
Yeah, because
Just expanding on the proctored model, what we were talking about, I would say that when we hire young faculty at Anderson, occasionally might call me in if they get stuck. But more commonly, they might call in if they're just having a slow case due to various challenges.
yeah,
So if I'm available, sometimes I'll just do the lymph nodes for them. I just call it a fast forwarding service, just to avoid like a 6-hour case or something like that. And obviously this setup could do that if someone were making progress slowly and
please
maybe an expert could
have
move it
to
along,
put
and
it.
then, then the next case they
Doctor,
get
please
faster
help
and faster.
me. Please help me to put it. Dr. Husa.
I mean,
Yeah,
I know
okay.
it's not quite
Okay,
the same,
okay.
but it's the same
Press
concept.
it,
I'll do
okay.
that with fellows. If they're kind of slow, I'll just get them to, all right, you need to start working on bladder neck. I'm going to get you there quickly so you have more time to do that before Patel loses his patience and comes in and takes over.
That's right. That's why I asked about the independent arm assignment, because with brand new trainees, sometimes like for a drop in the bladder, endopelvic, I'll actually run the progress just to move them along.
Yeah.
And then it's actually, you can do a few new things with it if all 3 arms are active, as opposed to, one goes to sleep.
Oh, yeah, for
when
sure.
it's only one surgeon on.
That tends to be their biggest problem.
And I have to make myself take my foot off the camera pedal also, or I'll just instinctively start moving it, and then you fight each other. It's like, all right, run it, but do move the camera.
Yeah, I have to do that, or I have to either sit on my hands or remove in my pocket. Well, no, there's.
You help me.
We don't have enough.
Press it.
No,
Press it.
it is longer. I mean, it does take longer. Yeah. The ones that Dr. Patel has done and what we have done, it is longer, but it's not significantly longer, right? I mean, but you're also talking about we're doing in person an hour prostate, right? So, telesurgery, it takes us an hour and a half, hour 45 minutes. Yes, it's longer, right? But it's still shorter than the common prostate, right? But I think naturally it's going to be longer just because the connection, you're operating slower. Yeah, you're more cautious, or you try to be more deliberate, about your movements. And I think with this surgery, you could really tell the difference between when the guys that are closer to the patient are operating, they're going faster than Dr. Lee is. But it's like Dr. Davis was saying, if you get to a point where even the local surgeon is going to take 45 minutes longer than an expert surgeon that's operating slower, but still only going to take 20 minutes, you're cutting 20, 30 minutes off a case or whatever the case may be.
I almost wonder if you could have a training simulation where it could produce latency for you to get maybe used to that. What I can't tell, and this is what I was asking about earlier, is I can't tell if they're slowing down because they're waiting on the instruments to move and catch up to what their brain's telling them. I mean, if it's instant, you should be able to operate naturally. I mean, cautiously, but naturally. If there's a slight lag, you may have to kind of factor that in. But I wonder if that with repetition, you could get your brain could get used to a latency, Just like those visual tricks, you know, when you're like trying to focus on a 3D, you know, one of those puzzles or something like
I
that.
think you get used to it. When I really notice it is suture. Yeah, that's when I feel like it bothers me.
这个延时昆凌这儿比我这好一点是吧？
And do motions as well as pedal operations have the same latency, or are those different too?
我这边见，
I don't know the answer to that question.
这
I
个
don't know
这
if
个
we've actually talked
这个
about
显示器不行，那显示器它这
I
个
would
散
assume
热效
it's
果呢，
like, you
不
know, from
如
the time
不
you
如
hit the
那
pedal
个
to when you actually see the effective energy. There is some latency to that. I don't know if it's equivalent. I would assume it would be because it's going across the same network. But I know motion-wise, at least MedBot, they've looked into
These
actually comparing the latency to your movements and then scaling the instrument movement, right? And that kind of helps with the latency side of things. Like developing a program to where if you do have latency, that the machine will automatically slow down your movements in transition.
'We've talked about possible ways to use this. Does anyone in the audience have a particular telesurgery scenario different that we haven't talked about yet? Maybe there's other applications we're not thinking about.
The 显示我这儿的比昆凌这儿好。
The 5-arm model is worth following. A long time ago, I was a VP at Cornell when Tawari was still there. And the way he had initially trained under a 3-arm robot, you know, he accomplished it by having 2 full-time assistants, laparoscopic. And when I happened to be there, he was, even though the 4-arm was available, he was just used to having the same 2 people on the side. And they figured out how to make it work. But, you know, as a visitor looking at it, I was like, yeah, you have that extra assistant, but they can't articulate. And so they're kind of in your way. I mean, they figured out how to stay out of each way. But I was like, I would, even if I had 2 assistants, I wouldn't want to do that because I'd much rather have an articulating progress than a person, even though they're live as opposed to static. Man, if all the instruments were articulating, I can't imagine the efficiency you could pull out of that. Because like we have certain of our younger staff, like I trained in the laparoscopic era, so I'm used to an assistant trying to actively assist. Because, you know, in the laparoscopic prostate era, you couldn't survive without a really good assistant basically making up for non-articulation. But some of the younger guys who've always been on a robot, I watch them. Sometimes they almost tell the assistants to like get out of my way, suction, but like be absent, and they're not trying to laparoscopically assist. But man, if they could come in and turn an angle with your progress, you could do all sorts of stunts. Maybe it's not. Maybe it's cost prohibitive, or maybe it's not. I don't know.
Well, yeah, no, I don't know, but I think it's. And then somebody brought it up yesterday in the plenary. Even things, you know, in the colorectal space, having the 5th arm be the uterine manipulator, or you know, things like that, and it's.
I mean, I know Da Vinci does make a suction, which hardly anyone used, because to use it, even if it was an articulating sucker irrigator, you would delete your progress essentially, and you know the assistants couldn't really do that as well as a progress could. But imagine if they could come up from below, articulate and suction, be off screen almost.
Yeah.
Come in on the top and.
But it's even from the suction standpoint, people are trying to do that all on their own too with
the drop
Rosie
sucker
and things like that. Do you use that at all, or?
For single port.
Yeah.
But I've seen like one of our colleagues at Naris, Rani Abaza, did single port for a period of time and decided he hated it and dropped it. But then he reinvented his multi-port with all the lessons learned from single port. So it's 4 robotic arms, no assistant ports, drop-in suction, low pressure.
Yeah.
And he makes it look really easy, but you know, that's Ronnie world, as we call it. Yeah. 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 Disposable, right? I think that, yeah, I've seen articulating lap, but they're disposable, they're very expensive. I don't know if that's as practical, but in theory, you could retract and get out of the way. Because otherwise, no matter where you put the assistants, if they're on rigid instruments, they can help in certain spots, but in most of them, they're colliding.
Yeah, but especially on prostate on the left side,
Mhm.
like if you have any bleeding in the left corner and your progress is pushing medially, they're trying to come across.
Mike, is Mike still back there? Where'd he go? Step down. I think we have the transmission till 12:30.
Yeah. 12:30.
Stop it. At 1:30 for the other session.
Because this patient cannot do the contrast CT scan, so the artery cannot get exactly side.
Was that due to availability or the patient?
For the patient, maybe. You know, not all country developed. Kazakhstan maybe, like China, developing country.
Just a little narrative to show the detail you'd have to pay attention to. So obviously at our robotic center at the medical center of Houston, the hospital has, of course, an extensive backup generator system for power outage that can go for, there's enough fuel to go for a day or so or whatever. But we built a surgery center out in the suburbs of Houston, and we have an XI out there, and I'll do straight up cases with a PA out there once a week. But that building is on a residential grid, and so if there is a power failure, it would affect it. So we realize that. And the problem, even if it flickers, the robot has to reboot, and it could be very disruptive. So we're actually in the middle of designing a battery pack backup that would instantly bridge for an hour or so.
That actually attaches to the robot, or
to those outlets?
Oh, okay.
You know, it'd be a big lithium pack. So they haven't quite installed it yet, but it's under dissection, because and I just bring that up because a lot of hospitals are investing in surgery centers, and you wonder if the telesurgery would be part of that potentially. But you even have to think about power backups to all this.
No, it's true.
Yeah. There's an audience question about your dissection sequence. Are you going to track the psoas at some point, or are you going straight for the hilum?
Sometimes I go straight to the Helen, but for this patient, have BMI maybe 30, maybe 30, a little bit fat. So I elevate the kidney to expose the artery. It depends. If in my hospital, I do the CT scan first and judge the exactly approach to the artery.
I think the Chinese definition of high BMI then is a lot different than the American definition.
Yeah. So the partial nephrectomy in China is relatively easy because the BMI is small.
As one of my favorite made-up terms, occasionally I will use the single port on really, really small people, or as I call them, morbidly petite. Sometimes single port is easier than crowding 6 ports on these guys that have a, whatever, 28-inch waist or something.
Yeah.
It's interesting how the top screen froze, but you could see his was active, a separate transmission thing. I wonder if we had 3D glasses, would we see 3D on his screen down there? Would that transmit through a transmission? Or?
Suction, please. Suction, please. Thank you. Suction, please. Pull down. Suction and pull down. Thank you. And see this, maybe this is artery. Maybe this. Okay.
东老校查处。
以后再有这种病人，应该叫张中元过去，是吧？
行。
应该让我的 my super assist doctor。
他刚刚在就是采访他的时候，他说了一句，这是他在中国最好的朋友，来这以后说是做的最厉害。
是啊 ，we are best friend。嗯哼。你看过 CT 吗？在这个静脉的后方，静脉的后方，你说这么肥怎么弄啊？太胖了。Do you have clip? Clip? 能够翻译一下夹子 ，clip。 Hemlock or Titan clip. clip。夹子，刚才我准备个夹子，钛夹。钛夹哈 ，clip。
钛夹吗？
钛夹对。
他们这儿好像没有钛夹。
它叫 hemlock。
钛夹有。
hemlock。
请检查医生
不，别着急，
给我
控制台弄一下。系统报错，给我摁一下。动不了了。OK。
I assume the general interaction with the assistant, not a whole lot different, as long as the microphone's working, et cetera.
Yeah, no, it's, but again, it goes back to the latency issue. As long as that's low, I think everything works pretty much the same. But when it's higher and it's noticeable, then it's kind of this awkward dance about getting the clip in the right spot. And
这他妈手术太危险了，我告诉你。
And is the audio
到时间给我
setup
掐了，
part
别
of
玩
King
了。
Duo, or you have to sort of provide a microphone
到
setup
时
around
间让他们改成俯
no,
向
I
镜
think
头了，别玩
I
了。
think that part's separate.
I was bringing it up because the new DV5 has a really sensitive mic system.
Does I have to turn it down?
Yeah, because otherwise I'm hearing everything in the room, people crumpling paper, or anesthesia making noise.
然后咱们转到那个福建去，让昆林做远程，好吧？好的。这太危险了，我觉得交给呼森，让他们自己做这个腹腔镜啥都行，就别让我再分了。我有点儿 a little bit concerned。
这个他们应该自己能做，这个看人做惯了。
啊？我自己肯定可以，你看，this is the artery。动不了了，那边给我报错了，动。
辛苦了，辛苦了。
昆凌，你说啥意思？
我说让他们本地端的做嘛，他们好操作。
OK。我把动脉看能不能分一下哈。
Hey, you have a question?
等会儿我再让你小心一点。啊，走，那就开始。非得让我报复你。
好。
哎呦，
很危险哈。
让他们操作吧，李老师，这个我觉得，
OK。
有个分叉动脉，有个分叉感觉是。
OK.
So the latency question, if you're in a 3-console setup, they're different connections, right? So it's not all one connection. So if one has a higher latency than the other one, then you can switch consoles to the other connection.
让他们来吧，分身。OK, Dr. Hu
because there's a connection from Strasbourg to Kazakhstan, and there's and there's also a connection from China to Kazakhstan and the Strasbourg.
我听不清楚，你声音大点儿。
So say
Bit
the
louder.
Strasbourg to Kazakhstan is too high, you can go with the surgeon who is in China.
不，都让他做吧。我这边你先让他做，然后我这边时间快用完了，还有几分钟。
Oh yeah, no, from the
10分钟是吧？我这还有10分钟。
The point behind the 3-console surgeon is something like that, right? From a training perspective, proctoring, having an expert surgeon do a part of the case that you're not comfortable with, or something of that nature, right? So yeah, from a clinical perspective, it's definitely things like that.
I think a valid point of what's the incremental value of triple over double. Like, why do you need a third site?
Well,
other than to show it can be done.
Yeah, that's a fair point.
And the third person gets a great view, right?
Yeah, Dr. Hussein from Kazakhstan takes the control.
Looks like they're back to local control. Okay, they're going to go in. They put a, I missed it. They bulldog anything, or he just sort of found it?
I wasn't looking.
Yeah. Or he didn't put a.
Was there a clamp?
No, I know he didn't clamp it, but I mean, he didn't put a.
他的那个动作比较粗大。
or anything.
李老师应该让他再分动脉吧？那个动脉是不是还没分完呢？
别分了，你看他的动作，你看他的动作了吗，坤林？就是他分肾吧，这个地方不阻断肾动脉，他都可以干，没问题哈。这个。For this patient, very adhesion of the peri-fat, the MAP score maybe fail, I guess, maybe at least 4 or fail. So it's a little bit difficult to identify the tumor. 昆林这个 MAP 评分应该在5分左右，4到5分，所以他实际上不好做。Male adhesion peri-kidney fat score.
Maybe they can use the ultrasound to locate the tumor. That's a quick method to find the tumor.
Yeah.
To your point, once this is up and running, probably the local surgeon will be in the next room seeing consults and signing records or something, staying busy. Hit the alarm button if you need me to come over.
I think that probably gets worked out before the clinical trial starts, but I would assume it would be shared. I don't know, for this particular case, I don't have that information, but I would assume that there's a shared responsibility as far as that's concerned.
How many times limit? The time limit?
You have 6 minutes.
不是，还有多长时间会议？
It's till 12:30, Dr. Lee.
12:30.
Yeah.
Oh, okay. Only 6 minutes.
I heard them talking about it, but they haven't done it yet.
Dr. Lee, do y'all have a drop-in ultrasound?
I will ask Dr. Husan. Dr. Husan, do you have an ultrasound? 工程师给我翻译一下哈，他们这有没有术中超声？术中的超声来确认一下肿瘤的部位。问问哈萨克斯坦有没有术中超声？ I will ask Dr. Husan if the ultrasound is available in his hospital, in his OR.
东了，他说这里没有。
So sorry, no ultrasound in the OR of Kazakhstan, in Dr. Husan's hospital.
Use it in every case, pretty much.
Yeah, maybe the tumor.
Even if
the
it's
tumor
obvious.
just here.
Even if it's obvious, you still want to see.
Yeah, tumor is here, just beneath the bipolar. Dr. Husan, be careful. It's a kidney. Okay. Oh.
When I proctored in China, I met this fascinating woman that had entered the Chinese market in the 70s when trade was open, and her company's initial technology into China was ultrasound. And then they went on to diagnostics.
Ultrasound is
in
available
hospitals.
in our
And
hospital.
they served as sort of the management of getting, intuitive into China at the time. So it was fascinating because she's from Brooklyn, so she had like a very thick New York accent, but then could talk to her team members in fluent Mandarin and back and forth. So, and there's something about regulatory in China that diagnostically they move very fast, but therapeutically very slow. So like they could diagnose anything, but they were always behind on abiraterone or advanced drugs or whatever. So it was a very interesting setup, but they had every imaging toy you could imagine.
From the CT scan, we can judge the tumor just under the scissor.
For the ureter or for the artery?
Yeah.
Lower pole, do you have to?
Lower pole tumor.
I think he's got it figured out, though. Not the friendliest fatty layer, though. Right. He imported a patient.
Okay. Hello, doctors and audience.
Yes.
For the time limitation, we have to close our live surgery now. Thank you for your moderator for us, and thank you for your suggestion. Dr. Yang and Dr. Ye from China really appreciate your help and really want to invite you to our hospital in the future. Thank you.
All right, let's clap for them. Thank you.
Thank you. Thank you. Thank you, all the doctor, all the audience.
Of course, they still have real work to do.
All right, good morning, everyone. My name Center. It's a pleasure to be with all you guys this morning, and I really appreciate the opportunity of the Society of Robotic Surgery to chat with you all about something that is very important and part of my career, and something that has really changed my clinical practice over the course of the past 5 months. And so excited to have the opportunity to chat with you guys this morning about transforming lymphedema surgery with robotics, the Samani surgical system. So, objectives that I want to go over with everybody this morning. What is, I think most of us probably have some awareness of what the Samani robotic platform is at this point, but I certainly want to bring everybody up to speed, and so you guys are well versed in what the Samani robot has to offer for microsurgeons. Specifically this morning we're going to talk about lymphatic microsurgery, and then we're going to dive into how it is applied in my practice and how I think it can really transform the practice of a surgeon who's intervening to prevent and treat cancer-related lymphedema, and specifically breast cancer-related. Talk a little bit about what lymphovenous bypass is, how the robot helps in the conduct of lymphovenous bypass, a little bit about lymphatic imaging, the role that that's played as part of this platform in optimizing the surgery. We're
we're going to show a specific case example of robotic venous bypass. And I always like to say that it's a bit of making the impossible possible. You're going to see throughout this talk about how the robot is really allowing us to tackle disease in a way that really was not previously possible. And then we'll talk a little bit importantly about what the future of lymphatic surgery is going to be utilizing the robot. Disclosures, I do consulting work for MMI, a maker of the Samani robot. So let's get right into it. This is the Samani surgical system, the robot. And I just want to kind of highlight a couple of important parts of this. First, there's the robot itself. That's the cart with the macro positioners and the micro manipulators. This is what drives the instruments and actually what makes the magic happen. There's the nano wristed instruments. These are the smallest wristed instruments that have ever been created. They really, paired with the tech and the software that drives these instruments, allow us to operate with a degree of precision that has never previously been possible. And then there's the open air surgeon console. So this is just where the operating surgeon looks in a 3D viewing environment and is able to really control two manipulators or controllers that drive the instruments in a very unique fashion. So just a little bit of background there about what the robot is and how this So here we can see these are close-up view of the robot hands actually playing in real time. And some of the key features of what the robot is, it is again the world's smallest wristed instrument that have ever been done. 7 degrees of freedom, and it creates a very natural replication of what the surgeon is trying to accomplish at the bedside. Another super important part of this, and I think that it's definitely worth talking about, you're going to see it in the case that we show as well, is the motion scaling and the tremor reduction. So the tremor reduction, even the best microsurgeons at this scale will tremor a bit. That is completely gone, and it allows you to tackle the smallest of lymphatics and vessels that you ever want to. And the motion scaling is incredibly important. The robot will actually allow you to reduce your hand movements down to 1/20th of what you're moving in space, allowing you to have a precision that's just not otherwise possible. A quick look at what that tremor reduction and motion scaling looks like. So on, you can see here an example of a manual anastomosis being done versus the stability that you can achieve with a robotic anastomosis. I mean, I think when you see it in this setting, the difference becomes obvious. And then you see a quick clip here of the degrees of freedom and kind of the accuracy of the motion scaling that can do and how you can translate your hand motions down to a very small scale using the robotic technology. All right, so get into now a little bit of our story, our journey in lymphatic reconstruction and how we have applied this to lymphatic microsurgery in our practice. This was day one for us at our Samani. It seems like in many ways the way we've scaled our practice and the number of cases we're doing that this was forever ago. And I think this picture on day one compared to where we are now, and you can see how you'll see in a few slides how we've really ironed out and have a very clean process. The ease that this robotic technology can be implemented into your practice in a very, very short time. So let's talk a little bit about breast cancer-related lymphedema specifically, the problem and what we're trying to address. So we all know kind of in general, 1 in 8 women are going to be afflicted with breast cancer in this life. That's a staggering number in of itself. And it gets even worse when you think about 1 in 3 of those women are going to be at risk for developing cancer-related lymphedema because of the need to intervene potentially on their axillary lymph node. So you start to think about that volume of patients paired with the number of surgeons capable currently of conducting those operations, roughly around 600 right worldwide that would consider themselves super microsurgeons at this point. And there's a huge discrepancy in the number of providers and capacity to treat the number of patients in need. I think really this robot is going to move the ball down the field in putting technology and enabling a greater body of providers to conduct these operations that patients are greatly in need of, and we're going to talk a little bit about that as well. I think this example, which is a quote from one of my patients, can really highlight the significance of the problem of lymphedema. I had a patient one time come in to me, she had breast cancer, she'd been treated with radiation therapy, and she said to me in clinic, I have a paralyzed right knee diaphragm injury that I should have breath every single day of my life. Then she went on to say, but it's this arm that is really the worst part of anything that has happened. And you know, that really just solidified, geez, we have to be able to do something better for these patients. I have a bit of a treated breast cancer patients, I remember historically, this was just the type of situation where many patients had lymphedema postoperatively, and they were kind of just in general actually told that, be grateful, be alive, but that's just something that happens. And that just seemed crazy to me that there must be something we can do better. And so we've all set to the task of solving that problem. We've made fantastic progress. The end goal is obviously that they don't want to wear their garments anymore, and in that comes all the modalities that go along with complete decongestant therapy or non-surgical intervention. And it can just be extraordinarily cumbersome and disruptive to a patient's daily life. The fact of the matter is, we've gotten quite good at treating breast cancer, but the aftermath of that leaves patients with lifelong morbidity that makes their life unpleasant. And we need to try to improve on that, and we have, and the robot is helping us push the ball down the field even farther. What we all need to know about cancer-related lymphedema and breast cancer-related lymphedema is that the disease is progressive. There is no cure for it currently without surgery. That's why we've had such a focus on treating early disease, and we'll highlight more, as well as preventing the disease altogether, both of which are going to be empowered and enabled by the use of the robot. Because this is the laundry list of symptoms that patients deal with long term. Here we can see a typical patient suffering from a swollen left arm, now dealing with cellulitis, and this is common if left untreated. The subjective symptoms of heaviness, fullness, decreased mobility, the infectious complications of cellulitis and lymphangitis, and the physical symptoms that develop in the form of edema, fibrosis, and even ulceration or a late risk of sarcoma. These are all things that patients just really shouldn't have to tolerate, and we can avoid. The pathophysiology of lymphedema is really a cyclic disease process that once that snowball starts to fall down the hill, it's quite challenging to stop. You get proximal disruption of lymphatic drainage, an accumulation of inflammatory fluid that subsequently turns on a series of events that leads to fatty disc deposition of the tissues, further disruption of lymphatics, fibrosis of the tissues, and as that process continues, fluid accumulation gets worse. You can see how this goes around and around until you really have a significantly incapacitated stem. Where are we trying to treat this problem with the robot and with intravenous bypass? So we're trying to intervene. This is kind of the sequence of lymphatic anatomy. You start collecting fluid in the lymphatics, that then moves to the subdermal lymphatics, deep tissue lymphatics, to the nodal basins, which are the source of proximal obstruction in cancer-related lymphedema, and returning it to central circulation. Intravenous bypass on a lighter surgical level tries to treat the subdermal lymphatics just beneath the skin by rerouting the blood, getting that fluid back into the system at that point to avoid the proximal obstruction and decompressing the stability. Now, lymphovenous bypass isn't something that's necessarily new, as many of us know in this room. This has been tried historically over the years. The problem is we didn't have a good mechanism for targeting channels that were draining obstructed areas, or even identifying lymphatic channels that had functional residual lymphatic capacity to flow that didn't have all of the smooth muscle in those walls burnt out. Now with the development and modernization of indocyanine green imaging technology, we are really able to hone in the best target vessels in very specific areas to optimize our capacity to be successful with lymphatic drainage. You can see here in stage 1 ICG imaging, you really have linear flow of multiple channels from distal to proximal. You can see as you move through the stages, progressive dermal backflow, and to the end of stage 4, where you have complete dermal backflow. This is the situation we are really trying to avoid. Once you're at this point, there's not much you can do from a lymphatic reconstruction. So really early intervention in the preclinical or stage 1 stages where we're looking to intervene. And this is what we're looking to do with lymphovenous bypass. Right? It's actually quite simple. As I mentioned, it's just a rerouting of the plumbing. We're using indocyanine green imaging, finding those target lymphatic channels, and rerouting them, connecting them from distal flow to proximal to a recipient vein to get that fluid that's accumulated back into the venous system, distal to where that obstruction is, avoiding that obstruction and decompressing the arm. And as I mentioned, really treating early disease is the key. Once the disease has progressed and you start to get fibrosis of the lymphatic channels, it's an interesting phenomenon that happens with that back pressure, with that fibrosis. The channels actually dilate as they lose their function. That makes it easier to sew, but unfortunately it decreases your capacity to have meaningful impact on the disease process. Once that train's kind of left the station, it's hard to make a meaningful difference. Intervening earlier is really where you want to be intervening, This is our algorithm that we use here in our program. But the trick is intervening earlier before the vessels are diseased is quite challenging. You're often tackling 0.8 millimeter vessels, 0.5 millimeter vessels, or even smaller. Technically, sewing that scale of vessels has historically been very challenging with low patency rates. The robot has completely changed that game. We can reliably sew sub 0.5 millimeter vessels with the robot and have excellent on-table confirmation of patency, flow, drainage, and fluid in a way that has never previously been possible. So what's robot? Right, roboting has become a verb at our institution now. Everybody knows what that means. I just want to walk down the process of what's happening when we approach a patient with early stage cancer. We first start out with some lymphatic mapping. We use a Gen 3 PD video that's made by Taka, and we start with a little bit of light sedation in unfortunate situations where a patient has had progression of the disease. We don't want to do a general anesthetic, and so we give them a little light sedation and do a lymphatic mapping. I want to show everybody what that means. So this is just an example of us doing some preparatory lymphatic mapping where we see patients with early stage disease, preserve lymph flow in several lymphatic channels, and we're marking those out so we know exactly where our targets are. I mean, something I want to highlight here is we often try to make our decision making where we want to perform an incision, where we can tackle multiple lymphatics in a single location. And so we'll walk through this. Really, the clarity of this technology, the depth of penetration of the imaging allows you to very reliably see these lymphatic channels. You can see volarly there some dermal backflow creeping through, and we want to get these marked, and we'll know where our target vessels are going to be. Good, just marking there as I highlighted incision plane where we can get both of these lymphatic channels and maximize our distal drainage. Great. Room setup. As I mentioned, it seemed a bit chaotic on day one. We really clearly have honed in on a very reliable, reproducible, systematic way to set the room up to do roboting. Our team knows everything now about where we want things positioned to very efficiently conduct this operation. These are just some of the points that I highlight that you want to think about, certainly deciding which side of the arm you want to operate from, bringing your exoscope in. We use a hawk site, but bringing your exoscope in from a central location so you can move back and forth if you need to. 3D monitors are positioned for good visualization around the hawk site for you and your assistant. In general, an important point here is I found that the robot really should replace where the surgeon's sitting. So setting the room up in a way where the surgeon goes to the console for the robotic portion of the operation. The robot comes right in, and that just makes everything make a lot of sense and makes the robot function in a way that's seamless for what you were wanting to accomplish. This is what the room site looks like. A picture there of the instrument setup, really a simple supermicro surgical instrument setup that's necessary for this. Hawk site coming in eyes from below the patient who had a right upper extremity lymphedema. And then when you go to actually do the robot, it's just an adjustment so the patient can be at their 3D console. Robot comes in again where the surgeon was sitting for really a seamless approach to the robotic portion of the operation. I do think it's worthwhile taking a minute to discuss using an exoscope with the robot. You can certainly do this both ways. The robot can be used without an exoscope, with a traditional microscope as well as with an exoscope. But I would tell you that using an exoscope has been an absolute game changer for multiple reasons. It's absolutely reduced the amount of fatigue from these longer micro cases that you can do. I wouldn't really reliably have considered doing 2 days a day previously. Now we do 2 in a day because of the decreased fatigue, the ease of the ergonomics, the ease of operating. We also have a really large working distance with the exoscope, and it lets you really have a visualization that's not possible with a traditional microscope. And the last thing, it does have a very easy transition with all of your monitors on the light, which lets you use that almost as a dissecting tool for some of the very small lymphatics, dissecting those, going back and forth with the ICD. And for those of you who are familiar with the movie Ferris Bueller, so I would jokingly say this about the exoscope. It is so short. If you have the means, I highly suggest it. It can be done without it, but much better. All right, anastomotic technique. This is for me. You'll hear lots described about how people approach this. I think that minimizing suture material in the anastomosis is super important, especially when you get into that 0.5 millimeter vessel size or smaller. It makes a difference. So I approach this more of a fistula technique than a true end-to-end anastomosis. 2 reasons. One minimizes the suture material, and 2 allows me to dump multiple lymphatics into a single outflow vein. Now I want to get right into a robotic LV and kind of show you some of the things, highlight some of the points of this that I think have been dramatically improved by implementing the robot in my practice. First and foremost, operative field preparation. Here's 2 lymphatics. We're going to go into 2 veins, highlighting the ability to click quickly back and forth between ICG and white light there to confirm your vessels are in a good position, that those are the channels you want to be anastomosing. Using the exoscope, here you're going to see an example. It is really convenient because historically where you had to contort yourself a bit to the patient, now the exoscope can really be positioned in any way that's reasonable. As you see, we just rotated 90 degrees there to allow you to operate with the robot in the most ergonomic fashion. So much more surgeon-friendly from that standpoint. Jumping right in, we're going to go to the task of preparing our first vessel here. Again, a combined technique with your assistant, preparing those while you're sitting at the robotic console, getting those clips removed and everything. And from an instrument standpoint, more is on the way on that front. The instruments that are going to be coming down the pike for the robot will make this even more seamless, allowing the surgeon to do more at the console than even possible right now. Now we're jumping in here to doing our first anastomosis, and I think at this point you can begin to really get a sense of how stable and how accurate you can be with the robot. I think if any of us are truly honest with ourselves, that this is about a millimeter vein going into a 0.7, 0.8 millimeter lymphatic. That's challenging to do, and there is just no question that you are accurately placing this lumen of this vessel, anastomosing this vein with 100% patency confirmation before you leave the operating room. And that's nothing. Having done hundreds of these anastomoses, that is absolutely my historical practice. I think any of us who have incorporated lymphatic surgery into our practice and we employ these very challenging cases and trial your patients for sure. The robot has just increased the confidence of even myself, an experienced surgeon, So we'll continue to walk through horizontal usage there, right on the edge, not painful that whatsoever. Back through our distal vein, our vein, and then you'll be able to see as well, tying is really just a breeze as well. The learning curve in using the robot, I would say, is extraordinarily short. And it just takes a little bit of training, a few cases, and it really becomes quite natural. I always jokingly tell a little bit of a side story. When we were getting ready to purchase the robot and deploy this, they have a nice simulator that can give you some practice on this. Believe it or not, my 8-year-old daughter had this down in about an hour sitting in my office. So just to give you some sense of the potential to embrace this very quickly in your practice, it is real. Good, so we get these tied up. I'll just show you how we finish this, and then we're going to move on to highlighting some of the benefits of the robot, even on a smaller scale. So the next lymphatic that we're going to be tackling is a sub half millimeter lymphatic, and I think there'd be no argument that this is very challenging to be done by hand and reliably and patent. And you're going to see here that this is really where the motion scaling technology and the tremor reduction. You can see how the tremor reduction improves the smile front. This is where the motion scaling technology really comes into its own. Being able to reduce your movements to a scale of 1/20th, it just makes sewing these small lymphatics reliably. These are the lymphatics you're seeing in earlier stage disease. This is what's enabling you to intervene at a time when you can make a meaningful clinical difference for patients. Really moving us into that space where we can more frequently consider being able to get patients out of their garments altogether, intervening on these lymphatics before they're diseased. And so you're going to see here, this is that motion scaling at work. You drop the microscope down to 120, and you can see it's just like document motion. I mean, I'm obviously not moving at this scale or this steadiness in real. Get right on the edge of that tiny lymphatic, pull it under a little bit of tension, and really see how we can just slide this lymphatic right down the atrium, almost nearly completely atraumatic, and have a really nice mess on it. Gently pull that lymphatic even through the Swedger needle, and we're off and running. Back through the vein, and we'll get this tied up. One thing we're going to highlight here as this video comes to the end is, when you're sewing that scale of lymphatic, you're inherently going to have issues with size mismatch. And so I'll do a little paralymphatic stitch here in the vein where I kind of plug up that loose end of the vein with a little piece of adjacent fat, and that completely takes care of any kind of leak issues that you would be concerned of, minimizing your suture material and any anastomosis, allowing you to sew a patent sub 0.5 millimeter vessel with really no backflow. You can see now we've transitioned back to a regular scale of motion. This perilymphatic suture I was talking about, again, just a little adjacent attached globule of fat. We'll seal that open vein up, and it'll work quite well to achieve what we're trying to. Remembering this is a very low flow system, low pressure system, and this is sealed up completely in a very short time post-op. You can see how that tucks in there quite nicely. Doesn't put any kind of undue pressure on your lymphatic that you've anastomosed. And the nice thing about this is we're going to confirm all that's true here in just a second. So again, the integrated ICG capacity lets you very reliably image this. You can see flow into our distal vein, and we're confident that we've done a nice pain anastomosis and are going to have greaseless fluid and have done something meaningful to help this patient. Going all the way back to the beginning of the story, you can see here from the markings how it's important to position your incision with that preoperative ICG imaging, allow you to tackle both of these in one incision. Fantastic. So then I just wanted to wrap up this session with some commentary and chat about the future and the future that robotic microsurgery is going to play in our practices. I think without a doubt, robotic microsurgery is going to dominate and define the future of microsurgery. This is the path forward. From multitude, first and foremost, the needs of lymphatic dissection, especially with exoscope and surgery is phenomenal. And I think anybody who's had an opportunity to engage in using an exoscope would argue with that. The robot is technically allowing us to achieve, as I mentioned several times, is not previously possible. You can sew at a scale and with an accuracy that you just keep, that not even the best surgeons. And I certainly get into this conversation with microsurgeons across the country who remain skeptical early on in this technology. The way I explain this to people is like, most of us are familiar with the movie Iron Man. Tony Stark is a pretty cool guy, even without the suit, but there is absolutely no denying that when he puts that Iron Suit man on, he's better in everything. The Samani robot is an Iron Man suit for the reconstructive microsurgeon, super microsurgeon, and there's no doubt that it can make you better than you even are today. And most importantly, allow you to achieve outcomes for your patients that you are not able to achieve today. It allows us to intervene early, as I mentioned. This is really when we want to be intervening for these patients. early is important. Preventing the disease from happening altogether is even more important, and the robot certainly has the capacity to tackle those applications as well. I think it's important to talk about how this robot, because of the tech, because of the tremor reduction, because of the motion scaling, is going to expand the potential pool of providers that are able to provide, that are able to perform these operations for patients. And that's super important because it increases patient access. We can clearly see, we mentioned at the very outset of this talk, the delta between the number of people that can perform these procedures and the number of patients that need them is huge. This robot's going to shrink that difference down. And last but not least, I just want to highlight that, we are rapidly evolving our understanding of the impact of lymphatic dysfunction and the role of lymphatic biology in normal physiology and when there's dysfunction present in a multitude of disease states. So the potential applications of this robotic technology of lymphovenous bypass and the capacity for this to help patients in ways that we probably can't even imagine right now, it is certainly on the horizon. So I want to thank everybody very much for your time and certainly happy to provide contact information and chat with anybody at all additionally on how this tech can help your practice and how it's certainly revolutionized. So thank you all so much. All right, good morning everyone. My name is Nicholas Panetta. I'm chair of the Department of Plastic Surgery at the University of South Florida, chief of TGH General Hospital Plastic Surgery, and director of the University of South Florida Hospital Lymphedema Center. It's a pleasure to be with all you guys this morning, and I really appreciate the opportunity at Society of Robotic Surgery to chat with you all about something that is very important and part of my career, and something that has really changed my clinical practice over the course of the past 5 months. And so excited to have the opportunity to chat with you guys this morning about transforming lymphedema surgery with robotics, the Samani surgical system. So objectives that I want to go over with everybody this morning. What is PREG? Most of us probably have some awareness of what the Samani robotic platform is at this point, but I certainly want to bring everybody up to speed, and so you guys are well versed in what the Samani robot has to offer for microsurgeons, and specifically this morning we're going to talk about lymphatic microsurgery, and then we're going to dive into how it is applied in my practice and how I think it can really transform the practice of a surgeon who's intervening to prevent and treat cancer-related lymphedema, and specifically breast cancer-related lymphedema. Talk a little bit about what lymphovenous bypass is, how the robot helps in the conduct of lymphovenous bypass, a little bit about lymphatic imaging, the role that that's played as part of this platform in optimizing the surgery. We're going to show a specific case, a case example of robotic lymphovenous bypass, and I always like to say that it's a bit of making the impossible possible. You're going to see throughout this talk about how the robot is really allowing us to tackle disease in a way that really was not previously possible. And then we'll talk a little bit importantly about what the future of lymphatic surgery is going to be utilizing the robot. Disclosures, I do consulting work for MMI, a maker of the Samani robot. So let's get right into it. This is the Samani surgical system, the robot. And I just want to kind of highlight a couple of important parts of this. First, there's the robot itself that's a part with the macro positioners and the micro manipulators. This is what drives the instruments and actually what makes the magic happen. There's the nano-wristed instruments. These are the smallest wristed instruments that have ever been created. They really, paired with the tech and the software that drives these instruments, allow us to operate with a degree of precision that has never previously been possible. And then there's the open-air surgeon console. So this is just where the operating surgeon looks in a 3D viewing environment and is able to really control two manipulators or controllers that drive the instruments in a very user-friendly fashion. So just a little bit of background there about what the robot is and how this really overcoming today's challenges with microsurgery, with robotics. So here we can see these are a close-up view of the robot hands actually playing in real time. And some of the key features of what the robot does, it is again the world's smallest wristed instruments that have ever been done. 7 degrees of freedom, and it creates a very natural replication of what the surgeon is trying to accomplish at the bedside. Another super important part of this, and I think that it's definitely worth talking about, what that tremor reduction and motion scaling looks like. So you can see here an example of a manual anastomosis being done versus the stability that you can achieve with a robotic anastomosis. I mean, I think when you see it in this setting, the difference becomes obvious. And then you see a quick clip here of the degrees of freedom and kind of the accuracy of the motion scaling that can do and how you can translate your hand motions down to a very small scale using the robotic technology. All right, so get into now a little bit of our story, our journey in lymphatic reconstruction and how we have applied this to lymphatic microsurgery in our practice. This was day one for us at Varsamani. It seems like in many ways the way we've scaled the practice and the number of cases we're doing that this was forever ago. And I think this picture on day one compared to where we are now, and you can see how you'll see in a few slides how we've really ironed out and have a very clean process. The ease that this robotic technology can be implemented into your practice in a very, very short time. So let's talk a little bit about breast cancer-related lymphedema specifically, the problem and what we're trying to address. So we all know kind of in general, 1 in 8 women are going to be afflicted with breast cancer in this life. That's a staggering number in of itself. And it gets even worse when you think about 1 in 3 of those women are going to be at risk for developing cancer-related lymphedema because of the need to intervene potentially on their axillary lymph nodes. So you start to think about that volume of patients paired with the number of surgeons capable currently of conducting those operations, roughly around 600 worldwide that would consider themselves super microsurgeons at this point. And there's a huge discrepancy in the number of providers and capacity to treat the number of patients in need. I think really this robot is going to move the ball down the field in putting technology and enabling a greater body of providers to conduct these operations that patients are greatly in need of. And we're going to talk a little bit more of that as we go through. I think this example, which is a quote from one of my patients, can really highlight the significance of the problem of lymphedema. I had a patient one time come into me. She had breast cancer. She'd been treated with radiation therapy. She said to me in clinic, I have a paralyzed right hemidiaphragm from treatment of short of breath every single day of my life. Then she went on to say, but it's this arm that is really the worst part of anything that has happened to me. And you know, that really just solidified, please, that we have to be able to do something better for these patients. I have a bit of a unique position being board certified in general surgery as well as plastic surgery. And you know, having treated breast cancer patients, I remember historically, this was just the type of situation where many patients had lymphedema postoperatively, and they were kind of just in general actually told that you would be grateful to be alive, but that's just something that just seemed crazy to me that there must be something we can do better. And so we've all set the task of self-control to make things happen. The end goal is obviously right? In that comes all the modalities that go along with complete distance therapy or non-surgical intervention. And it can just be extraordinarily cumbersome and disruptive to the patient's daily life. The fact of the matter is, we've gotten quite good at treating breast cancer, but the aftermath of that leaves patients with lifelong morbidity that makes their life unpleasant. And we need to try to improve on that, and we have, and the robot is helping us push the ball down the field even farther. What we all need to know about cancer-related lymphedema and breast cancer-related lymphedema is that the disease is progressive. There is no cure for it currently without surgery. That's why we've had such a focus on treating early disease that we'll highlight more, as well as preventing the disease altogether, both of which are going to be empowered and enabled by the use of the robot. Because this is the laundry list of symptoms that patients deal with long term. Here we can see a typical patient suffering from a swollen left arm, now dealing with a cellulitis. And this is common if left untreated. The subjective symptoms of heaviness, decreased mobility, the infectious complications of cellulitis and lymphangitis, and the physical symptoms that develop in the form of edema, fibrosis, and even ulceration or a late risk of sarcoma. These are all things that patients just really shouldn't have to tolerate, and we can avoid. The pathophysiology of lymphedema is really a cyclic disease process that once that snowball starts to fall down the hill, it's quite challenging to stop. You get proximal disruption of lymphatic drainage, an accumulation of inflammatory fluid that subsequently turns on a series of events that leads to fatty disc deposition of tissues, further disruption of lymphatics, fibrosis of the tissues, and as that process continues, the fluid accumulation gets worse, and you can see how this goes around and around until you really have a significantly incapacitated extremity. Where are we trying to start collecting fluid in the dermal lymphatics. That then moves to the subdermal lymphatics, deep tissue lymphatics, to the nodal basins, which are the source of proximal obstruction in cancer-related lymphedema, and returning it to central circulation. Lymphovenous bypass on a microsurgical level tries to treat the subdermal lymphatics just beneath the skin by rerouting the plumbing, getting that fluid back into the venous system at that point to avoid the proximal obstruction and decompress the extremity. Now, lymphovenous bypass isn't something that's necessarily new, as many of us know in this room. This has been tried historically over the years in development. We didn't have a good mechanism of targeting channels that were draining obstructed areas, or even identifying lymphatic channels that had functional residual lymphatic capacity to flow and didn't have all of this now with the development and modernization of insight and imaging technology, we are really able to hone in the best target vessels in very specific areas, optimize our capacity to be successful in lymphatic drainage. You can see here in stage 1, ICU imaging, we really have linear flow of multiple channels from distal to proximal. You can see as you move through the stages, progressive dermal backflow, and to the end of stage 4, we have complete dermal backflow. This is the situation we are really trying to avoid. Once you're at this point, there's not much you can do from a lymphatic reconstruction. So the early intervention, preclinical or stage 1 lymphedema stages where we're looking to intervene. And this is what we're looking to do with lymphovenous bypass. Right? It's actually quite simple. As I mentioned, it's just a rerouting of the plumbing. We're using indocyanine green imaging, finding those target lymphatic channels, and rerouting them, connecting them from distal flow to proximal to a recipient vein to get that fluid that's accumulated back into the venous system, distal to where that obstruction is, avoiding that obstruction and decompressing. And as I mentioned, really treating early disease is the key. Once the disease has progressed and you start to get fibrosis of the lymphatic channels, it's an interesting phenomenon that happens with that back pressure, with that fibrosis. The channels actually dilate as they lose their function. That makes them easier to sew, but unfortunately it decreases your capacity to have meaningful impact on the disease process. Once that train's kind of left the station, it's hard to make a meaningful difference. Intervening earlier is really where you want to be intervening. This is our algorithm that we use here in our program. But the trick is intervening earlier before the vessels are a disease is quite challenging. You're now often tackling 0.8 millimeter vessels, 0.5 millimeter vessels, or even smaller. Technically, sewing that scale of vessels has historically been very challenging with low patency rates. The robot has completely changed that game. We can reliably sew sub 0.5 millimeter vessels with the robot and have excellent on-table confirmation of patency of flow and drainage of that lymphatic fluid in a way that has never previously been possible. So let's robot, right? Roboting has become a verb at our institution now. Everybody knows what that means. And I just want to walk now everybody through the process of what's happening when we approach a patient with early stage cancer-related lymphedema. We first intraoperatively start out with some lymphatic mapping. We use a Gen 3 PDE Neo that's made by Mataka, and we start with a little bit of light sedation. The unfortunate situation where a patient has had progression of the disease, we don't want to put them through a general anesthetic, and so we give them a little light sedation and do our lymphatic mapping. I want to show everybody what that looks like. So this is just an example of us doing some preparatory lymphatic mapping for the ASC patient with early stage disease, preserve liquid flow in several lymphatic channels, and we're marking those out so we know exactly where our targets are. And something I want to highlight here is we often try to make our decision making whether we want to perform an incision where we can tackle multiple lymphatics in a single location. So we'll walk through this. Really, the clarity of this technology, the depth of penetration of the very remarkable. See these lymphatic channels. You can see volarly there, some double backflow through, and we want to get these marked with our target vessel. Good, just marking there as I highlighted. Incision plane where we can get both of these lymphatic channels and maximize our distal drainage. Great. Room setup. As I mentioned, it seemed a bit chaotic on day 1. We really clearly have honed in on a very reliable, reproducible, systematic way to set the room up to do roboting. Our team knows everything now about where we want things positioned to very efficiently conduct this operation. These are just some of the points that I highlight that you want to think about, certainly deciding which side of the arm you want to operate from, bringing your exoscope in, bringing your exoscope in from a central location so you can move back and forth if you need to. 3D monitors are positioned for good visualization around the Hogsite for UA and your assistant. In general, an important point here is I found that the robot really should replace where the surgeon is sitting. So setting your room up in a way where the surgeon goes to the console for the robotic portion of the operation. The robot comes right in, and that just makes everything make a lot of sense and makes the robot function in a way that's seamless for what you were wanting to accomplish. This is what the room site looks like. A picture there of the instrument setup, really a simple supermicro surgical instrument setup that's necessary for this. Hogsite coming in eyes from below the patient. You got a right upper extremity lymphedema. And then when you go to actually do the robot, it's just adjustments so the patient can be at their 3D console. The robot comes in again where the surgeon is sitting for really a seamless approach to the robotic portion of the operation. I think that it's worthwhile taking a minute to discuss using an exoscope with the robot. You can certainly do this both ways. The robot can be used without an exoscope with a traditional microscope as well as with an exoscope. But I would tell you that using an exoscope has been an absolute game changer for a multitude of reasons. It has absolutely reduced the amount of fatigue from these longer micro cases that you can do. I wouldn't really reliably have considered doing 2 of these in a day previously. We now do 2 in a day because of the decreased fatigue, the ease of the ergonomics, the ease of operating. We also have a really large working distance with the exoscope, and it lets you really have a visualization that's not possible with a traditional microscope. And the last thing, it does have a very easy transition with all of your monitors in the room between ICD and light, which lets you use that almost as a dissecting tool for some of your very small lymphatics, dissecting and clicking back and forth between ICD. And for those of you who are familiar with the movie Ferris Bueller, so I would jokingly say this about the exoscope. It is so choice. If you have the means, I highly suggest it. It can be done without it, but much better. All right, that's my opinion. This is from I think that minimizing surgery material in anastomosis is super important, especially when you get to that 0.5 vessel size, which is smaller, makes a difference. And so I approach this more of a fistula technique than a true end-to-end anastomosis. 2 reasons. One minimizes the suture material, and 2 allows me to have multiple lymphatics in this flow. Now I want to get right into a robotic and kind of show you some of the things, highlight some elements of this that I think have been dramatically improved by implementing the robot in my practice.
started, and it's a pleasure to be here to introduce Dr. Nico Quezada from the Universidad Católica de Chile. Nico is one of the pioneers with the Hugo platform, because he was one of the first users as his location at one of the first installations of Hugo. Chile, India, and Panama were the first locations, and since then he has done an incredible job in evolving the technique. You know that this is a modular system that has a lot of characteristics in terms of flexibility, ways to do things, and so we need people like Nico and his experience to learn and try to standardize as much as possible these procedures to make it more accessible for the larger public. So I will give you the microphone, and probably we'll find a way to be comfortably seated at some point, but I'll get you started.
Okay, thank you, Francesco. Thank you to the organization for the opportunity to present our experience with robotic abdominal wall surgery with the Hugo's platform. So it is supposed that I should present just one video of one single procedure, but in my opinion, I guess that if we present the platform itself and also the different surgeries could be more interesting for the audience. So as Francesco said, I'm a upper GI, bariatric, and hernia surgery from Santiago de Chile. And Hugo, before having Hugo, we didn't have any robotic platform. So this was our first robotic platform, and we were very to have a robotic platform because we knew that we can do a complex procedure in a simpler way with the robotic surgery, right? So, well, I think that those are my disclosures, of course. I think that when we talk about Hugo, we have to talk about the specific things about this platform, and you know that this is a modular platform in which every single arm is a single cart, and that's different from the most known robotic platform. So there are two key features of the robotic carts that every single surgeon should know, which is the tilt and the angle. And it is important to understand that because when you want to dock, it's important to know the tilt and the arm that and the angle that you should use for every single procedure. But for the tilt is related to the inclination that the arm has or the cart has when it is approaching the patient. For example, as Francesco says, this is like a stocks. Right? If the cart is coming from the floor to the ceiling, this is a positive tilt, okay? And the opposite, if the cart comes from the roof to the floor, this is a negative tilt. And as you can see in this video, can you come back, please? Can you play the video, please? There is a part in the cart that indicates the angle. So if the angle is 0, it is neutral. That's at the level of the patient. But in this case, I put a positive tilt, so it indicates that the arm is coming upwards, right? So that's one of the key features of these arms, but most of the time the nursing scrub that is draping the cart already sets the inclination of the cart. So most of the time you don't have to deal with the tilt. But what is very important is, sorry, go ahead.
No, I just want to make this very interactive. So if during the live you have any questions, feel free to ask questions anytime. I was going to say that this tilt is what also makes the reach of these cards much, much wider to what we are used also for the audience that is used to Da Vinci. This is a tilt that is much wider compared to the arms of Da Vinci. So the tilt has a lot of value clinically because it allows you to do more things and set up the system in more different ways.
Great. And the other key feature of these robotic arms is the angle. And to understand that, you have to think like a circumference around the patient. So 0 is heading to the head, 180 is to the foot, 90 degrees, and 270. So if you want to put up an arm which is in 75 degrees, it's going to be something like here, right? So what is very important is that when you approach the cart to the patient, it should come straight in the angle that you desire. Okay, so how do we choose those angles? Medtronic has done a terrific work providing setups guidelines for every single surgery. So at the beginning of the case, you will have somebody with the setup, and they're going to tell you the angle, so you don't have to have it in your head beforehand. Okay, so this is but first you have to make the card learn where it is located related to the patient. For example, I mean, if I have a card coming from here, the card doesn't know where it is coming, right? So first you have to make the card learn from where it is coming. So we have this laser in the floor. I don't know if you can see it, but this is a laser down here. So when you approach the card to the patient, the laser is intended to be in parallel to the patient, and then you have the angle. And after that, when you move, you can see an angle here in this little screen. So it's very important to let the card know the position, because that's the angle you're going to reach the patient. So one of the things that I have heard about the Hugo is that the docking process is complex and it's terrible. And you know what? After a few cases, it is very smooth and you can do it very fast. This is a 30-second video in which I show how we do the docking right now. So as soon as the nurse is approaching the card to the patient, I'm trying to obtain the angle I want. I have an assistant just holding the port right there. Oh, I'm sorry. I'm so sorry. Again, I'm sorry. Can you hit the video, please? Okay, so as soon as the nurse is approaching the card, I'm trying to get into the angle, and my assistant is holding the port, okay, just to be more comfortable. And I'm approaching the card. I haven't settled the parallel position yet. I'm gonna do it right now. I'm gonna latch the arm to the port, and if I don't get the angle I need, I just move it, and that's it. I have to do this for every single arm. For a 4 arms procedure, it takes like 6 minutes, tops. That's it. And it's almost the same that I do with Da Vinci currently. So it's not that difficult, okay?
I think one nice thing is that you can, after you start using the system for some time, you start to memorize these angles, because you start to think in the Hugo way. So I know my left shoulder is 30 degrees, my right shoulder is 330. 270. So when you know what case you are doing, you start to think at this card's position in the Hugo way. So the numbers are just a consequence of the position of the card. And it's a very, very detailed way to describe the position of the card around the patient. So it's very reproducible. You don't need to do any guess, and everything is already coded, as Nico is going to talk about this setup guide here.
Yeah, but as I told you before, Medtronic has done a very good job providing these setups for different procedures. But at the end of the day, and after working a lot with the Hugo, you know that those angles are not that important. The most important thing is how it looks related to the procedure you want to do. So we have this, for example, this 240 degrees angle, but if you know that if you are in 250, but if it looks fine, it's going to work. So it's not that important. You have to see how it looks related to the patient, and you have to do a manually movements of the cards, and you know that if the range is correct, it's going to work. You just have to avoid too close angles, because otherwise you're going to have collisions between the arms. But that's why these guidelines are very good, because it is proven that it works perfectly fine. Okay, so I'm going to show you next. There's a question there.
Yes.
In reality, the system is very flexible. If you have a space in the other place, in the other side, it's going to be better. You place them.
For inguinal hernias in particular, the setup could be also reflecting. We have a symmetric setup also available for right and left, and you can make a specular setup for the opposite side. So in this case, maybe the choice is on which is the dominant hand of the assistant. You can reach this level of detail with these setups because you can, if your assistant is left-handed and you're doing a right inguinal hernia, maybe you want to have the assistant on one side, or you're doing a left, you want the assistant on the other side. You can make more space as needed. Another thing that we did when we developed this set of guides was also to try to concentrate the arms in the areas around the patient where the least amount of space is needed. So you can see there is a lot of space for the anesthesiologist. We don't want ever to give too much space, right, to the anesthesiologist, but there is some space. And then, of course, there is space for the assistant. And this is done to reflect the needs. And this is one of the signs of the advantages of the modularity of this setup.
Yeah, and also currently, for example, the system tower, now we're placing that in the foot of the patient, and it's better because when you're placing the ports and whatever, you don't have to look this way, you're always facing downwards, and it's very flexible to place the cards and the tower and everything in the ward.
Another example, sorry, Rico, sometimes you have the entryway of the patient on one side. Maybe in this case, let's say, is on the left side of the patient. But if the door, when the patient is brought in, is on the opposite side, you might want to have the cards on the other side to make more space. So again, other examples on how you can really adapt this setup to the operating room, the space you have available, and the details of the surgery you're doing.
Okay, so I'm going to show you a case in which this is a friend of mine. Sorry, this is in Spanish, but this is a patient who had a bilateral TAPP repair previously 10 years ago, and he had a recurrence on both sides. And can you hit the video, please? And he was having trouble. This guy is a marathon runner, so he was having trouble with the running. So he asked me to do the repair of the hernia by MIS, and this is how the idea of this video is to show how the platform works, and it's amazing the visualization we have because the camera that we have is a stores camera with some digital filters that make this kind of visualization perfectly nice, and it's beautiful to see how it works, and the 3D. The 3D quality is amazing. I was doing a laparoscopic case a few weeks ago, and I thought to myself, what am I doing? Why am I not doing this with the Hugo? I mean, it's crazy, the anatomy that you can see with this optic. And as you can see, there was a mesh right there. Okay, so I'm trying to separate the mesh for the element cords. You can see there the epigastric vessels. Those are the testicular vessels, and we're starting to see there the vas deferens. I wanted to preserve the vas deferens because my friend just got divorced, and he asked me to preserve that. And after a few minutes of working with a high precision of the instruments, we were able to separate the cords element without any damage of them. And we just kept the old mesh in the peritoneal flap, because he had no chronic pain. So the idea was to repair the hernia. I was not treating chronic inguinal pains. In that case, I should have removed the mesh, but in this case, it was just repairing the mesh, the hernia, sorry.
How did you place your ports for this one? Umbilical?
No,
the camera?
a little higher, like 5 centimeters higher, and I do a triangulation because different to the Da Vinci, for example, which should be in line, triangulation in this case is better. For Hugh is better.
And which camera are you using?
30
0
degrees.
or a 30? 30 up.
Yeah.
30.
In this case, yeah, 30 up. And most of the time it's 30 up for inguinals, and just at the end of the procedure, you put down to see the retius space. But most of the time it's 30 up. Yeah. So you see the anatomical landmarks. This is a very nice view of the critical view of the myopectineal orifice. And after that, I'm pretty sure that I can put a new piece of mesh and just finish the procedure. In this case, my friend had a very bad myopectineal orifice. You know, there's a direct, indirect, and a little femoral hernia. So I decided to placate a little bit the direct place. I'm going to show you later. So I went to the contralateral side. This side was a little more tricky because he had a big direct hernia, and the mesh was very stuck to the elements, and also, again, when we didn't have the robot, we used to use by laparoscopy using some kind of advanced energy like sonicision because of the hemostasis, because of the slow dissection. But with the Hugo, it's amazing to see how you just move and go and go and go, and there's no major bleedings, no injury to the cord structures or the major vessels in the pelvis, which could be dramatic. I mean, an injury to the iliac vein or the iliac artery could be very, very dangerous. So again, we're trying to separate the mesh from the elements, and I'm preserving there the epigastric vessels.
How do you find the strength of these instruments for the traction on the sac, big sacs, the strength?
It's amazing. Yeah, and that's a big thing about robotic surgery, because you just pull a little bit, you're in the console, and you're having a very, very good strength. This is what is very, very good about robotic surgery is, for example, in hiatus hernia, you just grab the sac and bring it down to the abdomen, and the hiatus produces itself very easily. It's very nice to do hiatus hernia with the Hugo because of the strength of the arms, and that's very different from a laparoscopic hiatus hernia. So again, you see the vast difference there, right? Iliac artery, iliac vein. We are separating the old mesh from the structures, and those are the testicular vessels. Indirect orifice, direct hernia there. So again, we did the critical view of the myopectineal orifice, which should be done in every single surgery, right? And after that, we decided to placate this transversal fascia, that is herniated, and we bring it back to the lateral border of the rectus muscle or Henle's ligament. I did this just to have a flat landing zone for the mesh. I don't want the mesh to be pushed through this orifice. So.
Were you doing this also in laparoscopy?
Yeah, but it's harder.
Yeah. I can see how the robot really enables you to do this step much more easily and safely, because eventually good control in this area is critical to avoid the complications and bleeding. So it's very nice the way you're demonstrating it.
So after placating the transversal fascia, I used this heavyweight mesh because my friend had a very bad tissues there. So I decided to use this one. I usually use the program mesh. It deploys really nice with the robot. I just did 1 or 2 stitches to fix the mesh.
Do you always fix it?
No, but this is a recurrent hernia, so I want the mesh as fixed as possible, just because this is a recurrence.
Yeah.
Otherwise, I wouldn't do that.
Does people in the audience fix the mesh routinely at this point? Any indications? Is anybody not fixing the mesh? In some cases, I guess, right?
Yeah. And what I do in robotic surgery also is to do just one big flap from one side to the other, because with a 23 centimeters V-lock, I can close all the way, so it's easier, especially if you're using program mesh, which is sticky. If you have all the flap down, it goes all the way down, and it's very easy to deploy the mesh. So this is a very good case of inguinal repair. So again, okay, any questions? You want to comment something, Francesco?
No, I think it's a very nice technique. The control is perfect. Inguinal hernias is one of these indications where surgeons are generally uncomfortable doing it laparoscopically. Mostly these more challenging cases that last longer. Your assistant with the arm extended to hold the camera is sometimes. So doing these cases with the Hugo, the quality of the vision, the control of the system, the comfort at the console, because now you are sitting in a very comfortable position. You're in direct contact with your team, I think is very important and really simplify things a lot. You were commenting when we were chatting before that you are able to see now the field, and you like.
Yeah, I'm going to show you a video later about the console, but what I like about the open console is that I face the console to the patient's bed, to the patient's bed, and I have the full control of the OR. I mean, I can see what's going on with the anesthesia, with the arms, who is coming into the OR. I have full control of the OR because because I'm not into the surgical field. So I like it a lot about that. I'm going to show you later. So this is a different case. This is a ventral hernia. Again, Medtronic has provided us a setup. But in this case, as you can see, the angles are very close together from each other, to 90, to 70, to 50. And all the arms are coming from the other side across the patient and got into the patient. And as you can see, it works perfectly fine for small ventral hernias, because if you do a wide movement, you're going to have collisions. But if you work in a reduced space, it works perfectly fine. You can see that the arms are very close together, but still you can work. So this is good, for example, for a TAPP ventral hernia procedure. Works amazing. It's very nice.
It's beautiful, and yeah, this is a way you work. As you said, you need to keep your field always in order. I say so. The camera follows the instruments, and in this way, you can actually travel in very wide directions, because with this setup you can even reach the epigastric region and repair also epigastric hernias. But you need to be more mindful of the movements that you do, because you need to follow the camera with the instruments, and you can really travel a lot also thanks to the extended reach of the instruments. So it's very nice.
The problem was that at the beginning I came from the laparoscopic hernia surgery, so I was very used to move from one side to the other very quickly, and that is not possible. So at the beginning of our cases, we had a lot of collisions, and we learned that we have to move in block. We have to follow the camera and the instrument. So this is good for us, again, for small hernias, but probably for bigger hernias, like when you want to do a TAR, for example. This card positioning is very nice, because you have the working arms coming from the other side. This is the working arms. And the camera card is coming from the same side. So as you can see in the video, you have a lot of space between the arms. So this configuration allows a wider range of movements while doing more complex cases, and also provides a very good visualization of the linea alba. So it's a very good idea to do by this way that you and David Chain provided us this configuration.
Yeah, we worked on this option that is great, as you said, for this reason, and also for the flexibility, and we will probably see it later in your experience, because I know you're doing in changing sides, so you can swap from the left to the right and right to the left just by undocking and redocking or disconnecting and reconnecting a card. So it's extremely efficient way to change completely side when you go when you have to do bilateral work. If you go back on the previous one, I wanted to make also a comment on this one, again, to see how simplified the docking can be if you think, Ugo. 270 is the right flank. In this case, we did the setup guides such that these arms are all close to each other, and we will see why later. These arms are all coming to the patient very close to each other, and so there is a minus 20 and plus 20. So you remember that we are working on the right flank, and that's 270, plus and minus 20. Now you are at the numbers that you see there, 290 and 250. Very easy to remember once you start to think in the Ugo way.
Yep. So again, okay, so, but when you have a robot, of course, you want to do more complex cases, right? And the ETEP technique and the TAR technique are difficult surgeries to do, even with other platforms. So we try to do many ETEP cases, and we learned that the precostal access is a very good option to do that for many reasons. First is when you try to do the retromuscular space by direct view, sometimes you make a little rent in the posterior rectus sheath at the beginning of the case, and that is painful for the beginning of the procedure. So when you go to the precostal area, you do a small incision, and you open the anterior rectus sheath. You use a Kelly to separate the muscle fibers, and then you are in the posterior rectus sheath. You put a regular port here, and after that you use a regular laparoscopic camera, or maybe the Hugo camera, whatever, and you develop all the retromuscular space in the left side, and after that, you know perfectly where the linea semilunaris is. So you use the full retrorectus space to put your ports in a very good position, and after that, we dock and we put the instruments in, and that's the way it looks. This is the scissor, the bipolar, and the Hugo camera. So it was just for the purposes of the picture. We use a different laparoscopic camera, but we currently do this part with the Hugo camera. So this is the setup that we use. What we take care is always to have at least 8 centimeters distance from one port to each other, because if you come closer, you can have collisions. And also the ETAP is critical because we don't triangulate. This is in line, so it has to be at least 8 centimeters between ports. Okay, so this is the end of the case. You can see a small drain there, but this is the way we do ETAPs. This is a case I want to show you. This is a ETAP repair with a unilateral TAR procedure. Can you hit the video, please? This is a 70 years old man, something like that, which had a chronic renal disease, who had a rendezvous procedure after gastric bypass. He had a very bad surgery, and they lost the gallbladder inside of the abdomen, so they had to do a mini laparotomy to extract the specimen, and after that he developed a hernia. So again, precostal access, 3 ports, and the ports are inserted, and after that I moved to the robotic platform, and we start the case by fully developing this retromuscular space. And once we tried to reach the medial border of the muscle, of the rectus muscle, which should be something like here, because what we want is avoid an injury of the linea alba, right? So we have to be few centimeters down the meeting of the PRS with the anterior rectus sheath in order to avoid injuries to the linea alba. So once we are clear about the anatomy, we start the crossover, which is probably the most important step in this procedure. And despite of being very aware of that, we did a mistake. I'm going to show you later in this video.
Mistakes, of course, are normal.
Yeah.
But you should say, despite this unbelievable vision, because I don't know if you can tell, but the quality of the images is incredible. And this also because of the optics, is an 11 millimeters camera that brings much more light, much more quality. When you sit at the console, there is nothing comparable to this.
So we started the opening of the medial border of the left posterior rectus sheath. We pushed down this fatty tissue, which is preperitoneal fat, and we tried to do the opening of the medial border of the right posterior rectus sheath, but in this case we did a little hole in the linea alba. So this is the iatrogenic hernia. So we recognized that, and we knew that we know that we have to do something about this at the end of the case. So we keep on moving, doing the right side retrorectus space. There you can see a neurovascular bundle that we have to preserve in order to avoid the denervation of the muscle. That's almost the subxiphoidal fat. And here we are dealing with the hernia defect, and this is the hernia sac. We are trying to put it back to the abdomen. And this again, the strength of the instrument is amazing. By laparoscopy, this is impossible. There is no way you can bring this sac down again. So we were able to put this hernia sac back again, because I was trying to avoid a unilateral TAR. I wanted to preserve the hernia sac to close the defect, to close the posterior rectus sheath of the right side using the sac as a patch. But after doing that, I realized that it was very tense. So one of the bad or dreaded complications of this procedure is to have a intraparietal hernia because of if the closure is so tense, or it's very tense. So I decided just to move to a unilateral TAR. I had a lot of experience with laparoscopic TAR previously, so I felt confident with myself in doing a safe TAR. So I decided to move with that decision in this case. So this is what's the linea alba down below the umbilicus. So we are starting the TAR in the right side. This is top-down approach. So this is the medial border of the posterior rectus sheath. This is the internal lamella of the internal oblique, the posterior lamella, and we are transecting the TA fibers, just grabbing, releasing, and boosting that with the scissor. So
what setup
do
you have with the camera? For instance, the camera setup for this step here.
This is 30 down.
30 down.
30 down. You can see the 30 down there. Yeah.
Oh, yeah.
So we're moving downwards. This is almost reaching the below the IRCAD line, probably there, the IRCAD line. This is fascia transversalis, and this is almost the preperitoneal space there. So again, we are traveling from the xiphoid to the pubis, from one side to the other, and there is no problem with collisions between the arms, so it works perfectly fine. That's the lineal below the umbilicus. So the next step is to release the peritoneum and the fascia transversalis from the TA muscle. This is the upper part of the abdomen. As you can see here, this is the transected TA muscle, and we are releasing this tissue in order to decrease the tension in the closure of the posterior rectus sheath, right?
I see you use very nicely the scissors, combining blunt dissection with energy. How do you like these scissors?
Oof, crazy. I like it a lot. Yeah. What we have learned in difference to laparoscopy is that you have to grab with the bipolar very close where you are working and just pull, and it's just a mix of buzzing and pushing, and that works perfectly fine. As you can see, it's a very hemostatic procedure, almost no bleeding. And we're moving very lateral here. And one of the concerns about the Hugo I want to tell you is the reach of the instrument. And as you can see here, we are in the very lateral part of the abdomen. This is the TA muscle. And now here you're going to start to see the diaphragm fibers. So those fibers come in this direction and the TA in this direction. So it's very lateral. We didn't have any problem with the reach. Now we're starting the closure of the linea alba. And as I said before, we have to deal with the iatrogenic hernia we did. So we do this closure with this is not the big needle driver. This is the regular size. Now I use usually the extra large. They told me that they have the same strength, but anyway, it works perfectly.
Yeah, usually on the smaller one, the needle sometimes tends to rotate more.
Yeah.
But I see you are using it perfectly, even with the KDA or the bipolar.
I even sometimes use the bipolar.
Yeah,
if I
yeah.
find myself comfortable, I use the bipolar just to pass some needle passes, and after that, I just keep on doing with the needle driver.
Yeah. Going back to what you just said about the reach of the instruments, have you ever experienced a situation where the reach is not enough? How do you fix that problem? How do you overcome the limitation? Because with any robot, sometimes you might be in that situation, right?
Yeah, I have had that problem with very big patients. He was a very tall patient, like almost 2 meters tall, and we did a TAR, and we had some troubles reaching at the extremes. So there is a trick. You have to just take the instrument out and push the port inside, and you have 6 or 7 centimeters
of extra reach.
Yeah. So that was the way to solve that problem. It works perfectly fine.
Do you use titanium ports?
Sorry?
Do you use titanium ports?
No, I use plastic. I like plastic more. Yeah, it's not sustainable, but I like it better. Yeah. Well, we started doing the closure in the upper part. Now we're coming from the foot to the head, and we are dealing now with the hernia defect that was almost 5 to 6 centimeters. So maybe unilateral TAR was not that bad idea to decrease the tension.
Yeah.
Right. And also we are taking some bites of the subcutaneous fascia in order to decrease the seroma formation, to decrease the dead space in that place.
Do you have special algorithms to decide when to do one technique versus another?
Yeah,
this is a common question, but
that's a common question. But when you talk to true experts like Nowitzki, all those guys, I mean, if you, for a 6 centimeters hernia, if you feel confident and you know that you are doing a not risky procedure, if I know the anatomy, if I know that I'm not going to injure the neurovascular bundles, I'm not going to do an injury in the semilunar line, I feel confident doing the unilateral TAR. Currently, we are doing the Carolina's crossover, which is ETEP retromuscular in one side and preperitoneal in the other, so you avoid doing the TAR for medium-sized hernias, 6 centimeters, 5 centimeters. After that, a TAR is not a mistake. It's a good choice. is a better choice.
You have to have all the options in your
in
your hands to offer the best solution.
Yeah. And here we're closing the posterior rectus sheath without any tension, so we are avoiding this intraparietal hernia complication that I said before. And in the first few cases, you know what, I felt more confident doing laparoscopic suturing rather than with the robot. And I thought, what am I doing wrong? Because the needle moves from one side to the other. It was crazy. But after a few cases, I said to myself, what I was thinking. I mean, this is absolutely better than laparoscopic. But it's just a matter of what you are used to do.
Yeah,
right?
yeah. No, this is a suturing machine, so it's perfect for that and to have good control. And I see for this case you're using the camera on the other side, so two operative cards on one side and the camera on the opposite side, which really gives you more flexibility to go
from one side to the other.
Yeah.
Doing a case like this with the three arms coming from the other side can be a little painful because you have to move from one side to the other, and when you find some difficulties at some point, you want to leave it for later and you want to move to a different place. So this is a good idea to use the 2x1 configuration. And after that, we put a big piece of mesh in the retrovertebral space, a small drain. I use it for 1 or 2 days, and after that, that's it.
Routinely,
yes. I know that many of you don't use it, but I old-fashioned. I want to use it still.
Yeah.
Okay, so this is a different case. This is a 40-year-old man. He was like BMI of 38. He had an open appendectomy, and after that he did a small bowel obstruction. He had a midline laparotomy, and of course he had a midline hernia. It was like 10 centimeters wide. So this is a good case for a bilateral TAR. But in this case, we did a transabdominal TAR, not ETAP, okay? Because this guy was big too. So we wanted to have a very good view of the intra-abdominal contents. So
I noticed that they are also the previous patient was the high BMI.
Yeah.
How do you manage these heavier patients? Do you have them lose weight? Do you try?
We did the analysis of our first 100 cases of open laparoscopic TARs, and we learned that when the patients lost at least 5% of the initial weight, they had less complications. So for us, a bilateral TAR should lose at least 5% before surgery. Drugs, sometimes they go to bariatric surgery, sometimes they go to balloon, or whatever choice they want to take, but they have to lose some weight before surgery.
Has the robot changed in some ways this indication or the ability to deal with higher BMIs?
Sometimes, for example, the man I showed before, he's 70, 75 years old. You know, they are not going to lose a lot of weight. So you can be more flexible with them. But anyway, it's good to commit them with the treatment. So I guess that weight loss is a very good, I think that weight loss is a very good thing to do with them before surgery. Also, smoking cessation.
Yeah, and you create a team at that point with the patient. Are there any questions from the audience so far about the previous cases? Perfect, so we can start.
So in this case, we were thinking about doing a transabdominal bilateral TAR. So what we do is to insufflate the abdominal cavity, and after that, we try to put the camera port 15 centimeters away from the hernia edge. So as you can see here, we insufflated the abdominal cavity with a Verse needle. And after that, we pushed and we felt that the hernia edge was there, and we measured 15 centimeters. And this is the first port, which is the camera port. And after that, we put the working arms at least 8 centimeters away. So what we do is go caudally 8 centimeters and then 5 medially. And by Pythagoras formula, this is 10 centimeters. And again, to the head, 8 and 5 medially and 10 centimeters. So the ports are 10 centimeters away from each other. And
no, that's perfect. And one of the characteristics, I think you will agree with me, is that this way you have no guessing. You can standardize things in a very reproducible way. But one of the advantages, and you can tell from the setup of Ugo, is that you work much more medial to what you would normally do. And this is because the system has the ability to work backward, which you don't have with other robotic systems. So I think this is a nice thing to have, because from this setup, in some lab work, we end up mobilizing the ipsilateral kidney. So from here, you can work on the same side, going back in the opposite direction, all the way down to mobilize the kidney.
Amazing. Yeah. So what I want to show in these videos is the robotic performance. As we were used to do this by laparoscopy, but doing this with the robot is absolutely different. You are working in an ergonomic position. The visualization is absolutely better, and you have despite you don't have the haptics, you feel what you're doing with the view by viewing that. So the adhesiolysis, in my opinion, is safer with the robotic platforms rather than the laparoscopy. And a case like this one probably would go open. Previously, with having the robot in our OR. And
you mentioned about the comfort too, because right, you're working.
Yeah, but I always say that there is some measurements that we don't regularly do. For example, my lifespan as a surgeon is going to be longer with the robots. There's no doubt about that, right?
Definitely.
My shoulders are better than 5 years ago, of course, because laparoscopy, especially for the abdominal wall surgery, is very uncomfortable, right? So as you can see here, we do a very nice adhesiolysis, and we take everything down before starting the TAR itself. And the robot, the Hugo, works perfectly fine in this part. After that, we start with the case. We have everything down, and we are trying to identify where the right, because we are in the left, the port side in the left side. We're starting the right side. We are preserving the periperitoneal fat as much as possible, because it will help in the future to close the visceral sac. And we identify the rectus muscle, and we start the creation of the retromuscular space in the right side. So as you can see here, we are trying to see where the medial border of the PRS is, and after that we develop the retromuscular space from the xiphoid to the pelvis. The main goal here is to create the space by identifying the neurovascular bundles and preserving them in order to avoid the denervation of the muscle. And again, in my opinion, it's very different when you start doing robotic abdominal wall surgery. If you're learning to do these procedures, if you're a new user of the platforms, but also you are starting to do a new procedure, or if you come with a background of doing this by laparoscopy, because in this case, this procedure was not new to me. What I had to do was to learn how to use the robot. Right? I was driving a new car, but the procedure was the same. So that's why I say that I feel very confident by doing a unilateral or bilateral TAR, because I know what, being humble, of course. Yeah, I know what I have to do. And
I always say that when you sit at the console, your life becomes easier, right? Because if you have laparoscopic experience, you can replicate the same movements with all the benefits of the robot. And one of the advantages of Hugo is that, I'm sure you noticed, you can replicate, in hernia it's less important, but in many procedures you can replicate the same setup that you have for laparoscopy. With other platforms, you tend to work more on a straight line. With Hugo, you can really do the same setup that you have for your laparoscopic cases, which makes the transition even easier. But the question I have for you is how you train your team. How did you implement the utilization of the robotic platform with your team? You choose a small group and then you train other people. How did it work? Because that is the part that I think is very important also.
I have my boss here, but we have talked a lot about this. We would love to have a dedicated team for us, but our institution doesn't want that. And I have rotation of nurses and people, and it is always a learning process at my institution, and that's a headache, but it's the way.
But that's actually a good thing, because it still means that you can manage to do it. And then one of the other things I like is that you always have also the Medtronic team there that helps with everything.
Yeah, we have Andrea Valdebenito there. She's amazing. She's a very positive person in the war, so we love to have her there. So after that, after doing the release of the posterior rectus sheath, creation of the retrorectus space, we go to the TAR itself. And we are doing a bottom-up approach. So probably this is, oh, I'm so sorry. So probably, again, no, let me bottom up. Yeah, there you are. So probably this is posterior rectus sheath. Maybe the IRCAD line is right there. So there we are opening the transversalis fascia. But remember that this patient had a open appendectomy, so he had scar tissue around here, so it was difficult to do a bottom-up approach. So what we did was to create a incision in the posterior rectus sheath in the midpoint between the IRCAD line and the muscular part of the TA muscle. And we did this preperitoneal space. So we dig a little cave here, as Conrad Beleser has said in many, many presentations. And after that, you just go to face this part with the scar tissue, because at some point you just have to deal with that. And we release the peritoneum and fascia transversalis from the TA muscle. So this is the cut TA muscle aponeurosis. Okay. So this is fascia transversalis. Probably if you go down there, you're going to go to the Bowers space. But we didn't want to do that in this case. That's a scar tissue. And after that, we go bottom up. So you dissect laterally. We do a little cave, and then you just move upwards, transecting the posterior rectus sheath, which is the posterior lamella, the internal oblique, and the aponeurotic portion of the TA muscle. After that, going up, we're gonna stop doing this, and we're gonna stop at. What I do is when I start seeing muscle fibers, I stop there, and then I move upwards, and I do the top-down approach. So it's just the same as the previous patient, right? So xiphoid here. Oh, it's not running fine. Transecting the TA muscle fibers, okay? So I grab it, lift it, buzz it, and then going down. And then I meet in the middle, and that's the easiest way to do, in my opinion, and you avoid doing small holes in the posterior rectus, in the peritoneum, because afterwards you have to close it, and it's annoying to do one stitch and then the other. And if you have many rents, you have to work. You have to do everything to
that position that you showed of the scissors that were at 90 degrees, pretty much. That's a very nice thing that you can do much more easily with Hugo, because with Hugo you can position the tip in a certain way, you clutch, and you reposition your controllers in a more comfortable position. So you never have to be in very awkward positions for some of these steps, which I think is a nice feature of the system.
Yeah, I like the handle of the Hugo better than the Da Vinci, because your hand is in a more ergonomic position. You're working like this, not like this. When you're working in this position, if you want to move inwards, it's impossible. You have more risk to do that. And even doing that, outside, it's impossible. So when you have your hands in a neutral position, you have a lot of movement, and that translates better in the inside. So after doing the complete TAR from the xiphoid to the IRCAD line, you have to again release the peritoneum and fascia transversalis from the muscle, and again the reach is not a problem. You see the transected TA muscle there. This is the rectus muscle, neurovascular bundle, TA muscle transected. And you can see here the diaphragm, TA muscle, and this transitional fat, which is a landmark that points the transition between the TA and the diaphragm. So you have to be careful in that space, because you can do a iatrogenic pneumothorax if you go so deep. So we are trying to, again, to release the peritoneum and fascia transversalis from the muscle, because we have to close this posterior rectus sheath without tension. And you have to prepare the landing zone for a big piece of mesh when you're doing a TAR, right? So I'm going to skip this. So the thing is, how do we reduct to do the contralateral side in the robotic TAR? So we tried several ways, and we found that probably this one is the best, sorry. What we do is to have two arms in this side and the camera here, right, for doing the right side. But what we have in the OR is a waiting car. It is already draped, but this is out of the surgical field. And when we finish one side, this card goes out, and this one, which was waiting, comes in, right? Now we have, again, 3 cards, the camera coming from this side, and the working arms coming from the other side, so now you can do the left side. This is the best way to do the redocking process. Again, you have to drape another card. This is less sustainable, but it works, and you save a lot of time. Okay, can you please hit the video, guys? So it's currently the redocking process is taking us like 8 to 10 minutes, taking undocking, inserting the ports in the contralateral side, docking again, inserting the instruments, 10 minutes, and we go back to the console to the contralateral side.
What would you say would be the time if you didn't have to put the ports? Like if you have everything set up and you just need to change side?
Probably 5 minutes, 6 minutes, yeah. So that was the waiting card there. It was behind the surgical tower.
You normally store the cards in the OR when you don't use it?
No,
you store it
We
outside?
have a room for the
So you
room.
have also that flexibility to free up the room.
Okay, that's it. So again, we're going to the contralateral side. As you can see, the bare muscle, because this side is already done. We're trying to preserve the preperitoneal space. So the foot are here. This is left side. The head should be like here. This is a big hernia, right? So we're trying to preserve the preperitoneal space. We are releasing here is preperitoneal tissue, and we are starting to transect the medial border of the posterior rectus sheath. In the left side, again, we are creating the retromuscular space. Sometimes what I do now is, in order to avoid going from one side to the other, I do the release and I do the TAR at the same time. I just move, doing all the procedure from the bottom to the upper part, and that saves a lot of time, yeah. Again, trying to save the preperitoneal fatty tissue, and that also helps to identify the medial border, because otherwise it can be a little tricky to identify where it really is. Maybe we can skip this part. The left TAR with the bottom-up approach is amazing. It's super fast, and the rods were done for doing this procedure. Again, arcuate line there, opening the transversalis fascia. This is just transversalis fascia. After doing this, we dig a little cave going to almost to the Bogers space, and then we put the bipolar facing upwards and just transecting the aponeurosis, and this is really fast. It's like 10 minutes procedure doing the left side TAR. We grab the PRS here, we dig a little cave there, and we know that we are not injuring the peritoneum or fascia transversalis right there. So it is very easy to do the bottom-up approach in the left side.
How often do you actually use the bipolar? I see you always have the bipolar, but you use it.
This is an edited video. You know,
but still.
I use it, yeah. But there are no major bleedings. It's just something that is a little bit more annoying, and just bipolar, and that's it. Yeah. And you commented that in the morning session that one of the features, safety feature of Hugo, is that to activate the energy, you have to activate that first, tapping the pedal, and after that you can use it. So sometimes it's a safety feature, but also can be sometimes annoying, because if you want to do something fast, you have to activate, and then.
Yeah, no, it's true. There are a couple of things I always say that hearing feedback from surgeons that are using Hugo, there are two little differences that are not so automatic in the brain that of the surgeons that switch from Da Vinci to Hugo. One is this, that you need to do one first tap to engage the energy, and then one to deliver the energy. And the other one is a fraction of a second longer lateral tap to swap the fourth arm. We don't have it in these cases, but that's the other thing. And if you think about it, and this is consistently the report of the surgeons, This means that you can switch from one console to the other with minimal adjustment needed. So this is another interesting aspect of the technology. You can really adapt to the new platform very quickly, also if you have experience from the other one.
Yeah, we got a DaVinci Xi like 6 months ago, and moving from one console to the other was super easy. No, almost no difference.
We were, I always make jokes because we were working in Chicago developing these setup guides, and we were working in the lab. So, and then the lab is it's very close to the operating room. So on Fridays I was still doing cases while doing the lab, and sometimes I would finish a case with Ugo, start to go towards the OR, and still wearing the sunglasses, the 3D glasses. So people thought I was kind of a fancy surgeon, because you keep going back and forth and very easily adapt from one to the other.
Yeah. So this is how it looks. So you can see the patient is right there. I'm operating. I'm doing this left bottom up TAR. As you can see, the position of my hands is very ergonomic. No weird position of the hands. And also, since this is an open console, I can see whatever is happening in the OR. So this is very good, because I like it a lot, because I have full control of the OR.
You are in the action, you can see everything happens. And I think it's another way to speed up the learning curve, because you can really immediately see, as soon as you have a collision or a limitation or a problem, you can immediately glance at the movement of the arms. You can control and make some movements of the instruments and glance at the arm response. So you can learn very quickly how to fix problems with the system.
Yeah. So just to show you again, where in this case we did the closure of the visceral sac with a 3-0 lock. So this is the diaphragm here, diaphragm in the, this is left side, pars abdominalis of the diaphragm, rectus muscle, xiphoid there. So we did a very nice and high dissection of the preperitoneal space. And so reach is not a problem, to be honest. And we did it from the bottom down and from the bottom up and top down. And we did a closure of the visceral sac, so we have a very big space for a big piece of mesh. So I'm going to skip this part. Then we do the closure of the linea alba. Again, sorry, can you tap the video, please? Okay. So again, this is the xiphoid here. So we're going from the xiphoid to the pelvis with the instruments, and we achieve the closure of the hernia. Maybe you can do.
Keep it.
Okay. Yeah. So at the beginning, I didn't feel very comfortable doing this part, because I cut a lot of threads doing this. But it's just a thing of technique that we are learning. I think I've done several cases, but I still think that I'm in my learning curve. And in Chile, we don't have a 45 centimeters V-lock, so it's annoying because you have to use 4 or 5 threads in order to close the full.
You develop with time some tricks. You grab the suture when you pull on the suture in the same direction of the needle driver, for instance, because the needle driver is very, very strong, so it's not difficult to break the sutures, but you pull it in a way that the suture can slip off the needle driver rather than breaking it, right? So those are all little tricks that you can develop to reduce the breaking sutures. You can pull without grabbing, without holding the needle. You never pull the suture while holding the needle. So all these little tricks help simplifying things.
Yeah, and I have my assistant cutting the threads from the other side, and
yes.
I grab him with the bipolar and take them, because it's...
I always say when I do it from the bedside helping a fellow, I immediately say I'm not drunk, right?
Yeah. So, yeah. So in summary, I told you before that I did a lot of cases by laparoscopic surgery, but currently Hugo has allowed me to do a smooth transition from laparoscopic to robotic, and find it, I can do more complex cases with the robotic platform rather than laparoscopic. And now I'm doing most of my practice in hernia surgery, except for 15 to 20 centimeters, and I just go open. But I don't do laparoscopic surgery anymore, because I know that I'm doing a better surgery with the Hugo rather than laparoscopic. So that was my decision, and there's no way back. to laparoscopy for ventral hernias at least.
Absolutely.
And you work with the Hugo, so you know that we are still learning the capabilities of the platform. We're just learning what we can do with the Hugo. We have done different cases. We have done hiatus hernia, gastrectomies, oncological gastrectomies, esophageal resections. We have done a lot of cases, and at the end of the cases, we say, okay, we can do this. I mean, it's crazy.
Yeah. I will say this. Let's give him a big applause, and then we continue with the questions.
Okay.
Have a glass of water because you have been standing and talking non-stop. We give you a second, and I don't know if there are any questions from the audience. One thing that I will want you to talk about is your learning pathway to get here, because a lot of people is interested in these techniques, and of course, it's not an easy pathway. So I know you were already an expert in laparoscopy, but what do you think will be the right sequence of steps to get there?
Well, it depends absolutely on your background. If you have a previous experience doing laparoscopic cases, complex laparoscopic cases, what you have to do is to learn how to use the robot, and after that you can move on. Because if you know the anatomy, you can control the anatomy. That is what Mike Rosen says, right? So, but it is different if you're learning to operate and also you're learning to use the robot. You have to go from simple to more complex, and probably a good idea is to start with the inguinals, then probably ventral hypom plus, then probably TAPP. In my opinion, the transabdominal TAR is easier than the ETEP TAR, because creating the space in the retrorectus space is difficult at the beginning. So probably transabdominal TAR and then the ETEP cases, my opinion. But I guess that's a good learning curve.
Do you have any other different ideas from the audience? I think everyone agrees. I think it's the most reasonable.
I'm happy you all agree.
Yeah. The most reasonable way to do it. And what about the training with Hugo? How was your pathway from going from laparoscopy to be competent with Hugo? What was the steps?
We did a lot of mimics simulation, many hours. After that, we had a dry lab, moving pieces from one side to the other and improving times. And, because what is important to understand when you're starting robotic surgery is that clutching is a key step when using the handle. Sometimes in the beginning, you were operating like something like this, and that's not good. And I always say to my fellows that if you're in this position, you are not doing fine. So clutching is key to understand and to do a good surgery with the robotic platforms. So we went to mimics, dry lab, wet lab with tissues. There was a chicken leg doing dissection of the veins and the nerves and everything. And after that, we had 2 cadaver labs, and we did the docking process. We did the dissection of the abdominal wall, and after that we did 6 cases of inguinals. And after those cases, we felt that we were confident using the platform. So also in my country, doing robotic surgery is more expensive. It's more expensive. Most patients take like 2K out of the pocket. So if you're gonna use it, you have to make it worth. So we went to complex cases again because we knew the procedure and we were confident with the use of the robot. So we moved straight forward to TAR procedures. Yeah.
This is also a sign of the quality of the training that you received, because that enabled you to feel comfortable engaging with complex things. And I think it's a very responsible way the company is performing these steps, because you don't see 2 cadaver labs, dry labs. All these activities are not frequently done for other type of training. So I think there is a lot of value there as well.
And we have also people from Medtronic in the ward always. So if there is any problem or something that you don't understand about the robot, you have the technician there. So it's a very good to have them in the ward every single case.
Able to help. Do you have often problems with the system, errors, reboots, or anything like that?
I just would say that Hugo has a lot of alarms that's safety features, but sometimes you have a beep, 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 beep in the wire, so it's kind of, maybe the volume is too high, but.
So you would like to change the sound?
Yeah.
Some feedback we'll give to the company. No, I agree that sometimes.
But you know what? When you understand that those are safety features, you said that, because the most important thing here is safety of the patients, right? So at some point when you start doing robotic surgery, you say, okay, I'm kind of experimentation on the patients, so you have to feel confident that the robot you're using, which by the way was new at that moment, is good enough, is safe, and you can do a good procedure to the patient.
And you always are in control again, because you can immediately see what's wrong when you have an alarm going off, and oftentimes you can see how to overcome the problem from that. I call it the Harley-Davidson position, because you are sitting very comfortably. There are some surgeons were even using some gaming chairs with Hugo console, because you are sitting very, very comfortably. As opposed to, I'm Italian, I shouldn't say this, but to more like a Ducati position where you're leaning forward. You go fast maybe for a little bit, but then you get tired, right? So that's
it's like a Harley Davidson.
This is the Harley Davidson, yeah. It's much more comfortable. And I've seen people doing surgery with their legs crossed. I trained some surgeons, and one from Japan came and started to do a right colectomy on a cadaver using only 1 foot, and the other leg was crossed, and just 1 foot to control the energy. So it's a different level of comfort, for sure. And also for these cases that are longer, in general, I think also your comfort at the end of the case, as you mentioned, is different. You're still not fresh.
Yeah, when I was doing these cases by laparoscopy, I had weeks with 2 or 3 cases, and the Friday was terrible for my shoulders. Currently, it's just 1 week, working week.
Yeah,
no problem. Yeah.
And often for these cases, but some other application, hepatobiliary, I'm thinking at other situation where you have to do a lot of dissection in a very uncomfortable position, and then it's time to do the reconstruction, suturing, and having to deal with sutures, sometimes very fine sutures, becomes very challenging, right? Because your hands are tired, your arms are tired. So that's an advantage of this extreme comfort that is not only in the long term, but also in the short term as a benefit for the patient.
Yeah, when I do gastric bypass, laparoscopic gastric bypass, I do the gastroionostomy with the linear stapler, but with the robot I do it hand-sewn, because it's so nice to suture and it's very comfortable and it's even faster.
Yeah. So you use it also for some other bariatric cases. Do you have any tricks or any advice on how to control costs? Let's talk a little bit about costs.
This is, of course, this is cheaper than the other company that we have in our institution. I mean, the cost of a Hugo case is a third, 66% cheaper in robotic supplies compared to Da Vinci. So its cost is absolutely lower with the Hugo. So it's a good question, because sometimes you have to decide what platform would you use. And for a procedure like this, then you can perfectly do with the Hugo or Da Vinci. Of course, some patients can afford better a procedure that is cheaper, right?
That's an impressive difference.
Yeah.
I was not aware of such a big difference.
Yeah, it's a big difference.
Have you used the ligature yet?
We tried yesterday.
Okay.
So we're having a gastric bypass in 2 weeks.
Okay, because
and my boss has a gastric cancer next week, something like that.
Okay,
So he's happy.
I was going to ask you exactly about these applications for the. We were talking about the ligature that is straight, right? But again, you go back to the setup with Hugo that is more similar to laparoscopy. So for someone like you, for instance, that has experience in laparoscopy, you have a very similar port placement, just a better quality controls because you're sitting at the console, and the instrument is straight, but it's doing exactly the same thing you will do in laparoscopy. So you don't even feel much the need of having that wrist for the time being. So who has a straight from laparoscopy to robotic, Hugo doesn't really feel the difference at all.
But they told me that the articulated is coming soon. Anyway, they told me.
Soon is never enough, but I agree. Is going to be even better. No, I like the fact that the tip is smaller of this one, so you can really do and it's a ligature, so we don't need to say much about the quality of the technology. So really you can do things that even with the other platform are not easy to do because of the size of the instruments, of the jaws. Any question? Anybody wants to know anything in particular about this experience? I think we still have another hour and a half. No, no, we have a few more minutes. So I think it's great. And how many surgeons are using Google right now?
At my institution, we have three. We have digestive surgery department. Okay, we have four, and there are 6 or 7 urologists, like 4 gynecologists, and that's it.
So it's a big number, and you're having enough space for everyone. And
yes. I have Wednesday is my day, so I can use whatever I want on Wednesday.
All day is
all
yours.
Day yours.
All day is yours. Do they? Did you see any difference in the turnover time coming from a laparoscopy? This can be an interesting comparison. Does this extend your turnover time, complicates things significantly, or you don't see much difference?
Again, unfortunately, in my institution, there is always a learning curve in the anesthesiologists, in the OR team, so it takes longer. But this is just because they don't want to do a specific robotic team, because if you have a specific dedicated team to do this, it should be shorter, even than open cases. But it's just a cultural thing in my institution, so they are close-minded and they want to do a robotic dedicated team.
So it doesn't change much, because one of the things that I think is also easier is to move these carts in and out of the room. You can turn over the room a little bit faster. There is an advantage when we were doing the part of the study in the US, and we had to store this as part of the requirements for the study, to store the carts outside, and it was very easy just to move them in and out and turn over the rooms. We have we had the system in a surgery center, and we are planning, hopefully as soon as it will be clinically available, to get one in the surgery center. So we will be able to do very fast turnovers, because that's one of the characteristics of the system also, that you can move it around much more easily and more efficiently, clean the room and get ready for the following case. That's again, it's a great experience. What's next?
With the ligature, I don't know. Maybe we're going to even more complex cases. My practice is almost 40% bariatrics, 40% hernias, and after that I do 20% hiatus, gastric cancer, few cases of esophagus, because in Chile we don't have that much cases per year. But I guess that I'm going to feel more confident do it for example, a total gastrectomy with the ligature. So it's going to be easier, because at this point we have done it just with the bipolar and the scissor. And we felt that there was a little bleeding that we didn't have in laparoscopic surgery, for example, because of the sonization and the advanced energy. But with the ligature, we're going to do better. So we're going to increase our cases load.
Do you see any advantage of this quality of vision? The visualization, as I said before, is amazing. In revisional cases, for instance, do you see?
For revisional cases in bariatric surgery, it's amazing. The view that you have, the control of the anatomy, it's better than laparoscopic, for sure. No doubt about that. And also Hugo is incorporating the ICG. So we don't have that feature. We already have that, but we don't use it that much, but we have it. So ICG could be interesting in revisional cases too.
Yeah, absolutely. And I know you have your fellow here.
Yeah.
Do you work together when you do cases, or?
She has been my assistant in most of my cases, so she knows how to deal with the cards better than anyone here.
So let's ask you a question, since you're here. What do you think is the experience as a bedside assistant with Hugo? What do you see your experience with the system?
At the beginning, it was new for everyone in our institution, so maybe it was difficult. And as Nico said, every single surgery, all the other team was new. So the nurses, the scrub nurse, the anesthetist need to learn everything again. And that was a little bit difficult, but as we do more cases, we get more familiarized with the system, and that we can do more easy for all the team. Yes, but at the beginning it was not so easy.
What about the space? One of the criticisms sometimes we hear is the robots in general, and you go as well, it is the space for the assistant, for the regions, or things like that. How do you organize yourself to assist that?
You have to be very flexible and move a lot around the OR. So find the place to be more comfortable and to assist from the outside, because you have to give the needles, retrieve the needles, some cut because you cut from the outside. So you have to move a lot and adapt. Yes. No, stand up. I sit when the surgery, I know they won't need my help in a while, but I usually stand up. Yes.
One of the ways to overcome some of the space limitations is to sit down and you are comfortable, but you're still able to do work without having much interaction with the arms.
You have to move a lot. Yes. But it's fun.
Do you have any tricks to remember the angles or other things that you do from the bedside? Well, I've seen people having some silk tape where they put the angles on the system, so you know immediately which arm has which angle. Do you use any trick?
We always have Andrea on the OR, and she knows the angles. So, yeah.
So, yeah, Andrea is our reminder.
Your Medtronic specialist.
Yeah, but we always look at, because in the laparoscopic tower we have a lot of cards of the angles of every procedure, so we always take a look. But 5 minutes later, you forget about that, so Andrea is always there to.
But I want to do an experiment. If I say for the ventral hernia setup, one cart is at 270, do you remember which are the other two angles? You can say it. See, you already are good with Ugo.
You're ready to dock.
That's perfect, exactly. So it's really a matter of start thinking the Ugo way, and that becomes very, very easily. The setup for the upper quadrants is, again, very similar. You know, that's why I remember 30 and 330, because the shoulders, so it becomes very simple to integrate that.
Yeah, and the setup for the upper GI surgery is exactly the same for colitis, hiatus hernia, gastric cancer. It's just the same. But again, the angle is not that much important. You have to see how it looks, and if it looks fine, it's gonna work.
Yeah. We call that the butterfly setup, and it was done in such a way where you can really, with the same port setting and the same cart docking, you can do from a cholecystectomy, right hepatectomy, go all the other side and work on the left just by switching the camera in one port with the same location of the ports. And now you can do gastric bypass, splenectomy, stomach, Nissen. So it's very, very flexible in reaching all the quadrants because of the extended reach.
Mm-hmm.
Okay, so I don't know if we want to finish a few minutes earlier, and I think it's time to give you another applause for this great experience. Now we are curious to hear your experience in 1 year and see how many other things you have been doing.
With the ligature?
Yes, and not only the ligature, because there is the ligature, the stapler that we have been promised, a lot of things that are coming that will...
As you said, that soon is not enough.
Will be exciting. And you know, again, we all use this laparoscopically, so we know the quality of these tools and how we can trust them. So having them available on the same robotic platform, the exact same technology, is increase our level of comfort, I think. So, yeah. Thank you very much for staying, and we'll see you next time. Thank you.